I believe every one of you who is watching this video is doing absolutely good, and my dear children are happy and not sick like Papa Mr. Bean. You should see this gif. It's actually very, very funny. I found it to be very funny. Well, my dear children, most of the times in our life we have also come across situations like this, and not exactly like this, but yes, we have been sick, right? And today we are going to find the culprits behind this sickness. We are going to see what is that reason that made me sick. So my dear children, this chapter is one of my favorite chapter. The reason being that when I used to be in 12th grade, I used to feel like I am a doctor. At the end of this particular chapter, I felt that I am a doctor because I was able to get to know a lot of diseases, but obviously being a doctor is a lot more. But yeah, so I definitely think that this chapter is going to bring a lot of interesting things into your head, and yeah, you will love it. And by the way, this is your one and only Jasmine Ma'am over here with the one-shot video on human health and diseases chapter, and I have done 5 one-shots until now, and all 5 chapters are super important for whatever examination you talk about, whether it's KCET or NEET or your second PUC boards. I hope you have watched that. If not, make sure you watch it. And today you are here for one particular reason, because you wanted to complete human health and diseases. Okay, you thought that if I click on this video, I'll just check if ma'am is teaching fine, probably I'll go ahead and complete this, or probably I'll keep it for some other day. If ma'am is teaching fine, I'll come back and watch it, right? That is what your thought was. If your thought was like that, my dear children, if you like my teaching, stay here. And there's a reason I am talking about this right now. Okay, universe sometimes tries to give us a signal that here it is the right time to go ahead and do things. Probably this could be the right time for you guys to finish on the chapter. You might be knowing nothing about this chapter. It might not be clear to you at all. Okay, you might have not done even one KCET PYQ question or a second PUC board PYQ question, but here within this particular one shot, it could be long, but it covers everything. If you have watched the one shots before, you might know all of it, right? Not even a single thing is being left behind, and I promise you that. Yes, I promise that you're gonna get the best marks in your boards, the best marks in your KCET, and if at all you're writing NEET also, this could be helpful for you. It gives you 11 marks in your board examination. There'll be 3 one-marker questions, probably 2 of them will be MCQ, and 1 of them will be fill in the blank space question. There will be 1 3-marker question and 1 5-marker question from this chapter. If we grab all of it, we get 11 marks, and we will be grabbing all of it. And by the way, if you talk about KCET questions per year, so 2020 it was 4, then it was 5, then it is 4, then from these years that are there in 2026 also, there were 3 questions that had come from this particular chapter. So it's a very good weighted chapter, and we should be ideally covering it up. So are we ready? I hope we are ready, and if at all, my dear children, you are ready, make sure you hit the subscribe button if you have not, and make sure you listen to me very, very carefully. Me and you are going to complete the human health and diseases chapter together. Alone is not fun. Together is really, really fun. Okay, so first of all, concept number 1 is infectious diseases. What do you mean by infectious diseases? Ma'am, I do not know about all of it. First, talk about diseases. No. So, disease. When do you say that you are diseased or I am diseased? Okay, ma'am, when basically anything in my body is affected, it shows some symptoms and signs, and that's when I say that I am diseased, right? Exactly. So what do you mean by disease? When the function of either probably an organ or a system is affected, and when it is getting affected, okay, when you are being affected, you show symptoms, right? When you are, suppose you are not happy inside, you show symptoms of being angry. Similarly over here, our organs and basically our system, when it is being affected, it is going to show some signs and symptoms. Together I'm going to call this as what? Diseases. And these diseases are actually of 2 different types. Okay, 2 different types. One is basically infectious, and the other one is non-infectious. For example, this is a Jasmine Ma'am, and this is you. Okay, and now over here I did something like this. Hello. When that happens, if you have seen the flow, everything is on my hand. Now I give that hand to you. I know it's a very bad thing, right? Don't give me shake hand back, okay? Whenever we do that, sometimes, if at all, this disease that we're talking about is infectious, could be transmitted to someone else. These type of diseases which can transmit from person to person is known as what? Infectious diseases. Now it can be through achoo, it can be through different routes as well. It can be through blood, okay, it can be through other fluids of our body. For example, let's say pneumonia. Okay, pneumonia is a disease that affects our lungs, and that obviously leads us to go like this. Or common cold. So one person sneezes, the next day next person will be sneezing. Why? Because it's an infectious disease. Now we can talk about AIDS also. AIDS is also infectious. No, it is not transmitted by a shake hand and things like that, but it can be transmitted through fluids. Can it be transmitted from person to person? Yes. So it is an infectious disease. What about cancer? What about cancer? If X person over here has cancer, will that person transmit their disease to me? No. It's not an infectious disease. It cannot be transmitted like that. It's not contagious at all. So they are going to be what? Non-infectious diseases. So we have infectious diseases which can be spread from one person to another, and we have non-infectious diseases. And the first part of chapter, we are going to deal with them first. Okay, we are going to deal with infectious diseases first, and over here AIDS we are going to talk about it a bit late. Okay, before that we are going to have a whole idea of what exactly is happening inside our body, and then slowly we are going to shift to AIDS. I hope this is clear. So what is disease? Ma'am, when either an organ or probably a system in my body is being affected, it shows some signs and symptoms. Together I call that it's a disease, right? It can be infectious if it's transmitted from person to person. It is non-infectious if it's basically not getting transmitted. For example, cancer. Okay, now out of blue, I'm going to talk about one thing which you have to remember, because it can be a PYQ somehow. It has not come in your KCET and all, but still just telling you, because it's there in our NCERT, we should be knowing it. Discovery of blood circulation was done by William Harvey. Okay, discovery of blood circulation. Why are we talking about that over here? Listen. In our body, when something gets inside, it's there in our blood. It's going to travel through our blood. Right, in our blood there are good guys also, security men watching over that, hey, if anyone bad comes, I will be. So when I say that disease is happening, my body reacts to it. There's a lot of things that is happening in my body. So obviously I have to study about my blood circulation and things like that. If I'm not aware of that, basically I will not have an idea that how can we treat the disease, or what is exactly happening inside our body. You get it? So that is why it's important for you to know about blood circulation. And who gave it? It was William Harvey who gave it. William Harvey gave away. Okay, William Harvey gave away to understanding of blood circulation. Just have that tiny little thing here in one corner of your brain. That's enough. That's more than enough. Okay, let's go ahead now. So we are going to talk about the first disease which is there, which is known as typhoid. And over here, before going ahead with anything, there is a news article that had come about a lady whose name was Typhoid Mary. Ma'am, someone's name can be Typhoid Mary? Typhoid is a disease, right? So listen to me. Her actual name was Mary Mallon, and she was a cook at a very nice place, a royal place is what I assume. Now, the thing is, she had a disease which was known as typhoid. Okay, and she used to be a cook. She used to cook food, and you cook food with the help of what? Your hands. But somehow, Mary Mallon was not too hygienic. Yes, she used to go to washroom but didn't used to wash her hands. And with the same hand she used to cook food. I know that's actually very, very gross. But this is such something that could have happened. And that was the reason why everyone who were having food that was made by her were getting sick. It was a common thing that was seen. People were like curious, how can everyone have the same type of disease out there? So they went in to explore, and they found out that this lady is the one who is transmitting it. Okay, so you do not know exactly how it is being passed without washing my hands, how is it passed and all. You do not know about that, but you know one thing for sure, that it's an infectious disease. It is being passed from person to person, right? We just need to find the root of it. Okay, now if you look closely in this particular scenario, what is exactly happening over here? She goes to washroom, okay, to basically remove her undigested food, that is excreta, outside. Now, she comes outside the washroom without washing her hands. Basically, there are chances that her hand could be contaminated with some fecus, as an excreta. Okay, with some fecus out there. There are chances for that. I know it's gross, but listen to me. This is something that can actually happen to everyone. You all go have pani puri and all, right? I know you are thinking that, but listen to me. And I know you are like, oh my God, what is ma'am saying? But this is the actual scenario. Why do people say that you should not be having food from outside? especially if it's not too hygienic. The reason is the same. And why do people say we get typhoid when we have food from outside? The reason is the same, because of this contamination. Now the fecus could be in the hand. Now this contamination travels through basically the food and through food inside the mouth. You call this as feco-oral route. You call this as feco as in fecus, oral as in mouth, oral route. It can be passed through contaminated water also. Okay, if the water is contaminated, it can also basically transmit the disease. To have a better idea about all of it, let's go back to what exactly is typhoid and what are the symptoms, how is it caused, and blah, 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 blah. Okay, so first of all, there are multiple type of organism that causes diseases. The first type of organism that we have is bacteria. Okay, and we're going to talk about the bacterial diseases first. Different examples are there. The first example of bacterial disease is what? Typhoid. It is caused by a bacteria whose name is Salmonella typhi. What do you call it? You call this as Salmonella typhi. Ma'am, should we write it like this? No, never write it like this. Write it like this. Salmonella typhi, as in it should be coming Salmonella typhi. Here you see small letter, here you see capital letter, and underline it. My dear children, please do underline it. Okay, Salmonella typhi, which is there, is a bacterium, and that causes typhoid fever, or basically the disease that is typhoid. How is it transmitted? It is transmitted through contaminated food and water. When we get contaminated food and water, so this bacteria basically is there in the water, is there in our face. Suppose it's there in our body. Okay, suppose someone cooked something for me and basically I ate it. Now it's there in my body, it's dividing itself, it's increasing its number. Now, basically, when the undigested food goes out, again, that goes out of my body. But still something will be there, but it will be moving out also. Suppose this particular thing now goes to the sewage system and things like that. If the sewage is not being properly treated and that water goes to some other places out there, what is going to happen? That water people are going to utilize for cooking food, probably drinking and things like that. Now it's there, the contamination is there in the water. Again, that person drinks it. What happens? It goes on, it goes on, it goes on. You get it? So contaminated food and water is something that causes typhoid. And what exactly happens after getting inside our body? Where does it go? It says that, yeah, finally I am inside my body. Let's target the small intestine, because small intestine is a place where every food comes and basically is getting digested, right? The same reason, you can just imagine, okay, just imagine like that. It's running behind the food and coming to this small intestine. The reason I am talking about this with so much exaggeration is because, my dear children, this is just the start of the chapter. We are going to study a lot of different diseases, lot of different places being affected, and there are chances that my dear children can forget things. So always remember things with excitement. It's not overacting. Definitely do not think like that. It's just that I want you guys to concentrate. I want your attention right over here. So small intestine is being affected, right? The small intestine, and then it can travel through blood. Okay, it can go to your blood also. From the blood only it came, but again not from the blood, basically through the food and water it came. But now when it is in small intestine, it can go to the blood, it can go to other organs as well. Okay, but the major organ that is being affected is going to be your intestine, your small intestine, not the large one, small one. Okay, now symptoms: high fever. Arey baba, any infection is there, high fever will be definitely there, right? High fever as in 39 to 40 degrees Celsius. This is important. 39 to 40 degrees Celsius fever is going to be there. Apart from that, if you have fever, don't you have weakness? Yes, I have so much weakness, I cannot even move my body, right? So we will say weakness is there. Arey baba, they are coming and affecting your small intestine, so anything related to that, close to that, is also going to be in pain. So you will be having stomach pain, because stomach is very close to our intestine. Yes, and basically it is affecting your intestine, so there are chances that it could be constipation. Okay, there are chances that you would be constipated, nothing is going out, ma'am. Okay, so constipation could also be there. And finally, or you can think like constipation is there, nothing is going out, that's why you have stomach pain. Think like that also. It's either way possible. Finally, if you have fever, you have headache, and everything, nothing is going out. How do you feel to eat food? Obviously there is going to be loss of appetite. If possible, try to remember the symptoms, link between them. Okay, link between them and try to remember. That's the best way to remember, otherwise we might forget it. As I said, so many things are there. I'm not here to scare you, I'm just telling you, I'm just giving you a heads up that yes, this is important, we have to keep it in our head, right? Yes. Okay, so what all will be symptoms? High fever. Because of high fever, headache. Because of headache, weakness. Okay, because of headache, weakness. Then nothing is going out, constipation. Because of constipation, stomach pain. Because of that, basically loss of appetite also. I'm not able to eat food. Done. That's all. Simple. Right? Now come back. Severe cases. Severe cases as in basically when a person is very much affected from basically when it moves from your small intestine to other parts of your body, it becomes a severe case. Right? So first of all, in severe cases, it can lead to intestinal perforation. For example, suppose this is your intestine, there will be small holes through it. It can perforate. It can perforate and basically move out. And it can also lead to death. It can also lead to death. Cool, that is the thing. But that's a severe case. So your question comes, what is the symptoms? In typhoid, the severe case leads to intestinal perforation and death. Is that true? Yes, it can. Cool, yes. Now diagnosis, this is very important. How do you diagnose whether someone has typhoid? Vidal test. Okay. There is a test over here. What do you call this as? Vidal test. Vidal test. Okay, Vidal test. There are two diseases in your entire NCERT about which, where you're talking about the way to diagnose the disease. One is going to be typhoid, another one is going to be AIDS. Okay, cancer is also there. That's the whole thing, a whole different thing. I'm talking about infectious disease. You have Vidal test for typhoid. Please do remember it. Okay, the typhoid Mary, a cook who unknowingly spread typhoid for years. Now I'll tell you, if at all it is there in your head that ma'am, if she had the disease, then how did she pass the disease throughout so many years? She might be a patient who might have the severe form of typhoid, right? For years she's having the disease. But no, the reason being that, listen to me very carefully, she was a carrier. Yes, sometimes a person can be asymptomatic, as in they might not show the symptoms, they can be just the carriers, they can transmit it to others. Their body might have developed some resistance to it. Somehow the bacteria is not able to do its function, but obviously it is able to transmit itself. That is what was happening. So this Mary Mallon, because of the same reason, became what? Typhoid Mary. So this is the story of Mary Mallon, and if at all you want, you can go and probably search more about it. She worked in a royal family or things like that as a cook and things like that. But yes, you can do your own research. That will be a fun part of the day that you can go and explore. Okay, so typhoid is super clear. If at all we just want to have a thing of typhoid, how do we do it? So what do we do? Forget everything. Let's begin. Typhoid is a bacterial disease. Yes, ma'am. Which bacteria? Salmonella typhi. Typhi has double I? No, only one I. Salmonella typhi. That's all. That's all. Okay, ma'am. How does it transmit? Through contaminated food and water. Through contaminated food and water. Where does it go? Small intestine. Small intestine is usually being affected, but it can go to your blood and other organs as well. Done. Done. Okay, ma'am. What are the symptoms? Severe cases you're asking? No, normal symptoms. Normal symptom, high fever. Okay, because of that headache, because of that weakness, and then you have constipation because of that stomach ache, and finally loss of appetite also. But in severe cases, it can lead to intestinal perforation, holes in your intestine, and can lead to death also. Okay. Ma'am, is there a way I can diagnose it? Yes, Vidal test. What do we have? Vidal test. Example of a person who probably was carrying the disease, typhoid Mary. Done. Mary Mallon is her name. Okay, Mary Mallon is her name. This is the only thing that you need to know, and I hope it's super clear. Everyone who feels that yes, it's super clear, can you give me a quick thumbs up? And also, children, do not forget to hit the like button, because you know what? Every time someone comes and put a comment that ma'am, the teaching was so good, okay, or probably I loved the class, I feel so motivated, and plus this is my favorite chapter, so I'm trying to put a little more energy into it. So I hope it really works out well for you and you remember it. Yes. Okay, let's go ahead with the next thing, that is pneumonia. So next bacterial disease that we have over here is pneumonia. And how is pneumonia going to be caused? Again through bacteria only. Because that is why you call it as bacterial disease. There are two bacteria causing it. Okay, there can be two bacteria that is causing it. But before I go ahead with that, I want to tell you that it's not like pneumonia can only be bacterial. It can be caused by viruses also. For example, I am the living example of a person who had got viral pneumonia, and it was the start of COVID. Okay, at that time the COVID was just starting off. I remember I was kind of the first patient to show all the symptoms of COVID. I do not know whether it was COVID or the doctors are not able to diagnose it then because no one was aware of it. Okay, the day I discharged, that's when India reported the first case of COVID. So I went to Manali trip, and when I came back, okay, I used to travel in some junk packed places and things like that, in buses and all. So probably from there I got the disease. Then I had it. I had got the symptoms like fever, and then I was breathless. I was about to die. Okay, yes, I was actually about to die. It was a very scary experience that I had, and basically that was a viral form of pneumonia. So what exactly happens in pneumonia? Let's look closely into it and let's understand. So that if you are seeing the symptoms, probably you can also go and have a timely checkup. In my case, we were not aware that I could be having something like this, okay, because it was a few days. I mean, it was already some days since I came back, and I was resting. I was having a good, peaceful life. So yes, let's go ahead and talk about the bacterial pneumonia which is there. So it can be caused by two organisms, Streptococcus pneumoniae and Haemophilus influenzae. What is it? It is Streptococcus. If at all you remember, this was the organism that was used by Griffith for his experiments. Okay, Frederick Griffith for his transforming principle experiment. He put this inside the mice puchu, remember? Okay, so it was Streptococcus pneumoniae, or it could be Haemophilus. It could be Haemophilus influenzae. So Streptococcus pneumoniae and Haemophilus influenzae, these are the two organisms, bacteria, which are there that causes what? Pneumonia. Okay, now over here, what exactly is going to happen? So pneumonia is a disease that is going to affect your lower respiratory tract. Lower respiratory, this is upper respiratory, your nose and everything. This is your lower respiratory, as in your lungs and everything. Okay, what is exactly going to happen over here is that, you know, in our lungs, if at all we see our lungs over here, okay, it has bronchi, then you have bronchioles, the branches are known as bronchioles. At the end, you have some sac-like structures like this. What do you call these sac-like structures? You call them as alveoli. You call them as alveoli. Whenever we breathe in, okay, just imagine, whenever I breathe in, okay, all the oxygen and every gas which is there, it goes and gets filled up in this particular alveoli. Now when it is being filled up over here, what is going to happen? Just beside the alveoli, it is richly supplied with so many blood vessels. It is richly supplied with blood vessels. So what happens? The oxygen which is there in my alveoli is now going to move into the blood vessels, and the blood vessels are going to carry this oxygen throughout my body wherever the oxygen is needed. Oxygen is very important for the process of respiration to happen, for our body to work smoothly, right? Yes. So that is how it usually works. Now think about the next scenario. Suppose instead of having gases over here, okay, you have something else, that is fluid being filled. Fluid is being filled because of some infection that is happening in your body. You have fluid being filled. Do you think the gas exchange can take place smoothly? No. Now if that is not happening, our body is deficient. Our cells are like crying for, where is oxygen? I do not have oxygen. Without oxygen, we cannot function. Why? Baba, oxygen which is there is required for the breakdown of glucose. That is what you call as respiration, right? And when this glucose breakdown, finally you are going to get ATP, energy, and with that energy our whole body is going to work. Now our body could survive. What about our brain? Our brain can never survive without too much amount of oxygen. Our brain needs oxygen. Our brain definitely needs oxygen. So there is going to be what? If my body's lungs is filled with fluid over here, filled with mucus over here, what is going to happen? I will be having breathing problems. And not just that. Okay, when something is there, you might have seen when we choke, what do? We go like that. Do you do it voluntarily, or it happens naturally also? We do it voluntarily later, but initially it happens very naturally. That's our body's defense mechanism. So my dear children, here in this particular case also, we wanted to just come out. That particular mucus which is there, we wanted to come out, which is exactly why we will be having symptoms that includes coughing. Okay, now our body is not getting enough amount of oxygen. Our body is under code red mode. Obviously in this case, again you have fever. again you have fever, and again you have headache. Because of fever, headache will be there. Listen to me. And one more thing comes up, and that is chills. Why? Because the fever is going to be uncontrollable. My fever went up to 105 degrees. Yes. Okay, and it was very, very bad situation. You could not even think. I started seeing people differently. Okay, in front of me someone else was sitting. I used to think someone else is there. So that situation even happens. So there is fever, there is chills, there is cough, there is headache. You do not have to remember it, as I said, in a way that this is for pneumonia. Just understand it and try to recall it. This our body tries to put it out. That is why we cough, and while we cough and all, obviously we have weakness, we have tiredness, and apart from that, since we are in a very bad situation, code red is happening inside our body, we have fever. Because of fever we have headache, and apart from that we have chills also because of the same fever. Now in extreme cases, in severe cases, just like how we had severe cases there where it lead to intestinal perforation and all, here also we have severe cases where your lips as well as your nails, lips and nails turn blue in color. Just imagine everyone, me with blue lips as well as nails. Just imagine, have that in your head. That is what you need to write in your examination. Okay, lips and nails turn bluish gray in color. That is a symptom that we have. That is a severe case symptom that we have. Okay, now how it is transmitted, as I told you. Achhi, suppose achhi in my hand, and then my hand goes to someone else. Or probably achhi, today I'm going to use the AC remote. Some other teacher comes and use the same AC remote and probably comes in contact like this and this and this. So don't worry, this is my, this studio is reserved for me, so no one is going to get contaminated, but I'll clean also. Okay, just demonstration. So similarly, if I share utensils, if I share certain things, or probably I'm not putting my hand covering my nose and face while sneezing, the droplets are all around, and it's a droplet infection. That means it can be passed because of infected droplets. In these droplets you have so many contaminants, the organisms, and basically it can be passed very, very easily. So inhalation of infected droplets or sharing utensils with an infected person can lead to what? Transmission of pneumonia. And probably I was there in the bus, and that is how I might have got it. Okay, so it is very much recommended and all, to make sure that we continuously wash our hands, wash our face and all. It will be really good. Okay, anyways, so what has to happen will definitely happen, but precaution is better than cure. Yeah. Okay, so we have Streptococcus pneumoniae and we have Haemophilus influenzae. Let's discuss about all of them in general together. So this is the second bacterial disease that we were talking about. It is pneumonia. How is pneumonia being transmitted? Pneumonia is transmitted because of two different bacteria, ma'am. It is Streptococcus pneumoniae, the Griffith experiment 1, and it is Haemophilus influenzae. Yes. Okay. Now, Baba, what is going to be affected? Your lower respiratory tract, as in your lungs and everything, is affected, especially your alveoli. Your alveoli is going to be filled with fluid, or basically mucus, which is why you are going to develop breathing issues. Okay. Yes. Now, what are the symptoms? Breathing issues is there, definitely. Apart from that, what issues are there? You're going to cough. Okay, you're going to cough, you're going to have fever, you're going to have headache, you're going to have chills. And in severe cases, your lips as well as nails might turn bluish gray in color. Done. Now, how it is transmitted? It's a droplet infection. Basically, infected droplets can travel through, and anyone who inhales it, okay, can get it. Or probably if I share some utensils with an infected person, I can get it, or you can get it. That is how it works. Done. Always remember, pneumonia affects your lower respiratory tract, not the upper one. There is something that I'm going to talk about very, very soon, and which is why I'm reserving your energy, saying that it's upper, not lower. It's lower, not upper over here in the case of pneumonia. Done, ma'am. That's also clear. Now, one very important thing before I go ahead with anything else. So we assume that bacterial diseases are only two, because only 2 is given in your NCERT explanation wise, but actually no. In your NCERT, in the last line, okay, if you check out the last lines of pneumonia, you will be able to see something like this. Other bacterial diseases are also there. You have 3 of them: DPD, okay. Dysentery is where your undigested food moves out. You call this as stool, right? Along with your stool, you might have blood and mucus. This is known as dysentery. So dysentery is one such thing, okay. there are different type of dysentery. This is the plain dysentery I'm talking about. Different type of dysentery can be caused by different organisms. I'm telling again, this is just a plain dysentery situation. Okay. Apart from that, plague. Apart from that, diphtheria. So dysentery, plague, and diphtheria are also bacterial diseases which are mentioned in your NCERT. Similarly, cholera. Cholera is also a bacterial disease, not given in NCERT, but it's almost similar to typhoid, which is there. Okay, so what is there? Diphtheria, dysentery, and plague. Dysentery, plague, and diphtheria. Whatever way you want to remember, you can. In total, we have 5 of them now. Bacterial disease: typhoid, pneumonia, and then we have dysentery, plague, and diphtheria. Sorted, ma'am. Okay, perfect. Now we go to the next sort of diseases, which are viral diseases, which is caused by viruses. And here the first one that we have over here. Why is a mosquito over here? Yes. Okay, we'll talk about the mosquito. Okay, we'll talk about it later. Okay, but before that, let's talk about the viral disease that is given in your NCERT in detail, and that is common cold. I am going to tell something which is very important. Common cold affects your upper respiratory disorder, upper respiratory tract. Common cold which is there, it affects your upper respiratory tract. What do you mean by that? Your nose, your throat, everything is going to be affected. It does not affect your lower respiratory system. Always understand that. Okay, so when we say we have sore throat, okay, when we say we have nasal congestion and things like that, mostly it could be what? Common cold. It could be just common cold because it is going to affect your, as I said, upper respiratory system, but not the lower one. And that's a major difference that we have between pneumonia and common cold. Cool? Yes, and I'm going to show you so many questions around it because they literally have given so many questions around it. Okay, so the first thing, who causes it? It's a group of virus. Okay, it can be anyone who belongs to that group. It's known as rhinoviruses. Rhinovirus is not a virus, it's a group of virus. Okay, you call this as basically a common term. That's what you give to these viruses. You call them as rhinoviruses. They're the one that causes common cold. Rhinoviruses causes common cold. What do you have over here as symptom? Nasal congestion. Nasal means this is your nasal tract. So nasal congestion as in this. Okay, you get congested. Sore throat. Again cough, again what do you have? Headache and tiredness. This usually lasts for 3 to 7 days. So this we have noticed that what if someone gets cold, it will be almost there for a week's time. 3 to 7 days is fixed. Okay, whatever medicine you have, it might be there. The reason being that, I'll tell you, viruses which are there, no, they are very crooked organism. You know, you might have heard of that term, dalbadlu and things like that. Basically, they just change themselves very, very quick. Okay, they are able to change that. They are able to mutate really, really fast. The genetic material is not going to remain the same. So today, Jasmine Ma'am, a scientist, made a, drug against these viruses. Tomorrow, these viruses do their entire body change and they basically come up with a new form. Like, ta-da, I am again here to cause the disease that is common cold, which is why we generally do not have a drug which is going to effectively treat common cold or prevent us from getting the common cold and things like that. If at all you get a cold, probably it might be there for 3 to 7 days. That's a general thing that is there. After that, it will go. Our body will fight. Our body will fight. Our body will fight, and our body will basically kill and remove all of it. Cool. Infection area, nose and respiratory passage only. Not the lungs. Why not the lungs? Because that is lower respiratory system. This is the upper respiratory system. So your nose as well as the respiratory passage, as in what your trachea and all, could be affected. But not this, but not the lungs. Transmission, same way only. Transmission of infected droplets or contaminated objects such as pen, book, cups, doorknobs, keyboard. That is why if one person have it in your school or basically a college, everyone has it because it's an infectious disease. Cool. That is about rhinoviruses and that is about common cold. So let's just have a quick recap and then we'll go ahead and talk more about it. So common cold is the first disease, viral disease that we have. It's caused by a group of viruses. Basically anyone can be coming from that group. It's known as rhinoviruses. They are known as rhinovirus. Right. Well, the second thing that we have over here is going to be what? Basically, what are the symptoms that you have over here? The symptoms that you can have over here is going to be nasal congestion, sore throat, cough, and then fever and tiredness, which could last almost for 3 to 7 days. Done. That's all. How it is transmitted? Same, droplet infection only. Same way how pneumonia is being transmitted, this can also be transmitted. But the place is different. The place of effect is different. It affects your nasal, nose, or basically the upper respiratory tract, but not the lower one. Got it. That's all. Okay, that's all. Now in your NCERT, there are 2 more diseases which are given. Okay, 2 more diseases which are given. One is dengue and the other one is chikungunya. Okay, chikungunya. So we have dengue and chikungunya. We say that they are also viral disease. Yes, they are viral diseases, but they are transmitted through mosquito. Okay, so I already know that all of you are thinking of malaria right now. Malaria is not caused by a virus. It's some other organism put all together. We spoke about bacteria. Right now we're talking about virus, okay, viral diseases. So dengue and chikungunya are actually caused by virus, but this virus has been transmitted from one person to another with the help of a mosquito that is known as Aedes mosquito. What do you call it? Aedes. Okay, it is Aedes mosquito that we have that causes what? Dengue and chikungunya. Dengue and chikungunya is basically transmitted by Aedes. Transmitted, not caused. Caused is causative organism is what? Is going to be a virus only. Always remember it. Okay, ma'am. Okay, so I come to you saying that I have dengue. What is it? Is it a viral disease or a bacterial disease? Or a mosquito-based disease? It's going to be a viral disease, okay? So which is a mosquito that transmits? Aedes mosquito. Done. That's all. That's all about the viral disease which is there. In your NCERT, there is a mention about polio also. Polio also is a viral disease, okay? Polio also is a viral disease. Okay, we'll talk about that later. But as of now, if you wish, you can just remember this. Dengue, chikungunya, as well as your common cold. If you feel polio is a bit difficult for you to remember at this point, it's okay. Just forget it. Let's just erase it from here. Okay, now, there's a question that have come in PYQ of 2023. Let's try to solve it. This is a KCET PYQ, okay? Identify the symptoms of pneumonia. Nasal congestion and discharge. Nasal, nose, upper respiratory system, no. Constipation, not that low, okay? We don't have to go that low. High fever, weakness, stomach pain, no. Difficulty in breathing, fever, chills, cough and headache, yes. This becomes your answer. This is your answer. What are the other examples of nasal congestion, discharge and sore throat and cough and all is example of what? Your common cold. Constipation, abdominal pain, cramps and blood clots we have not studied until now. It will be coming. High fever, weakness, stomach pain, loss of appetite. This is a symptom of typhoid, right? So anyway, this is the answer that you have over here, and yeah. So here I have given you the answer for A, B and C also, if at all you just want to know about it. Anyway, we will be talking about the other diseases also very soon. So this is one type of question that has come. Let's see the next type of question that have come. The symptom based question has come so many times in KCET at least, and also in your second PUC. Let's see. A doctor identifies symptoms of nasal congestion, headache, sore throat, hoarseness, cough in the patient. The conclusion is that the patient is affected by a pathogen. What is a pathogen that is being affected by? What are symptoms? Nasal congestion, nasal, nose. Just understand it has to be common cold. And common cold is caused by what? Salmonella, Plasmodium, rhinovirus, adenovirus. Rhinovirus is the other one that causes what? Common cold. And here is your answer. B is your answer for this particular question. Got it? Yes, ma'am. That's all. So these 2 questions have come from the portion that I just spoke about right now. Apart from it, obviously there are going to be some second basic question which we are going to deal very soon. Okay. Now we are going to go ahead with malaria, which is there is a protozoan disease. What do you mean by that? So Baba, all the organisms that you see in the entire world can be divided into 5 kingdoms. The first kingdom is kingdom Bonera, where you have bacteria. The second kingdom is kingdom Protista, where organisms which are known as protozoans come in. Okay, they come under Protista, kingdom Protista. Similarly, you have kingdom fungi where all the fungus comes in. Okay, the fungi organisms are going to come in. Then we have kingdom Plantae where all the plants come in. Then we have Animalia where all the animals come in. So kingdom Protista, the second kingdom which is there comes an organism whose name is what? A protozoa, or basically a group of organisms which you call as protozoan. One such protozoan that is there is known as Plasmodium. is known as what? Plasmodium. So where are we? There is kingdom Monera. There we have bacteria, such as Salmonella typhi is a bacteria. Streptococcus pneumoniae is a bacteria, and all of it. Similarly, you have kingdom Protista. Under kingdom Protista, you have a group which you call as Protozoa. Under Protozoa, okay, this is the third level. We have an organism which is known as Plasmodium. That is going to cause the disease. So, ma'am, we know that malaria is basically caused by the mosquito. Isn't that true? It's true. It's true only. It's basically mosquito has a role over here. But you know what? It is being framed. Papa guy is being framed over here. Why? Because this is not the actual one who causes the disease. This is only the one who is going to transmit it. It is the one who transmits it. Papa guy is also affected in the whole way. It is just being framed over here. So Plasmodium is the one that actually causes malaria. And the mosquito which is there, which is you call as Anopheles mosquito. Anopheles mosquito is the one who is going to transmit the disease. Always remember that. Okay? Yes. Now, I have so many things to talk about in this particular thing. But before I go ahead, I really want you guys to understand how Plasmodium affects organisms like us and the mosquito altogether. Because this is very, very crucial. So many things have come from here, and I really want you guys to understand it really well. So Plasmodium which is there, we know it's a protozoan and it causes malaria, right? Right. Now, the first thing that is going to go and affect is an organism which is a mosquito, Anopheles mosquito. Male or female? Female ones. Okay, the female ones are the ones that takes our blood. The males male mosquitoes, they feed on the plant sap and things like that. And why does the female feed our blood? Because they like it. Nice, tasty. No, it's because for reproduction purpose, for nurturing their young ones, they might need the blood meal. They might need to give them the blood meal. That is the reason. Okay, so over here, your Anopheles mosquito is the first one to get affected. It is the first one to get affected. Now, when it is there in the Anopheles mosquito, right now, suppose the Plasmodium is there in the Anopheles mosquito. Now, the Anopheles mosquito is looking for a human being. And it goes and bites us. When it goes and bites us, what is going to happen is that it is going to transmit this Plasmodium into our body. But before you go any further, let me tell you, the Plasmodium is going to have different stages. It's not like Plasmodium is an organism, it just has one stage. No, it has multiple stages. One such stage which is there is known as sporozoite. What do you call it? Sporozoite. Okay, sporozoite stage. And where is the sporozoite? Sporozoite is actually present in the salivary gland of the Anopheles mosquito. I told the Anopheles mosquito has it and it's going to transmit the disease, right? So basically over here, the Anopheles mosquito, suppose this is the Anopheles mosquito that we have. In the salivary gland of the Anopheles mosquito, you have a stage of Plasmodium which you call as sporozoite. Now, when this mosquito comes and bites us, okay, it wants the blood to come without any trouble. No clot should be there. The blood should easily come. And you know, our blood has clotting enzymes or clotting factors which makes clots, which is why it won't be able to drink very smoothly. Against these clots and all, the organism, the mosquito, usually puts in its saliva into our body, such that there is no clotting. Okay, its saliva will be having certain things that will prevent clotting and it can drink the blood very easily. So while, just imagine the scenario over here, where it is coming and biting us, injecting its little saliva over here. In the saliva, what do we have? We have sporozoite. The sporozoite now gets an opportunity to get inside our body. Now, the sporozoite, or basically the Plasmodium, is within our body, within our human body. It goes and runs to where? To the liver. The liver is going to be the first camp. They are terrorists residing in our body, and the first camp they have is where? In the liver. Your liver which is there is made up of cells. Okay, all the organs are made up of cells, but here the liver cells have a name. You call them as hepatocytes. Okay, hepatocytes, just understand it. You don't need to remember it if it tells too much for you, just understand it. Your liver cells are there, and inside the liver cells you have these organisms. Okay, you have this organism, and now when they make the camp, they think that it's time to make sure that we make our camp size even bigger. We need more terrorists out there to basically cause the issue. So they undergo, where the easiest form of increasing the number is going to be sexual reproduction or asexual. Asexual, it can undergo division. You know, plasmodium which is there undergoes multiple fission. Basically the nucleus divides so many times, and then the cell wall surrounds it. That is multiple fission. Okay, so over here you undergo, not you, basically the plasmodium undergoes what? Asexual reproduction. Now when it undergoes asexual reproduction, just understand, over here there is a cell and you have so many plasmodium being formed here inside this. There will be one time where the cell is going to burst and all this plasmodium is going to be released. Now the stage of plasmodium is going to be different. I'm not talking about the stage right now, I'm just mentioning it as plasmodium for your understanding. In which stage does it affect? That is important. We know it is going to be the sporozoite stage. In which way it is going to affect us? Okay, it affects your liver cells, go to inside your liver cells and basically undergo what? Asexual reproduction. Now the liver cells, they burst open and all the plasmodium are now out. Out where? Out inside our body, in our blood. In our blood. Now in the blood they go to the second camp. What is the second camp? RBC, red blood cells, or your erythrocytes. Now red blood cells is the place which was their actual target. Why do I say so? So for that I have to come back over here because I need some space to explain you this. Suppose this is your red blood cell. Okay, suppose this is going to be your RBC. Inside your RBC, what is there, Baba? We all know hemoglobin is there. Hemoglobin is there. What if I tell you the plasmodium was looking for this hemoglobin only? Plasmodium was actually looking for this hemoglobin only. So once they are right inside, okay, what they're going to do is that they're going to break this hemoglobin into two. Heme and globin. Heme and globin. These are the two things they break things down into. Now, when it happens, they are like, oh my god, it's affecting us. It is basically over here. You need to understand that the organism is also there. Plasmodium is also there right over here where all of this is happening. It is only the one doing it. But when it breaks down hemoglobin into heme and globin, it's like, oh my god, I'm not able to survive. Why? Because the heme is toxic for them. For these organisms, the heme is toxic. It wanted this, but somehow it is toxic. So what it does is that it converts this heme into what? Something else which you call as hemozoin. This hemozoin which is there is not toxic for them and they are pretty much happy. They actually wanted the globin. They actually wanted the globin part of it and they are happy. The heme, they converted to hemozoin. The plasmodium are really happy. No effect to me. Okay, apart from it, they are doing all this thing in your RBC. First thing is what? Breakdown of hemoglobin and conversion of heme to what? Hemozoin. They are doing it for their own good because they want to feed on the globin part of it. Okay, apart from it, they are also undergoing asexual reproduction again. Asexual reproduction again. Let's increase the number. That is also parallelly happening over here. Okay, now the same thing happens as it happened in the hepatocytes. There will be one time where RBC is not able to take over all this plasmodium. It is going to burst open. Now you just imagine the situation. It's burst open. Your hemozoin is going to be released. Hemozoin was not toxic. They made hemozoin because it was not toxic for them. But for us, it's toxic because in our body it's in the form of heme, right? Heme and globin comes together. Normal thing. Hemozoin is not something that we make. It's toxic for us. So which is why we are going to have what? Fevers and chills. Whenever this happens, when basically the cells are going to break down and the hemozoin level increases in our body, we get fevers and chills in few days, in a gap of 3 days and things like that. That's a very common feature of malaria. Okay, you get chills. All of a sudden, you started getting chills within a gap of almost 3 days and things like that. Why? Because this hemozoin is being released and that is toxic for us. Now, there was one more scenario. I told you asexual reproduction was happening over here. The cells are going to burst open. The cell is going to burst open and basically they are going to release the plasmodium. In which stage does it release the plasmodium? This is important. They release in a stage which is known as gametocyte. Gametocyte. Ma'am, until now you just told that sporozoite stage is important. Sporozoite stage, the infected stage over here was important. Now you are saying that we have to remember one more stage. Yes, these are the only two stages that you have to remember. What exactly happened over here? Listen to me. In the blood, it came to RBC. In the RBC, it undergoes asexual reproduction. RBC cell gets lysed. That means it bursts open and releases hemozoin. Because of hemozoin, what do we have? We have fevers and chills. We have fevers and chills. Apart from that, what happens? Basically, when it breaks open, gametocytes are being released. Gametocytes are released. Where are they now? In the blood. Where are they now? In the blood. What are these gametocytes? And until now, did any sexual reproduction happen in our body? Every time it happened, reproduction happened, it was asexual reproduction. And at the end of it, I have got a stage that is known as gametocyte. You know what are gametocytes? Gametocytes are the one which can later form the gametes, the male and the female gametes. They undergo sexual reproduction also. They can undergo sexual reproduction also with the help of formation of gametes. So these gametocytes later have to divide to form what? Gametes out there. And when the gametes fuse, sexual reproduction is going to happen. But will that happen in our body? No. Because our body says, whatever you want to do, you do, but don't do sexual reproduction in my body. That's the only thing that our body says. So gametocytes which are there, actually they cannot undergo sexual reproduction over here. So what exactly happens is that it's there in the blood. Now I'm a mosquito again, a female anaphysis mosquito. I come and I bite. When I bite, I take the blood. In the blood, what is there? In the blood, I have gametocytes. I have the gametocytes. Now these gametocytes get inside what? The mosquito. The mosquitoes, it goes to the mosquito's gut. Okay, suppose I am the mosquito over here. It goes inside my gut. Inside my gut, my dear children, it is going to form gametes. The gametes are going to fuse. Okay, the gametes are going to fuse. You will get something that is known as ookinete and things like that. That you do not need to know. Just understand, it goes to their gut. Why? Because food, whatever is there. For them, blood is the food. So it goes to their gut. In the gut, the gametes are going to form. They are going to fuse. Sexual reproduction is going to happen. When gametes are fusing, I say sexual reproduction, right? It is happening. At the end of sexual reproduction, what do you get? At the end of sexual reproduction, you are going to get a stage, we call it ookinete and whatever is this. Later on, they are going to divide, they are going to transform, and again you will be having sporozoite coming here in your salivary gland. That is basically what I am. I am a mosquito. Inside my salivary gland, again I have a stage that is known as sporozoite. Again I go and basically try to drink blood. I put my saliva, and along with that sporozoite get inside the body again. This is the cycle that I have. This is a cycle that I have in the case of what? Plasmodium. I'm going to repeat it. You just have to listen to me. Do not be worried about anything else. This is very, very simple. Okay, I'm just going to make it go away. Over here, I am the mosquito, and inside my salivary gland, I have sporozoite stage of Plasmodium. I come and bite an organism. When I do that, basically I put my saliva such that there is no clotting, and I can drink my blood very, very easily. Okay, drink the blood very, very easily of the human being. Now, when I put the saliva, along with the saliva, who gets inside? Sporozoite. Sporozoite, once it gets inside, it runs and gets into the liver. In the liver, in the cells of the liver, which you call as hepatocytes, or basically the liver cells, it is going to undergo asexual reproduction. It is going to increase their number. And when it does, one time it is going to burst open the cell, and now they are going to release into our blood. In the blood, where do they go? In the RBC. In the RBC, what do they have? Hemoglobin. They actually want the globin, which is why they break down the hemoglobin into heme and globin. Heme is very toxic for them, which is why they convert into something that is known as hemozoin. It's there in the RBC. Along with that, along with doing all this thing, they're again undergoing asexual reproduction out there. There will be one time that comes where your RBC is not able to take it anymore, and they're going to break open. When they break open, what is going to happen? What is being released over here? Obviously, your hemozoin is going to be released. If your hemozoin is released, it is very toxic for us human beings, which is why we get fevers and chills. Apart from that, now they have underwent asexual reproduction, which is why they're going to form a new stage, which is known as gametocyte stage. Gametocyte stage. These gametocytes is now released into the blood. Do they form gametes in our body? Do they undergo sexual reproduction in our body? What happens is there in our blood, another mosquito comes, bites, and takes it out. Now the gametocytes go to the mosquito's gut. It stays in the gut of the mosquito, forms the gametes out there, undergoes fusion, and later on forms a stage that is known as sporozoite, which again is there in the salivary gland. That's the basic logic. Okay. So entry point sporozoite, exit point gametocyte. Remember that, and no sexual reproduction in our body. Sexual reproduction only in the mosquito's body. So basically, if you have heard me carefully, you know one thing, that Papa mosquito is not just being framed. Yes, it is a carrier for the disease. It is carrying the disease out there. It's not a carrier, I'll say vector. It's a vector, same meaning itself, but yeah. But I call an organism as a vector also when basically it is being affected. So yes, it is also being affected. It is also a host. Just like we are a host for the organism to divide and increase the number and things like that, similarly it's a host. Mosquito is acting as a host for the other organism as well. Okay, mosquito is also acting as a host for Plasmodium. So Plasmodium, which is there, it has two hosts. One is mosquito and the other one is human being. Okay, mosquito and the human being. Who is the vector? Vector is the one that basically transfers it, and that is again the mosquito itself. Cool, cool. Now let's just have a quick read about all of it. So first thing, Plasmodium is the pathogen. Yes, we have three forms of Plasmodium that we're going to talk about in a second. Before that, transmission, bites of infected female Anopheles mosquito. Okay, life cycle, enters the human as sporozoite via the mosquito bite, multiplies in the liver, then attacks the RBC, causing them to rupture. Hemozoin toxin is released, causing chills and fever every 3 to 4 days. Mosquito bites the infected person, parasite reproduce within the mosquito, and new infection cycle begins. Two hosts are there, human as well as the mosquito. Anopheles is also a vector. Vector as in basically it is going to transmit the disease as well. But you have two hosts over here, both of them. Here it undergoes asexual reproduction, here it undergoes sexual reproduction. Can you try to remember it? And hemozoin is a toxic behind the chills and the fever. Never ever forget it. This is very, very important. Okay, okay. Now, the names of the organisms. So there are different species. Okay, genus remains the same, Plasmodium, but we have three different species of Plasmodium that causes different types of malaria. Okay, the most dangerous form of malaria, I'll talk about that first, is caused by something which you call as P. falciparum. Okay, P. falciparum is the one that causes the most malignant, deadly form of malaria out there. This is a usual question, which is the one that causes the deadliest form of malaria? P. falciparum. But apart from that, you have two other guys also which causes malaria, that is P. malariae. It's a very simple name, no? P. malariae, and then the other one is going to be P. vivax. P. malariae, P. falciparum, and P. vivax are the three organisms that we have that causes the disease, that is malaria. Cool. And it's a female Anopheles mosquito. Dengue and chikungunya is caused by which organism? Dengue and chikungunya, if you remember, it's basically transmitted, not caused. It's caused by virus. It's transmitted with the help of what? Aedes mosquito. Here it is Anopheles, there it is Aedes. Do you remember it? Okay. So what are the organisms that we have? P. falciparum, P. malariae, and P. vivax. Falciparum, malariae, and vivax. You will get a hold of it once you basically just put in your 100%. Okay? Okay. So this is what I wanted to tell, and one thing that I want to tell over here is, please do remember the organism's name, because straight question, 1 3-marker question you can expect coming from this topic, literally from the diseases part of it, and they usually ask you, what are the all causative organisms of the diseases? It can be malaria and the few more things organism. I'm going to talk about few more diseases which usually comes in. This is one thing that is very, very common, so you should know about it. I'm writing it again, that is why you tell me this time. P what? P. falciparum, not puram, it's falciparum. Okay, then we have P. vivax. Viva, you went to Viva. Okay, then this Viva was about malaria, so malariae. So P. falciparum, P. vivax, and then P. malariae there. These are the three organisms. This one is the most malignant one. Cool. Cool. Now, here is a picture that is given in your NCERT regarding the same, and this picture is also important. We just read about it such that we know that we have covered everything, and then we move ahead. So when the mosquito bites another human, sporozoites are injected with the bite. Sporozoites, yes, mentioned. Now, the parasite sporozoite reach the liver through the blood. Sorted. The parasite reproduces asexually in the liver cells, bursting the cell and releasing it to the blood. So basically what is happening, it is infecting the liver cells, and now the parasites are going into the blood. Parasite means any organism that is foreign to us and it's causing trouble in our body. Those are known as parasites. Okay, so now they are there in the blood. In the blood, so this is red in color, so just understand it is going to be your RBC. Now, parasites reproduce asexually in the red blood cells, bursting the red blood cells and causing the cycles of fever and symptoms. Releasing parasite infect new red blood cells. So it is going to infect what? The new RBCs out there. It is going to infect the new RBCs. Now, basically what you're going to get, sexual stages gametocytes develop in the red blood cells. So over here you see inside it. Okay, so inside it you have the sexual stage being formed, that is what? Gametocytes. That is basically gametocyte is being formed in the RBCs. Until this particular point, where you're gonna see a diagram of a hand, just understand, is just the human cycle that is going on right now. From this point onwards, female mosquito takes up the gametocytes with the blood meal. Now they are again coming and taking the blood meal. The fertilization and development takes place in the mosquito's gut. Basically, the fertilization and fusion of gametes and development is going to take place. Then directly in the salivary gland we have what? Sporozoites. So mature infective stages, sporozoite escape from the gut and migrate to the mosquito's salivary gland. From the gut, they now move to the mosquito's salivary gland. That is the only thing that you need to know. So this is for liver, this is for your red blood cell. Just understand here you have sexual stages, gametocytes developing in the RBCs. That's all. Okay, developing in the RBCs. Cool. And from this onwards, it will be something else. So they can ask you, right now I am seeing that these type of questions are also coming in, where they are asking you in KCET especially, what stage is this? They just put a box out there and they expect you to give the answer for the same. So please know, something bit me. I hope it's not the female Anopheles mosquito. Okay, anyways, so this is how it goes, and I hope this is super clear to you. Here is a question that we have from KCET, okay, and it goes like this. Some of the events occur during the life cycle of Plasmodium are given below. Identify the correct statement. So we have to identify the correct one. The sporozoites reproduce sexually in the liver cells. What do you think? Do they reproduce sexually in the liver cells? Asexual only, in our body, asexual. So this is going to be wrong. The gametocytes develop in the RBC. Do they develop inside the RBC? Gametocytes are formed in the RBC? Yes. So asexual reproduction happen, you get the gametocytes. That could be correct. But let's see the other ones also. Female mosquito takes up sporozoites with blood meal? No. They take up gametocytes with the blood meal, not sporozoite. They take up gametocytes with the blood meal. So this is going to be wrong. When mosquito bites a man, gametocytes are injected? No, it is going to be sporozoites which are going to be injected. Now sporocytes, don't write like that. Always remember sporozoites, and this is going to be gametocytes. Sporozoite, and then here you have gametocyte. Got it? So the only one that is going to be correct is going to be this one, B1. Clear? Yes. Do we have one more question? Yes. Malignant form of malaria is caused by, this is a PYQ 2025, very recent. Okay, Plasmodium, malignant malaria is caused by Plasmodium malariae, Plasmodium vivax, Plasmodium falciparum, or Plasmodium rubrum. Falciparum. Okay, falciparum is the one that causes, F, remember, F for fatal. Fatal as in the most serious one. The fatal form of disease is being caused by P. falciparum. Cool, ma'am. Cool, then let's go ahead with the next one. Amoebiasis. So listen to me. We have covered the first protozoan disease, and I know it was long, but this is the most important disease that we learned so far, and that was malaria, right? There is a second protozoan disease, and that is amoebiasis. You call it amoebiasis. Okay, you call this as amoebic dysentery also. Why all this? Why amoeba? Amoeba is there. Amoeba, if you know, it comes under kingdom Protista only, and again under protozoans only this amoeba comes. Okay, the name of the disease that causes the this amoebiasis is known as ant amoeba. Sin, I did a sin. I wrote it in capitals. Histolytica. A nice name, Litika and all. Entamoeba histolytica. Entamoeba histolytica causes what? Amoebiasis or amoebic dysentery. Now, whenever the term dysentery comes, just understand. I told you dysentery, plain dysentery is caused by bacteria, right? Amoebic dysentery is going to cause by this amoeba only. Anyway, whenever that comes into your head, just understand. Blood and mucus will be there in the stool. In the stool, as in basically in the 2 number, okay, excreted, undigested food, you will be having blood and mucus as well. So that, yes. Now we're going to talk about it more. So, pathogen is going to be what? As we know, Entamoeba histolytica, it's a protozoan. Organ that is affected is your large intestine. Now, before I go ahead with anything, it has lots of similarities with typhoid. There are 3 diseases which are almost, we think it's similar, but it's not. So in typhoid, what is being affected? Your small intestine is being affected. Here, in the case of Entamoeba histolytica, that is amoebiasis, the disease that is caused, what is being affected? It's your large intestine which is being affected. Not the small, but the large intestine is being affected, right? So just know that difference. This is amoebiasis, or you call this amoebic dysentery. Symptoms, constipation, there also you had constipation. Okay, abdominal pain. So there you had stomach pain, but now it is abdominal because it's basically you're moving down to large intestine. That's why abdominal pain, and not just pain, you're going to have cramps. You're going to have cramps. This is a very important symptom that helps in differentiation. Abdominal pain as well as cramps. And along with that, you have blood and mucus in the stool. I told you dysentery term comes, this is something that you have to remember. Okay, so constipation is there, similar to typhoid, but abdominal pain, there's not stomach, there is stomach pain here and there, and here it is abdominal pain, and you have cramps, and along with that you have blood and mucus in the stool which is there, right, okay. Now transmission, how is it being transmitted from one organism to the other organism? Same way, contaminated food and water carrying the fecal matter as in basically suppose, you know, in lots of places, you know, people do not have a good place to go and use they do not have the washroom set up out there. They go and excrete, do the process of excretion, or not the excretion actually, what do you say, they put the fecal matter near to the lakes and all. Now the lake is getting contaminated, that contaminated water comes into a home, right? And without boiling, suppose, or the sewage treatment, suppose it has not been done properly, what exactly happens is that we are drinking that water with the contaminants which probably we will not be seeing, because all of them are going to be microscopic. And trust me, it happens. Okay, however well treated the water is, there are higher chances of contamination to be there, which is why it is always recommended that we should be having boiled water. A lot of us do not show any symptoms and things like that because we have been immune to a lot of your body is fighting. Inside the body, a lot of fighting is happening out there. That is why you are not able to see this. Okay, but yes, it's there. So contaminated food and water remains the same. So it is going to be transmitted through fecal oral route. Fecal oral route, same thing. Carrier. So apart from the infection being transmitted from the fecus to the food, as in normally from the contaminated food and water, basically there can be a source through which it can be contaminated. Your food can be contaminated. Okay, that is houseflies. Houseflies over here are going to be carriers. Remember, they are not being affected in the whole process. Inside their body, nothing is happening. They are just carriers. You know, housefly, they are a little dirty in that work. Okay. So they go sit on the top of any dirty thing, come and sit on the top of our food and can contaminate the food very, very easily. So this is also how it can be happening. So contaminated food and water transmission is there, just like how typhoid has been happening. Apart from that, you can take the help of a carrier also, that is going to be a housefly. Housefly can also help in this contamination. Cool? Yes. So please do remember it. What do we have? I'm going to, okay, just a second. Housefly is a mechanical carrier. It's not a vector. I told you, vector is a one that is that itself is being affected in some ways. Okay, but this is just a carrier. Malaria mosquito is a biological vector. That means Aedes is a vector. So please do know that difference. Okay, so in both the cases, in both the protozoan diseases, one we have a vector there. Here we have a carrier, that is housefly. Okay, the second protozoan disease that we have is known as MVSAT, or you also call this as amoebic dysentery. Who causes it? Entamoeba histolytica. Okay, lytica. Histolytica is the one that causes it. Where does it go and affect? Your large intestine, not small intestine, large intestine. Okay, what are the symptoms? Constipation, same. Apart from that, abdominal pain, and then cramps are also there. Cramp is also there. And apart from that, since it is dysentery, obviously you're going to have blood and mucus in the stool also. Done. Now transmission, if at all we talk, the route is going to be contaminated food and water carrying the fecal matter. Apart from that, you can transmit the disease with the help of a carrier also, that can be a housefly. A housefly can easily transmit the disease from one place to other. This is just a carrier, a mechanical carrier. It's not a vector. It's not been affected by its own. Done. Clear, ma'am. All cool. If it's all cool for you, it's all cool for me. So what are the diseases that we studied? 2 diseases, we know about it and you know about it, right? We have Plasmodium that causes malaria and Amoeba that causes this particular amoebiasis. Okay, this is a MQP1 question. This is second PUC question. I'll just write it such that you know. Sometimes we just MQP means model question paper question, okay, previous years. Second PUC. Fill in the blank, word blank. Symptoms of constipation, abdominal pain and cramps are associated with the disease what? Constipation, abdominal pain and cramps are associated with the disease what? So this is actually a fill in the blanks question which was given to you. In the fill in the blanks you had to choose. Now there are so many things: amoebiasis, richness, nostoc, ovulation, colostrum, diversity. Obviously you might not be aware about a lot of things at this point. Ovulation you might know, colostrum you might know, richness, nostoc, diversity you might not know. Anyway, the answer for this question is going to be amoebiasis. I told you one marker can be fill in the blanks based question. So this was a fill in the blanks based question that was there in the previous year model question paper. Okay, so symptoms of constipation, abdominal pain and cramps are associated with the disease amoebiasis. For this year also, 2026 also, they had given the same model paper. Few more are there, we have to check that. Okay, so yes, we'll be making videos on that as well very soon. Cool. Now we have the next set of diseases. Ma'am, how many diseases are there? Last 3. Okay, last 3, and I'll say last 3 of them are a little easy also, don't worry. Okay, what is difficult? Only malaria is a little tricky out there. Rest everything is a little easy to remember, right? Not too difficult to remember. Typhoid and all, it was easy. Pneumonia was easy. Okay, then common cold was also easy. This one is a disease. Malaria was a disease where it was a little difficult, and amoebiasis is also easy if at all you think it's easy. And rest all the features are somewhere similar to what? Typhoid, right? Now we have helminthic disease. So ma'am, why do you call it helminthic? Do they take us to hell? Okay, does it feel like we are in hell? No. Helminthic diseases are caused by basically a group of organism that comes under kingdom Animalia. Okay, we have covered kingdom Monera, we have covered kingdom Protista, and now we are in Animalia. In Animalia, you have heard of Aschelminthus. Have you heard of what? Aschelminthus, where you have your roundworm and things like that. Well, one Aschelminthus which is there, as I said, is a roundworm. Okay, is a roundworm. It looks like this. Very round. Okay, there's one male and one female is going to be there. So over here, you have a technical name for it. Actually, you have a scientific name for it. You call the roundworm as Ascaris. It's actually known as Ascaris lumbricoides. Now in your NCERT, this lumbricoid part is missing, Ascaris is there. So you remember Ascaris, why do you have to take worry about this? You will be studying about this when it comes to practical, biology practicals. But until then, okay, if you do not want to study about it right now, it's fine. So we have Ascaris, that is a roundworm, and it causes the easiest disease to remember, Ascariasis. Okay, Ascariasis. So Ascaris causes Ascariasis. Again, very similar to typhoid. Very similar to typhoid when we read about it, not in exact disease manner, but when we read about it, we feel so much similarity. Let's read about it, okay? So pathogen is Ascaris, the common roundworm that is there. Disease Ascariasis. Symptoms: internal bleeding. Okay, muscle pain, fever, anemia, intestinal blockage. So why did I say then, ma'am, nothing apart from fever is basically something that is common between typhoid and all? The reason I said that it can be similar is because of this. X excreted in the feces contaminate soil, water and plants. Infection spread through contaminated water, vegetable and fruits. Basically contaminated water and food. Again, the contamination in the water and food is going to transmit the disease. But here, within our body, it's going to be a little bit different. What is going to happen? It is also going to affect your intestine. You know, in the intestine, if you see its picture, you will be like, oh my God, I cannot see the picture. Okay, so many of them looks like noodles inside our intestine. Now that causes blockage. In the intestine. If at all you have a blockage out there, you just imagine the situation. Okay, it's not too easy. It will be obviously painful. Apart from that, basically they cause perforations, holes in the intestine, which leads to bleeding. There will be internal bleeding, and because of all this, whenever you have bleeding, when you have infection in your body that is happening, what happens is that so many cells, okay, the cells which are there to fight against the diseases, they become active. Because of that activeness, it can lead to inflammation and all. Okay, when they are active, they will lead to inflammation. Basically, that's a mechanism for body to fight back against this. What is inflammation technically? Inflammation is, suppose the blood vessel was like this. Okay, now when this army is coming over here, we broaden the blood vessels to look like this, something like this, as that more and more of them can easily come in. This eventually leads to what? Inflammation. Now you just think of a scenario where everything like this is happening inside our body. Our body is in cold red situation. Obviously, here and there we are going to have some pain and all. Why? Because of this inflammation seen. So there is muscle pain also associated with this. There is fever that is associated with this. And this is a term that you have to remember, anemia. Anemia means you have less blood. Okay, less hemoglobin. That is anemia. You call it situation as anemic situation. Why do you have this? Because you have internal bleeding. You have internal bleeding happening, which is why you have anemia. So it's a very dangerous one that is there. Okay, so roundworm is generally there, but we usually have medicines and all, it's being treated. Suppose it's not being treated, then it ends up like this. Okay, so what do we have? Intestinal blockage. Just imagine noodle like thing inside our intestine causing blockage out there, and because since they are there and just there, basically they can lead to perforation and all, leading to bleeding. There can be internal bleeding out there. Because of the internal bleeding, you have pain here and there because other cells are also active in our body. Apart from that, you have fever, and because of the bleeding, you have anemia as well. Okay, how it is transmitted? So suppose one organism is there. Suppose X person is being affected. X person goes and flushes out his excreta. In the excreta, this organism's egg is there. Listen, it's there in our intestine. In the intestine, there is undigested food also, right? This organism releases their egg in the excreta. Now, in the excreta, when it is moved down, basically what happens? Egg is also there outside. This egg which is there, it is going to contaminate the soil, the water, the plants, because all the water which is there definitely goes up there. Water, sewage and everything gets mixed up with the soil and a lot of things. So it is going to contaminate everything nearby. Suppose a plant is growing in that particular soil. What is going to happen? That plant is now going to have what? The small, eggs of it and things like that. Right? And now when we have that particular fruit without washing it properly, okay, what is going to happen? That egg is there inside our body. That egg is going to later on develop into this organism. The same thing is going to be repeated. The only mission that it has is that I have to release my eggs through the excreta of this organism, and basically if that happens, everything is done and dusted. It's super clear, because human beings are definitely very, very dirty. And it's not about being dirty, it's about how microscopic they are. Obviously you cannot again see the eggs with your naked eyes, so it becomes a lot difficult. Okay, got it? No vector here. Okay, just this organism is there, remember that. So helminthic diseases are caused by organisms which are Aschelminthes, and in that one organism that we have is Ascaris lumbricoides. Actually it causes scariasis. Okay, ascariasis. Over here what do you have? Intestinal blockage is there, and leads further you have internal bleeding. Because of internal bleeding you have anemia, you have fever, and apart from that, because of bleeding and all the other cells and everything is very active, which is why you have muscular pain here and there. It's a reaction that our body has. Okay, yes. The next thing, it transmits through what? Egg excreted in through the excreta, okay, of the human being. It goes mixes up with the water, soil and fruits and everything out there, contaminating them, and whenever we have it, we again get it. So contaminated food and water causes it again. Got it? So this is about ascariasis. I hope this is clear. This is the first helminthic disease that we have. We just have one more helminthic disease, and that is known as filariasis or elephantiasis. Okay, filariasis or elephantiasis is the next disease that we have. And over here, before I go ahead with that, just taking a quick pause and coming back because there's a small meeting that I have to attend. Okay, I hope until this particular point it's super clear, and it's going to be very, very interesting. Apart from helminthic disease, that is this disease, we just have one disease, and then we are done with the diseases part for some time. Okay, then we are done with diseases part for some time. We'll come again talk about AIDS and all, but that is going to be pretty much easy for you. Trust me on that. Until this point, have you liked the class? If yes, not forget to hit the like button, and do not forget to hit the subscribe button and share it with your friends also. Cool? Yes. So I'll be coming right back. Okay, so let's go ahead and let's talk about the helminthic disease, the second type of it, and that is filariasis or elephantiasis. Listen, why do you call it elephantiasis? That might be a general curious question that is there. If at all you see the picture over here, you might be able to see this person's lower limb. Lower limb means we have upper limbs, that is this, and basically lower limb, that is this. The lower limb over here is swollen up, and it looks like a elephant's leg. That is why you call this as elephantiasis. Now the reason why it becomes swollen up and things like that is very, very important, and if at all you're curious about that, then you are my friend, because curiosity is something that should be very much in you guys. If at all you're curious, your learning becomes lots and lot easy. It's not going to be a boring task. Okay, so I'm going to probably enlighten your curiosity much more while discussing this. Listen to me very carefully. It is a very fun topic and it is going to be useful for you in the later part of the chapter, because again you're going to study about this later on. Okay, so what exactly happens is that you are aware about a blood vessel which we have in our body. We call this as artery. Artery, yeah, and then we have something which is known as vein. So we have vein, ma'am, and we have artery. Now, does artery reach everywhere? Does artery reach everywhere, each and every nook and corner of our body? No, ma'am, it's actually bigger. So it cannot reach everywhere. So what does it do is that it basically branches out. It basically branches out. You call them arterioles and things like that. Anyways, similarly, veins, do they reach everywhere? No. So arteries provide things to the cell, veins take those things. Whichever is not necessary, veins take those things. So it is very, very important. Okay. So for example, at our home, we should be getting food items. We should be eating them. And whatever waste material is there, that has to be thrown out also. Both of them are equally important. The same thing is happening up over here. So since arteries and veins cannot be reaching out to each and every cell, they thought, why not divide and form some other blood vessel around here, which you generally call as what? You call this as capillaries. Okay, they are going to be known as capillaries. So capillaries are those blood vessels. They are very tiny, teeny tiny. Okay, they are very teeny tiny, and basically they are going to go within the cells. Okay, within the cells, as in not inside the cell, but basically over here, suppose this is the capillary that I have, it can go like this. Okay, it can go like this, providing what? Each and everything that is important to the cells and taking whatever is not important from them. Okay, so that it can be removed easily. That is the role of capillaries. But capillaries have a catch. And what is that catch? If at all you take a closer look at the capillary, you would be able to see something like this. What is this? They have small pores. They have small pores. And these capillaries are the one through which the plasma is going. What is plasma? The fluid in which your blood cells are floating. That is what you call as plasma. So we know here plasma is there. Then you would be having your blood cells. Okay, let's make few blood cells over here. Let's make some RBCs. So your RBCs are floating, moving from here. Okay, apart from that, you have your white blood cells. White blood cells are what, Baba? White blood cells are the one that is going to fight against diseases. So you have so many things. Apart from it, you also have certain pathogens. You know, some infective agents which have accidentally got inside our body and they are running. Okay, they are basically circulating throughout, causing infection. So we have all of it in our blood and it is being passed through. When you have these pores here, don't you think from these pores certain fluid can come out very, very easily? Yes, obviously, ma'am. Definitely that can happen. So yes, plasma can come out. Okay, what extra? What apart from that? Can the RBC come? No, RBC does not change its shape, so RBC does not come. What about WBC? WBC can come. White blood cells, you know, they are very big, but they can change their shape. So WBCs can also sneak out. Okay, what about the pathogens? Arey Baba, they can also come. They have managed to come until this point. Obviously, they can come beyond this particular point also. So you have that also. What about your platelets? That is another type of cells that is there. They remain over here. They cannot move out. Okay, so you have plasma, you have your WBC that are very, very important, and you have the pathogens that is not important, but anyway it is there. These guys can ooze out. Now what is the problem if at all they all move out? The problem is that the blood pressure that we needed, if you need pressure to be maintained such that the blood can keep on flowing, okay, only when we get pressure of examination, that's when we go and study. Similarly over here, when we get pressure over here, that's when the blood is going to keep on moving. Here when I am moving out a lot of fluid and stuff like that, the blood pressure reduces. We need to make the blood go around, reach the heart. We took the blood from the heart, we need to take it back to the heart. So we need that pressure. So what is the thing that can be done in this case? Anyway, it has lost a lot of it outside. What can be done? So listen to me carefully. Now whatever comes out is right over here. Whatever comes out is right over here in between the cells. So I'll call this space as interstitial space, intercellular space, or I can call this as interstitial space. And all this thing, the whole fluid coming together, I'll call this as lymph fluid. What do I call it? Lymph fluid. So your lymph fluid is right in the interstitial space, right? And someone needs to collect this particular fluid out there. Otherwise, what is going to happen? Swelling will happen. The fluid is going to accumulate over here. Swelling is going to happen. And also, we have one more thing to do. That is, we have to maintain the pressure. I'm going to tell you how, but let's listen to me. So we have to take this from here. Otherwise, swelling would happen. And also, we have to increase the pressure up there. That's a major task. So what is going to happen is that, my dear children, in our body, apart from arteries, veins, and capillaries, which are blood vessels, we also have something which are known as lymphatic. There is it. Lymphatic vessels. We also have what? Lymphatic vessels. What do they do? Lymphatic vessels basically are going to take in. They are the one which takes in all the lymphatic fluid. Okay, over here the lymph fluid which is being accumulated between the cells, they are going to take that. They are going to take that, and basically, if you see a lymphatic vessel, you might be able to see something like this. Okay, there are certain points like this. Again, the vessel will be there. Again, there will be a point like this. And anyway, finally, it takes all of this and it goes and opens into what? It opens into a vein. It is directly going to open into a vein. Now, again, if you're opening into a vein, everything that you have got removed, basically everything has come back and the pressure is now going to be maintained. Now the vein is going to carry this blood and going to give it to the heart. Everything is sorted out there. Yeah, the fluid is also gone and that has been done. So can I call this as a drainage system of our body? Yes. But beyond drainage system of our body, it is also doing one more very important function, which probably at this point you might have missed because we have not spoken about this. My dear children, these things that you see in the lymphatic vessels, okay, these lobe-like structures which you see over here, you have a name for it. You call this as lymph node. You call this as lymph node, and it's there throughout our body. What does it do and why is it important over here? Over here, you have so many WBCs, white blood cells, which are there to attack on the pathogens. If you remember, our lymph has plasma, WBCs, and also pathogens. So these pathogens are now going to travel through this. Just imagine that they are left outside like that. They are going to affect our body. So that is why they are made to travel. Now, while they travel and when they come over here, everyone would be like, hands up. Hands up, you are dead. Hands up, Baba, you are dead. So these lymphatic nodes or lymph nodes are super important because they are richly supplied with a lot of WBCs are there, which can probably fight back against all the pathogens that are intruding in our body. That is why they are important. If you go to a doctor, you might be seeing that the doctors touch here and check. What do they check over here? Is your lymph node swollen? So you have lymph nodes over here. If at all they are swollen, that means that probably your body is fighting against an infection. You get it? Now, ma'am, what was the reason of talking about all of this right now? I didn't get it. So listen, a person who is having filariasis, okay, or basically who is having elephantiasis, their lymphatic vessels are being affected. The lymphatic vessels are being affected, which is why the fluid which is there over here, it just remains like that. It gets accumulated like that, which is why they have swelling all around. You get it? You get it? That's the point. That's the basic thing that you need to remember. Why did I talk about all of this thing? Because you are going to study about lymphatic organs later on, lymphoid organs later on. I just gave you a brief right now. And this is what exactly, this might save a lot of your time up there. So don't think like that you have invested time over here. Just think that it's for good. Okay, so what is going to happen is that filariasis or elephantiasis is a disease that is caused by blah 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 organism. We are going to come to that. But over here, what is symptoms? Chronic inflammation. chronic inflammation, not a normal level inflammation, chronic inflammation, swollen lower limb. So it's not like the upper limb is not being affected. Generally, it's the lower limb that is being affected more. Okay, there can be genital deformalities. What do you mean by that? Your genital organs are right up over here. The penis in the case of males, and mons pubis and everything in the case of females. Those, since your lower limb has been affected, those regions can also be affected. So genital deformalities can happen. Swollen lower limb could be there. There will be chronic inflammation that could be happening. Why? Because the site of infection is what? The lymphatic vessels, mainly of the lower limbs. The lymphatic vessels are being affected over here. You have studied about intestine being affected and all. This is for the first time a lymphatic vessel is being affected, which is why you saw all of it. Okay? Okay. Now listen. Progression. Worms live for years, causing gradual swelling and deformality. So in our body, they live for years, slowly creating issues up there. Slowly increasing the number, blocking up the lymphatic vessels and creating all this trouble. Now, who causes this disease? The answer is very simple. It's another ask helminth. It's known as Wuchereria. Wuchereria. It's known as Wuchereria, and there are two species of Wuchereria that you need to know: Wuchereria bancrofti and Wuchereria malai. So, you know, malai, we say buttering, okay? So, Wuchereria buttered and basically bankrupted the bank. Okay, they made a fool after the bank and then bankrupted it. So, you can remember like that. Bancrofti, okay, bancrofti. So, you have Wuchereria, bancrofti, and what do you have? You have one more thing, Wuchereria malai. That's all. These are the two aschelminthics, or basically worms that causes filariasis or elephantiasis. Very important. Again, as I said, I told you, plasmodium, malaria, who is the one that causes it, or basically this also, filariasis, which is the organism that causes it, and things like that usually comes up. So you should be knowing about it. Same goes with ascaris also. Cool? Yes. Now here, it is written that it is spread by female mosquito bites. What do you mean by that? It's not like female mosquito is causing the disease. It is said that it is a carrier. It carries it. And basically, from one person to other person, you can get this disease by a mosquito's bite. Okay? And what is the name of this mosquito? It's not given in the NCERT, I'm telling you. The name of this mosquito is going to be Culex. Okay? Culex mosquito is the one that transmits the disease. So, from one person who has it to another person who does not have it, you can get the disease with the help of a mosquito bite. That is why it comes under infectious diseases. Cool. So under the mosquito category, we have directly studied the one where there is a vector. It's malaria, where basically Anopheles mosquito is the vector for the disease and also the host. Then we spoke about dengue and chikungunya, which are viral diseases. They can be transmitted by bite of Aedes mosquito. Here it's a helminthic disease that is basically elephantiasis or filariasis. It can be transmitted again by a mosquito bite. The name of this mosquito is Culex. Do note that. Okay. Apart from that, housefly we study, that is in basically the protozoan disease, amoebiasis. Okay, Antamoeba histolytica causes it, but it can be a housefly can be a carrier, a mechanical carrier for transferring things from contaminated food or excreta and things like that. Okay. That is the basic logic that is there. Can we just close it up and try to revise it by ourselves? Let's try. Okay. So what do we have? We have elephantiasis or you have filariasis. How it is caused? It is basically caused if at all a mosquito bites. Okay. From an infected person, a normal person can get it with the help of a mosquito bite. The name of the mosquito is Culex, not given in your NCERT. But who causes it actually? It's Wuchereria bancrofti or Wuchereria malai. This is a causative organism. This is the reason behind the disease. Okay. Where does it go and affect? Lymphatic vessels, ma'am. What is the symptom? Chronic inflammation, genital deformalities, swelling in the lower regions, lower limb regions. These are the things that you need to remember. Done. That's all. And we have two Wuchereria bancrofti and Wuchereria malai. Sorted, ma'am. That's all. That's the only thing that we need to know. And with that, we complete helminthic disease also. Now we are coming to the last disease which is there, okay, under the infectious disease category. AIDS, as I said, is a separate thing. We are going to talk about that later. So in the fungal disease that we have only one, and that is ringworm disease. It's a very common thing. It looks like this on our skin. Even though it's a ringworm disease, it's not a worm that is causing it. It's actually a fungus. But over here, it forms a ring-shaped structure. And it looks like a worm is there. That is why you call this as ringworm disease. Okay, actually it is caused by fungus. and it can be easily transmitted. Okay, you might have the dry scaly lesions on your skin or your hair and things like that. Suppose I have it, okay, and you used my comb. Jasmine Ma'am, can I get your comb? I gave you the comb. Jasmine Ma'am is really good, so she's very hygienic. I'll just take her comb and probably comb my hair. But then eventually you're also getting the disease. Why? Because I could have it. I could have it. Anyone can have any infectious disease. So it's always better to use your own combs, use your own towels, use your own clothes. That is always good. Or if you're using someone else's, make sure you sanitize it really, really well. Okay, yes. Now over here, the dry scaly lesions which are there, it can be found in a very moist places. Okay, for example, in between your fingers, okay, or probably in between your fingers of your toe and things like that. Skin folds, the groin region. What do you mean by groin region? For example, if this is a man or a woman, this region that you have over here, this is going to be the groin region. This is a leg, okay, this is a leg over here. This region is known as groin. It is very moist region, warm region, which is why it can easily flourish up there. Fungi usually comes at that location, right? So what all do we have? We have symptoms of dry scaly lesions on the skin, nails as well as scalp with intense itching. There will be too much itching, okay. Usually they are there in area where you have heat and moisture, such as skin folds, groin, or between the toes. Transmission, contact with infected oil. Now infected soil. This is something that we forget. Infected soil can also be transmitting the disease. Similarly, towels, clothes and combs can also transmit the disease. Now, what type of fungus? That is a question. So I'll tell you. For making things literally very easy for you, I'll tell you a story. Okay, I'll tell you a story. So over here, this is your skin. This is your skin. Okay, skin is basically epidermis. This part that you see over here is the epidermis. So we have epidermophyton. We have epidermophyton, and we have one more phyton. You know trichomes. You might have heard of it. Hair-like structures which is there. Anyway, if you have not heard of it, there is trichome. It's not here. It's okay. It does not make any sense over here. I'm just telling you to remember it. So we have trichophyton. We have trichophyton, and basically we have epidermophyton. Epidermophyton and trichophyton. Just guess, what are they fighting for? Just guess. Silly people, they are fighting chumma. What are they fighting for? They are fighting for a small spore. A small spore, you know, ball. It's ball for them. So they are fighting for microsporum. Okay, they are fighting for what? Microsporum. Can you remember it? Epidermophyton and basically trichophyton are fighting for what? Microsporum. We are fighting for microsporum. That's all. Okay, pathogens, microsporum, trichophyton, epidermophyton, all of them basically they are fungi. They are different fungi. They can cause the fungal disease, which is the ringworm disease. Again, a very important question. I'll be showing you a question so that you get an understanding of what I am telling you. You'll get a question, right? Despite the name, no worm is involved. Ringworm is caused by fungi. Do remember it. Ringworm disease is caused by fungi, and it can be happening to anyone out there. Got it? Yes. This was the last disease, and I'm going to just shut it down, and I'm going to make you revise this. Okay, so ringworm disease is caused by a worm or a fungi. Fungi. Okay, what fungi? Epidermophyton, trichophyton. Fighting for what? Fighting for microsporum. Fighting for microsporum. Actually, three of them are fungi that causes the disease. Okay, what do you have as symptom? You have dry scaly lesions all over your body, and you have intense itching out there. So much itching is there. Apart from it, Baba, you are going to see this in areas where heat and moisture is being trapped. For example, groin area, your fingers, in between your fingers, your hair, scalp, nail, and things like that. Okay, yes. Now finally, how can it be transmitted? By sharing clothes, comb, or through infected soil also. Through infected soil also it can be transmitted. That's all. Cool. So that's the only thing that we need to remember, and that's the only fungal disease that we have. Done, ma'am. Okay. Now there are a few more things that we have to remember. Actually, only one. This one slide, and then we are going to solve some questions around it. Some KCET as well as second PUC based questions around it. So how do we prevent vector-borne diseases? So you have seen so many vector-borne diseases by this particular point of time, right? Vector-borne as in basically organisms carry it and transfer it to other organisms, right? For example, Culex mosquito helps in transferring filariasis or elephantiasis. Dengue and chikungunya can be transmitted by Aedes mosquito. Malaria can be transmitted by by your Anopheles mosquito. So all this thing requires one thing, vector control. We have to kill the vectors. We have to make sure that they are not there. If they flourish, probably our chances of getting the disease increases a lot. So what can we do is prevent water stagnation. If the water stays at one particular point, the mosquito will be like, nice place for me to lay egg, let me lay some eggs out there. Okay, so that is possible, so we do not want that. Clean coolers regularly. Vector control measures I'm talking about, okay? Prevent water stagnation. Second thing, make your coolers really, really clean, because in coolers generally we use water. There is water cooler, okay, where you put the water, and that water can be a safe egg laying ground for these mosquitoes. So we have to make sure that after the use, we clean the coolers regularly. Now use mosquito net as well as wire mesh, obviously, so that we are not being bitten by that. Introduce Gambusia fish in the pond. What is Gambusia fish? So Gambusia fish is a fish that is going to feed on the larvae of the mosquitoes. So it feeds on all the larvae, and there is no papa. When mosquito comes back, so see they're like, oh my god, nothing is there. Why? Because Gambusia fish ate it all. So that is the way. Last is spray insecticide in the breeding areas. You might have seen in the breeding areas people come and spray the insecticide, so that basically they are not allowed to grow. Okay, that is how it works. So what all things are there? We have to prevent water stagnation. We have to clean our coolers regularly. We have to use mesh and all whenever necessary. We have to make sure that we introduce Gambusia fish, because they are the ones that feeds on the larvae of the mosquito. And finally, spray insecticide in the breeding areas. Done. And know your mosquito. As I told, this is just for you guys to have an idea about things that we already learned. Anopheles causes malaria. Culex basically helps in transmitting filariasis. Aedes helps in transmitting dengue and chikungunya. And housefly helps in transmitting amoebiasis. It's a mechanical carrier. It's not a vector. It's not being affected by itself. Cool. Done. I hope it's done. Right? Clear? Yes. Now we are going to solve some questions. This is a PYQ 2017 of KCET. It said, which of the following vector-borne diseases are caused by Aedes mosquito? Aedes mosquito. Ascariasis and filariasis. Ascariasis and filariasis. Filariasis still can be spread by mosquito. Ascariasis is not spread by mosquito, only through contaminated food and water. Egg goes in the contaminated food, remember? Yeah, so malaria and sleeping sickness is not given in NCERT, which is why no. And over here malaria, yes, okay, but anyway no. Dengue and chikungunya, which is there, dengue and chikungunya, both of them are spread by the Aedes mosquito are there, so yes. Kala azar and filariasis, no. So the only answer that we have over here is going to be dengue and chikungunya. C is the answer for this particular question. Cool. Now next one, PYQ of 2023. PYQ of 2023. Okay, find out the correct match. Typhoid, and over here pathogen bacteria is given, main organ affected, lungs is given. In typhoid is caused by bacteria. Until this particular point it is correct, yes. What's the name of the bacteria? Think. Salmonella typhi. Okay. Over here is the lungs being affected. No, small intestine is being affected, ma'am. Small intestine, I remember it. Then from there it can go to blood and different organs, right? It is not this. Okay. Filariasis basically is caused by common roundworm. No, roundworm causes ascariasis. No, so this is wrong. Does it affect the small intestine? Filariasis basically affects your lymphatic vessels. So again this is also going to be wrong. Okay. Dysentery means basically blood and mucus will be there in the stool, right? Dysentery is caused by protozoa. Depends what dysentery. It can be amoebic dysentery, but let's check over here. Liver is being affected? No. In amoebic dysentery, large intestine is being affected. Here small, here large. We studied, right? Yes. Now we have ringworm. Ringworm disease is caused by a fungus. Correct. But since we receive worm over here and fungus over here, we usually go with wrong, but you know that right now. So this is correct. What about the skin? Yes, skin is the one that has been affected. So the answer for this question is going to be what? D. It is going to be Macha D. Got it? Clear? Sorted? Yes. Next one. Causative organisms. This is what I was talking about. This is your second PUC question. 3-marker question that had come. Second PUC, 3-marker question. Name the causative organism of the following diseases. Filariasis. Elephantiasis, what is it caused by? It is caused by Wuchereria. What? Wuchereria bancrofti, underline separately. Then what do we have? Wuchereria. If you have written this once, you can just write W dot, but anyway. Malai, underline again. Got it? That is how we need to go. Ringworm. Ringworm is basically wherever you have 3 or 4 names, that is the usual thing that comes over here for name the causative organism. Okay. Ringworm, we know epidermophyton is a fungal disease, right? So epidermophyton. Then we have trichophyton genus, and then we have what? Phyton. Venta. Everything Venta. Just a second. Some problem. Trichophyton, and there is one more thing. What is that one more thing that we have? Microsporum. Microsporum. Okay. What about malaria? Malaria is caused by, first write the malignant one. Plasmodium. Plasmodium falciparum. Falciparum. Underline it. Then write P dot. Next letter should be small. Okay. Malariae. And then basically we can go with P vivax. Got it? That is how we go about it. Cool. Done. That's all. Here I have written everything so that you have. Give the genus and the species where NCERT gives 1/2. Okay. So don't just write Plasmodium and come. Please write all of it. Very, very important. Okay. Yes. Now, infectious diseases, the whole map that we have studied. In the bacterial hormone diseases that we have, Baba, we have typhoid, pneumonia, diphtheria, plague, and dysentery. DPD. Remember, and you have typhoid and pneumonia. Typhoid caused by Salmonella typhi. What about pneumonia? Haemophilus influenzae or Streptococcus pneumoniae. Some people think Haemophilus pneumoniae. No, Haemophilus influenzae and Streptococcus pneumoniae. Okay. In viral, we have common cold, dengue, and chikungunya. In protozoan, malaria, amoebiasis, and helminthic scariasis and filariasis. Done. Now there is one more statement is given. With immunization, okay, if you get immunization, smallpox is completely eradicated. With immunization, smallpox has now been completely eradicated, as in completely gone from our country. Okay, over here, polio, diphtheria, pneumonia, and tetanus are largely controlled by vaccines. So polio, which is there, or diphtheria, which is there, polio is actually a viral disease. I already spoke about it. You can write it over here. Okay, polio, diphtheria, pneumonia, and tetanus are largely controlled by vaccines. So vaccine, immunization, all of it is different. They're going to talk about it, but just know smallpox is completely gone. Okay, smallpox is completely gone, and all the other diseases that we spoke about right now over here, basically they are being controlled by vaccines. Cool. Done. So until now, until this particular point, if my children are able to understand things, okay, can you give me a high five? Obviously you cannot. So what you can give is that go hit on the like button and hit on the subscribe button and share it with at least 5 of your friends who probably needs help. Okay, fine. Okay, listen. So now we have a drill, a game that I have for you guys to play. Let's go ahead and play this. Okay, cover the right side, say the pathogen out loud before the slide flips. So before I go ahead to the next slide, you have to tell me the name of the pathogen. Now, 6th and 7th is your homework. I am not going to tell that. 6th and 7th is going to be your homework. Let's talk about the first one. Typhoid, Salmonella typhi, pneumonia, Haemophilus influenzae, Streptococcus pneumoniae, common cold, rhinoviruses, malaria, P. falciparum, P. vivax, and P. malariae, amoebiasis, and amoeba histolytica. Okay, and then what? Then you have the thing. Name the organ affected for each of bonus thing. Name the organ affected. Okay, typhoid, organ affected is usually small intestine. Pneumonia is usually lung, the alveoli of it. Common cold, the upper respiratory tract, nose, and your trachea and all. Malaria, it's basically liver and RBCs which are mostly affected. Amoebiasis is a large intestine which is being affected. Now, this is your homework, every one of you, not in the chat session, okay, here, because this is going to be premiered. Not in the chat session over here. I want you to put it down in the comment section of this particular video. Close the chat and comment it down. That's when I can probably see. Okay, because these chats that you're going to do is going to go, so I will not be able to see it. Okay, so yes, I hope that makes sense. I hope not, you have not seen it. Okay, now we go ahead with the next concept which is there. So we have completed diseases from my end. Everything which is super important, we have done it. Okay, so probably you can expect a 3-marker and also the 1-marker questions and all. You might be able to ace it. Now we're going to go ahead talk about other big terms. Innate and acquired immunity. What do you mean by that? So Baba, just imagine that you are being born. When you are being born into this world, Are you aware about anything that is happening around? Do you know what's good, what's bad? Okay, which organism is going to cause this disease, which organism is not? So at that particular point, when your body is not known about anything, you cannot come randomly out of your mother's womb without any protection. You have some immunity from the very point you have been born. For example, immunity in the form of skin, immunity in the form of tears. What happens in the tears? Tears have enzymes which can kill bacteria. Okay. Similarly, there are different. You have HCl inside your stomach to kill all the things that comes inside your body. Okay, while you eat food and things like that. So there are a lot of things. They all come under a category which you call as innate immunity. They all come under a broader category which you call as innate immunity. Similarly, we have one more type of immunity that is known as acquired. For example, I was a baby once. Now, I grew up, I had pneumonia. Basically my body reacted to it. My body was almost gonna die, and basically somehow it got safe. It has the cells being active. It came to know which was the organism that caused the problem. And basically, after identifying it, it's more strong now. Okay, initially it probably didn't have all the weapons, but now it has all of it. So this type of immunity that we acquire during our lifetime is known as acquired immunity. Obviously, at this point, you might not be able to understand all of it clearly, which is why we are going to go in deep, and one by one, we'll understand it. One line I liked it: one you were born with, one you earn. One you're born with, that is innate, and one you earn, that is going to be acquired. And only one of them remembers. Let's see what I mean by that. So, first is the innate immunity that we have. This is present from birth. Very, very important. Okay, few terms are very, very important over here. They are present from birth. Apart from it, they are going to be non-specific, as in, example, the first type of innate immunity, or basically first category of innate immunity, is physical barrier. In physical barrier comes your skin, comes the mucus in the respiratory, in the gastrointestinal tract, in the urogenital tract, all of it. Okay, so what does the skin do? Skin allows protection. It does not allow bacteria, it does not allow fungus, it does not allow virus, it does not allow any other human being to enter through. Does it? No. Is it specific? Does it say, hey, virus, you can get inside, bacteria, you cannot? Can it do that? No. It's non-specific. It is what? Non-specific, common for all. So it is present from birth, and basically it is going to be what? Non-specific in nature. Basically it does not have a specific target out there. It's for all, common for everything. Okay, so and that is a major two things that we have from birth and non-specific. Now over here, listen to me very carefully. The first type of barrier that we have is physical. In physical, the first thing that we have is skin. Apart from it, you also have mucus. Where all do you have mucus? In your respiratory tract. In your respiratory tract, the mucus which is there, it traps. Suppose I breathe in certain things. Along with it, a lot of dust and blah 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 thing came in. The mucus is going to trap it such that it does not go throughout my body. Okay, throughout my respiratory system at least. Okay, so that is a role. Apart from that, gastrointestinal tract, as in basically from the esophagus to the intestinal stomach and everything, is lined with mucus. Again, protecting me from a lot of things that is happening up there. Urogenital, your urinary, genital tract, everything has been again coated with mucus such that no pathogen could basically cause a trouble. It's just trapped. The pathogen is like, leave me from here. You know Spider-Man web? You all have seen Spider-Man movies, right? So there it does not move around, right? Same thing happens over here. They are going to be physical barriers. They are going to be physically there, present, such that the organism basically cannot get entry, or if it had got entry, it cannot move around. Okay, physical barrier, please do not forget skin and mucus. The reason I'm telling you this is that you might have a confusion with this and physiological barriers. Physiological barriers are basically things that are released from our body. Okay, they are going to be released from our body. They can be the form of fluids and stuff like that, which keeps us really, really safe. So mucus, do not put it over here. It comes under physical barrier only. If mucus is a layer, you can imagine like that, a wall layer of mucus, you can imagine like that, okay? This is going to be physiological barrier. Stomach acid, which is your HCl, it makes sure that whatever food comes in, okay, it's germ free. Similarly, saliva, which is there, similarly tears which are there, they both have an enzyme which is known as lysozyme. They both have an enzyme that is known as lysozyme. What does the lysozyme do? Lysozyme are responsible for cleaving open the bacterial cell wall. The bacterial cell wall is made up of something that is known as peptidoglycan. Okay, it is made up of something that is known as peptidoglycan. peptidoglycan. To break it open, to cleave it open, we have lysozyme. So every time you cry, remember it's for good. Okay, happy tears. Be happy. Okay, so your saliva and your tears have the, you might have seen that. I know it's gross what I'm going to tell, but it makes sense. But you have to be very, very safe. Sometimes whenever we get some small pimples and stuff like that, our mothers and all, they do this, like they ask to put saliva up there. Why? The reason being that they have lysozyme. But it has to be done with a very clean hand, and it's better not to do it because you have a lot of things. But in general, it works. Okay, it's because of the same reason, that is, it has lysozyme. So physical barrier done, physiological barrier done. Are you born with it? Yes. Are they non-specific? Yes. They are non-specific. They are not like I will act only on you, right? So they both come under this. Now you have cellular barrier. Okay, cellular barrier as in, this whole question is important. They ask you what is innate immunity. You have to explain all of it. That is why I'm explaining you in detail, such that you write that particular all these points and come. Okay, cellular barrier as in cells which are there. We do not have all the cells super active in our body from birth, but we have few of them. We have few of them which is written over here, such as polymorphonuclear leukocyte. First of all, what do you mean by leukocyte? Leukocytes are basically WBCs, white blood cells. Now polymorphonuclear leukocytes means the nucleus have different morphology. This is a nucleus, it has different lobes and all different morphology. They are known as polymorpho. Poly means many. Polymorphonuclear leukocytes. Polymorphonuclear. What is polymorpho? Nucleus, right? So polymorphonuclear leukocyte is there. In simple terms, you also call them as neutrophils. You also call them as neutrophils. What do the neutrophils do? Do you know? What does this neutrophil do? Neutrophil are the ones that is going to, suppose over here I have a pathogen. Over here I have pathogen. It comes and basically eats it up. You know, phagocytosis is being done. It takes it up and eats it up, digests it up. This is known as phagocytosis. Okay, taking inside it and basically killing it. So neutrophils are one cell which are going to do it. Apart from that, you also have another group of cells which are known as monocytes. Okay, which are known as monocytes. They also have a similar function. Monocytes also have a similar function. They later on develop into something which you call as macrophages. Macrophages. So, to make you understand things a little bit, okay, I'll tell you. You have different types of white blood cells. You have very different type of white blood cells. If at all I want to just put it down out there, I'll say, okay, I can just put it like this. If there is WBC or leukocytes over here, I'll put them into the one that has granules and the one does not have granules. Agranulocyte and granulocytes. And then under that I can divide them into lymphocytes. Okay, and over here I can have neutrophils, eosinophils, basophils, and lot of cells like that. There are so many of them. And there is macrophages also. Okay, so neutrophil is just one category of your leukocyte, which is responsible for what? Phagocytosis. Similarly, you have one more group of cells which you call as monocytes. These monocytes later on develop into macrophages. Macrophages. These macrophages also does the same thing, that is phagocytosis. Phagocytosis. Ma'am, two of them doing the same function? Yes. Two of them can do the same function. But this one, whenever something comes into our body, this is the one to react first, to go and eat first. This one will come up late, but this cell is super important for giving information to the other cells and things like that. A lot of things are happening in our body. So I'm not going in that depth because in that case it will take a lot of time. If you're interested, let me know. Probably in another day, in another session I can explain. Okay, so that is how it usually works. So we have neutrophils, we have macrophages which develops from monocytes. They were monocytes, later on they develop into macrophages. Anyway, they are there in our body from the starting point. Apart from that, you have natural killer cells also. Okay, natural killer cells, these are another type of cells that we have. NK cells is what you call them. These all cells are right up there in our body from the starting point. Okay, so they are known as cellular barriers. What all cells are there? Let's remind once more. Okay, polymorphonuclear leukocyte, you call them as neutrophils, ma'am, and they are doing phagocytosis. Similarly, you have monocytes, ma'am, they develop into macrophages, they also do phagocytosis. Okay, keep them there. Okay, let them do phagocytosis. Then you have natural killer cells, which are the ones which actually kills the cancerous cells, the viral infected cells and things like that. But they have not kept things in detail, so I'm just telling you there are natural killer cells also that is going to affect the infected cells. Right. These are there from the starting point onwards. This is there from the starting point onwards. This is there from the starting point onwards. One last thing is left, and that is cytokine barriers. Cytokine means certain things that are going to be released by our cells, and they're going to protect us from something else. Okay, and they are there from the starting point onwards. And amongst all of them, this one is the most important, because this is where you get an MCQ question from. So what exactly happens is that, suppose this is a cell. This was very happy cell, okay, very happy. This was actually a group of cells are there. These cells were also very, very happy. One day what happened is that this cell which was there, it got infected by a virus. It got infected by a virus, which is why it became sad. Now, if a cell is being infected by a virus, there are high chances. So the virus can basically make progenies over here, increase the number, and later on affect the other cells. But before everything happens, this cell is going to do something. Is going to produce something which you call as interferons. Which you call as what? Interferons. And this is the most important things. What happens to the interferons? Interferons are released, and that goes and tells the other cell, hey Macha, you have to be safe. Please move away from here. Please do something. Either kill yourself, do something. But you have to move away. You cannot be in the proximity of the cell. You have to be somehow safe. You have to alert the other cells, somehow do something such that you are not being affected by viruses out there. Okay, that is the role of interferons. Why do I call them cytokines? Because they are something released from the cells. That is why cytokine. So cytokine barriers, as in virus-infected cells release interferons. This is just an example of a cytokine. There are multiple other types of cytokine also. Interferon is an example. Okay, so virus-infected cells release interferons, which protects the neighboring healthy cells from further infection. Similarly, you might have other cytokines also, but in your NCERT only one is mentioned, and that is interferon. Interferons do not kill viruses. Do note that. Interferon is not going to kill. Okay, they are just going to protect the uninfected viruses. Uninfected cells out there. They're going to protect. They're going to give the signal that, hey, you have to do something. Got it? So how many barriers do we have? Physical barrier, skin and mucus in all the urogenital tract, gastrointestinal tract, respiratory tract, all of it. Physiological barriers, things that are released by our body. For example, it can be stomach acid, it can be basically tears, it can be basically saliva. All of it has some enzymes that could be killing the bacteria or things like that. Then you have cellular barriers, 3 types of cells majorly. Polymorphonucleoleucocytes, which you call a PMNL. Polymorphonucleoleucocyte, you call it PMNL, or neutrophils. Similarly, monocytes are there, which later forms macrophages. Both of them are responsible for phagocytosis, for taking up this organism and killing it inside. Okay, now don't think they're taking up lion and all. It's just small microscopic organism that they take up and kill. Apart from that, we have natural killer cells also, NK cells, natural killer cells. Then we have cytokine barriers, the things that is released from the cells. Example is interferon. Interferons are released by virus-infected cells to inform the other cells to be safe. Got it? That's all. Very, very, very simple. So that is all about innate immunity. It's there from our birth with us. It is non-specific, very, very important, and it does not remember anything. Today a bacteria came in. Does the innate immunity system has a memory that skin has a memory that we have seen this bacteria before? Does it have any life like that? No. It does not. So it does not remember anything. Please do note that. Because the thing that we're going to talk about right now, that is basically acquired immunity, is not going to be like that. Acquired immunity is going to be a lot more different. So over here for innate, I'll just write the barriers. What are the 4 barriers that we have? We have physical. Okay, we have physical. We have physiological. We have cellular, and we have cytokine. The example for cytokine, what do we have? We have interferons. For cellular, what do we have? We have PMNL. We have macrophages, and we have what? We have NK cells, natural killer cells. Here what do we have? We have the acid in our stomach, we have the saliva, and basically we have the tears. Here what do we have? We have the skin, and we have the mucus. Will you be able to remember it? I hope you do. Okay, and please remember it's from birth and non-specific. That's all. Now, we're going to talk about acquired immunity. Listen to me carefully, okay? Suppose this is Jasmine Ma'am. Suppose this is Jasmine Ma'am, or let's make it Pappu. Pappu is our guy. Okay, this is Pappu. Pappu for the first time is infected with a disease. What is going to happen? Pappu will be like, oh my god, my life is gone, I cannot survive. This is the bed that Pappu has. Okay, that is the case that usually happens up over here, right? When we first get disease. Here, Baba, the reason why we get really ill is because this is known as the primary response. Primary response. For the first time, our body is seeing this pathogen. It is not prepared for it. Why? Because we have very few limited cells. We spoke about it. We do not have a whole system ready. Okay, which is why we are going to go like this. But if this happens once more, okay, if the same scenario happens once more, this time Pappu is there. Okay, Pappu basically has endured all of it. Again, a disease comes. What happens? Pappu will be strong only, and this time Pappu will be having biceps and triceps also over here. This is what the second response that is there. Secondary response to the same disease which is there, or the same pathogen that is there. Secondary response. Secondary response, you also call this as anamnestic response. Why do you think it's like this? Because the first time our body encountered something, encountered a pathogen, a parasite, okay, what exactly took place is that for the first time when it came across this, our body, okay, produced two different type of lymphocytes. Lymphocytes are basically what? Lymphocytes are a type of WBCs. Lymphocytes are a type of WBC, just like how you have neutrophil, right? Similarly, you have lymphocytes, and you have two lymphocytes, B lymphocyte and T lymphocyte. These two cells have been released. B cells which comes across this particular pathogen, I'll write it as pathogen. Sometimes I also call this as antigen. Okay, pathogen, antigen, same thing. Pathogen is the whole organism, antigen could be a part of it. It comes across this antigen, what happens is that B cells is going to do two things. First thing, it is going to produce something which is known as antibodies. Okay, what are antibodies? Antibodies are nothing but proteins. They are proteins which has the ability to go and make sure that this particular pathogen is dead. Okay, cool. I will tell how and all. So that is the role of antibodies. Similarly, the B cells which are there, they are going to produce some memory cells. Why memory cells? Just to make sure that you remember that some pathogen had come in, it had caused a trouble. It's like revenge mode on, okay? It has caused the trouble, and at that time I had produced this antibody. So there are so many antibodies. How many antibodies? 5 antibodies are there. G, A, M, E, D. Gamed. I remember it as gamed. There are 5 antibodies out there in our body, and depending upon the antigen which is coming, basically I'm going to release each of these antibodies. Done. B cells are going to do that. They have it. They have done it. In the first case, when this antigen came in, or when this pathogen came in, our body was producing it. But it was the first time it was producing it, which is why the quantity and everything was less. Okay, and at that point only it produced memory cells also. Now, the next time the same thing comes up, our body's memory cells are already active. They know that something like this had come before. They are going to produce the exact same antibodies out there, and obviously they are going to be more effective. You have heard that you do not do the same mistake twice, usually. Why? Because every mistake comes with a learning. The same thing happens up over here in our body also. Every mistake that it did came up with a learning, that this is how it works. Right? So B cells get active, and I'm telling you one more cell get active, and that is going to be known as T cells. T lymphocytes. So B and T lymphocytes are there, T cells now become active. T cells basically are of different types. Certain T cells, you call them as cytotoxic cells. Okay, cytotoxic cells, you call this as TC cells, okay? They directly go and kill the organism. Then there is some other cells which is very important, T helper cells. T helper cells. What are T helper cells? T helper cells might might pass the information to other cells, and the other cell becomes active, and then they might be going and killing it. They are the help one. They are the intermediate, the mediators out there. That is T helper cells. Okay. Similarly, you have so many other type of T cells also which are responsible for it. And whenever I say that cytotoxic T cells are produced or T helper cells are produced, you also need to remember memory T cells are also being produced. Memory T cells are also being produced here also, so that you have an understanding that what happened and what did we previously do. Got it? Did you get it? So what happens next time a pathogen comes in? Everything is active already. Our body already knows about it, and it's going to be a good response. Second response would be a better response. So first time we get any disease, we would be like that. So first time I got pneumonia was like that. Then I got COVID. My body was already okay. It was already at that point. My body still knew what it had to do. I had got, I think, COVID 5 or 6 times. Literally, my immune system was so bad at that point after I got pneumonia. Still somehow it recovered. The reason being that our body fights. We have a good second response, mostly. Got it? Now listen to me. I'm just putting it down together. Whenever some pathogen or antigen comes in, your body is going to produce a lot of WBCs, but majorly I'm talking about one type of WBC, that is lymphocytes. In lymphocytes, you have 2 types of it. One is B lymphocyte and other one is going to be T lymphocyte. The B lymphocytes are the ones that are going to produce antibodies. These antibodies are going to affect the antigens or the pathogens directly, okay, with the help of certain cells out there. How many antibodies and what are antibodies? They are proteins. How many types are there? 5 are there. GAMED, G-A-M-E-D. Okay, apart from it, you have memory cells also being produced in your body, so that you have a memory that I produce this type of antibody against this antigen. Similarly, you have T cells. The T cells which are there, they can be cytotoxic T cells which are being produced, or helper T cells which are being produced. If it is cytotoxic, it goes and just kills the cells directly, kill the organism directly. If it is T helper cells, it gives an information to the other cell becomes active, and the information passes. Somehow we are able to do the job of making our body safe. Okay, apart from it, memory T cells are also being produced. Now listen to me. Here, the immunity offered by B cells, I have a name for it, and the immunity offered by C cells, T cells, I have a name for it. B cells, I say, it's humoral immunity. It's humoral immunity. Why humoral immunity? Because these antibodies which are being released, they are going to travel through our blood, and blood is humor. Humor is basically fluid. Okay, so these antibodies which are there, they're going to travel through our blood, which is why I call it humoral immunity. They provide immunity through the fluid, through the blood out there, through the circulation out there. Then we have this immunity which you call as cell-mediated immunity. Cell-mediated immunity. Over here what happens? One cell is active, it activates the other cell, okay, or probably a cell can directly go and kill other organism altogether, but a cell is the one that is majorly doing the work. So you call this as cell-mediated immunity. Always understand that acquired immunity which is there, it has 2 forms under it. One, humoral immunity managed by the B cells, other one is cell-mediated immunity managed by the T cells. Okay. Now suppose my kidney failed and I am taking kidney from you. Okay, what usually happens is that even though everything matches up, my body might still reject it. You might have heard about it. It's known as graft rejection. It's known as what? Graft rejection. Very important. Graft rejection mostly happens because of the T cells in my body. My T cells are not ready to take up anything new. It's very foreign for me, and anything foreign can be affecting me, which is why my body tries to keep myself safe. That's why I reject the graft, even though it's good for me. So that is why, okay, always understand, graft rejection is not done by the B cells, it's because of the T cells. Graft has a T cells are involved over here. That means cell-mediated immunity is going to be involved over here. Remember that. Very, very important thing. And which is exactly why people who undergo graft transplantation and things like that, they're usually given immunosuppressive drug. That means they are given drug to suppress their immune system. Okay, this is a usual thing out there and a very, very important thing. I hope it makes sense. I hope you have understood it as well. Works clearly for you? Or you feel that, ma'am, I have few more doubts in my head? No, right? I hope it works. Now, listen to me. One more very important thing, that is, this proteins which are there, okay, that is antibodies which are there, you call them as immunoglobulin. Okay, the name of the protein is what? Immunoglobulin. That is why you make it short form and say IgA antibodies there, IgG antibodies there. It's nothing. Ig stands for immunoglobulin. They are just protein. Okay, that's a term for protein. Cool. Works. Now we'll just put it out all together so that we understand things, because I know it's difficult for you to know all of it at one go, right? So let's go one by one. Immune response. First response is primary response. The first exposure is going to be of low intensity. Our body is not going to react so bad to it. Secondary is anamnestic response, stronger and faster because of memory. Why? Because until this particular time, memory cells are being produced. Okay. Lymphocytes involved. B lymphocytes produce antibodies. It can be IgA, immunoglobulin A, immunoglobulin M, E, G, and where is D? D is also there. Okay. D is also there. So always remember it as gained. It basically gives humoral immunity because these antibodies are found in the blood. And blood is basically humor or fluid. So anything that travels through the blood and provides immunity, humoral immunity we can say. Okay. T lymphocytes help B cells and cell-mediated immunity. T lymphocytes which are there, they are helping. They can help. They can do their work alone. First of all, do understand that. Or they can help the other cell. It can be a B cell also that they can help. Okay, and say that, hey, Macha, this is there. You have to be active. If you need no help, let me know. I can probably kill. But yes, I'm giving you the signal that this is taking place over here. So please look forward to it. You get it? So since here cells are involved, okay, I'll say that it's a cell-mediated immunity out there. Cool. That's all. When I say a person, antibody structure, I'm coming to that. Before that, organ transplant. If a person is getting any graft transplant that is happening up there, tissue and blood group matching is needed to prevent rejection. That's the first thing. Okay, CMI recognizes and rejects the foreign grafts. So immune suppressants are required after transplants. So CMI means cell-mediated immunity recognizes and rejects the foreign thing that is there in our body, which is why we might need immunosuppressive drugs. Done. That's all. Now over here you have a picture that is given, and this picture is super important. This picture is usually being asked in the form of diagram. It can be a 3-marker question that could be coming, or in the 5-marker the B part could be coming like this. Okay, what is antibody molecule and how do you make it? Antibody is nothing but a molecule that is made up of peptide. Peptides come together to form proteins, right? Yes. So we have 2 chains over here. One chain is this, another chain is this. This long chain that you see over here, you call this as heavy chain, very heavy. And there's a small chain out there, you call this as light chain. So we have heavy chain, and what do we have? We have a light chain. These 2 chains are there. Okay. In between this, you see certain things, they are hydrogen bonds. Not hydrogen. Sorry, forget. Okay, they're sulfide bonds that you have in between. Cool. Disulfide bonds actually. Cool. You will be finding more between 2 heavy chains and less between a heavy and a light chain. Okay. So since you have 2 heavy chains, can I write H2? Okay, and you have 2 light chains, can I write L2? So the structure is what? H2L2. Structure is going to be H2L2. Very important. Okay. H2L2 over here would be having some bonds. As I said, sulfide bonds would be there. Now if you look at it carefully, you're going to find certain things. That is, here at this particular point, heavy chain, light chain, and this particular point that we have over here, you're going to have some antigen binding sites. What do you mean by that? The antigens which are there, for example, there's a pathogen, and the pathogen, some part is there which is probably very specific. Okay, it can create a trouble out there. That part could be joining up over here on this particular side, antigen binding site. That is what is known as. Okay, if the antigen is binded, suppose what is going to happen? I'll just give you an example. This cell is there. On the top of it, you have antibody. Here antigen comes and binds. This cell becomes active. This cell probably can now produce certain things to kill the pathogen, or probably directly can engulf the pathogen and kill it. There are a lot of things that can happen up there. You get it? So that is why we have an antigen binding site. So this site which is there is going to be different in different type of antibodies. You call this region as variable region. You call this region as variable region. And this region which is in red, basically you call this as constant region. So you have constant region from here to here, and you have variable region from here to here, and that is going to be different in different type of antibodies out there. Always remember that. And this site that you have is known as antigen binding site, where your antigen is specifically going to come and bind. Certain antibodies are going to react against certain antigens only. They are very, very specific in that. It's not like all the antibodies are going to produce, for example, in allergy. Okay, whenever you have allergy, antibody E is going to be produced. IgE, immunoglobulin E is going to be produced. If you have something else is going to be produced. You get it? They are very, very specific in that terms. Cool? Understood? Works? Please do remember it. It's very important, and you would be asked to make the diagram for it. So first you make a diagram which goes something like this. Okay, this is going to be what? This is going to be your heavy chain. Okay, I just need to make some changes over here. Everything went down. Okay, so let's have some change over here. Okay, this is going to be the heavy chain that we are having. Okay, similarly you would need to make a heavy chain right over here also. Right over here you have two heavy chains. In the heavy chains you mark until this particular region, you give a different color. Okay, as of now I'm not able to make it nicely, but you can do so. So you can just color it up like this. Okay, this is the variable region of the heavy chain. Similarly, again, you have to do what? Here you have to make a light chain. For light chain, it's going to be pretty simple. Make it like this, and you can elongate it a little bit. You can elongate a little bit. You can make it until this particular point. Okay. Yes, the same thing, you can make it up there. I'm not making it and wasting a lot of your time up there. If when you make it, just make sure you have some space being kept over here. Here you can write S, and here also you can write S like this. S, S, that means disulfide bonds is up there. Disulfide bonds. Similarly, they have disulfide bonds between them and basically within them also. So one S over here and one S over here, and then make a bond like this. That will also be there. Same thing happens over here. That is what they have done over here. That is what they have done over here. So they have those disulfide bonds. Here they just have one. Apart from that, in between them, SS bond is there. Okay, that is also up there. So do remember it, and then you can just tag it. And then you can just tag it. So this site which is there, this is going to be an antigen binding site. If you want, you can just mention this is going to be variable region. You can just mention like this and do like this. Okay, apart from it, this is going to be what? This whole thing which is there, this whole thing. Now how do you explain that? Do I need to make a diagram? Do I have a place for that? Yes, I can. If you give me a second's time, probably let me make a diagram and I'll show it to you, because I think this diagram is important, so let's not miss it on it just because your teacher is lazy to draw. Okay, so here it goes like this, here it goes like this, here it goes, and then make a line. Okay, yes, over here, that's done. Similarly, give some space. From here you can start so that you can make them understand, right? Now over here you go, outside, inside, 1, 2, and then straight, right? Got it. Here you make a line, and that's done. Right, now here S bond is there. One more SS bond if you want, you can make it. Similarly, S bond will be here. S bond could be here internally as well. Okay, this is what? This is going to be a heavy chain. So you can just mention like this and put heavy chain. Got it? Got it. Now, let's go ahead. Let's make the next thing. And if you can, with the help of a pencil, just shade this portion. If you can, with the help of a pencil, just shade this particular portion out there. It will be really, really helpful if at all you could do so. Now we make the next thing. So the next thing is going to be a light chain. One line goes like this. One line goes like this. Make it like this. Okay. And then make it like this. Here, until this particular point, this is going to be an antigen binding site. Okay. Similarly, make a line from outside. That will be more easy for you. Then like this. Then like this, then like this, and join it up. Here again, line it up. Cool, cool. And here make a disulfide bond. Here also make a disulfide bond. Done, done. Now, this particular portion as an overall thing, mention this as what? A light chain. Okay. Here, the thing which is there, mention this as what? Antigen binding site. And if at all you want more marks, probably you can mention that this region is going to be constant. Okay. This is generally not asked. If you need, you can go. And probably these two regions which are there, they're going to be variable region. But I think that can cause a lot of trouble. So if you miss this constant and variable, at least mention this and that could give you marks. Also, one more very important thing. Listen, it is made up of amino acids, right? It is made up of amino acids. All the peptides, all the proteins which are there, they're made up of amino acids. And each amino acid has a carboxyl end and it has an amino end. It has a carboxyl end and an amino end. Suppose it joins. So there will be a carboxyl end over here. And at the end, Baba, you are going to have an amino end. So just mention C over here and N over there. That's all. Similarly, C over here, N over there. Cool. That's all. This is your antibody molecule. If at all you make it properly, you will get your marks. You do not need to mention constant and variable region because I know that it's going to be difficult for you to make them understand. You cannot use pencil colors and stuff like that, right? So you can just skip out on that. Now, if you think that that is going to cause confusion, I'll just remove that from here. Okay. Cool. Works. Now over here, I have a question. Identify the incorrect statement from the following. This is a KCET PYQ question. B cells produce antibody. Is that incorrect? No, B cells actually produce antibody. Interferons kills viruses. Wrong. Interferons basically gives information that a cell is affected with viruses. It cannot kill viruses. What is the question? Incorrect statement. I have got my incorrect statement. Let's go ahead. Response of T cells is called cell-mediated immunity. Response of T cell is known as cell-mediated immunity. Yes, that is correct. Macrophages are the phagocytotic cells. Macrophages are the phagocytic cells. Phagocytic means they eat up the other things. Are they phagocytic? That is also correct. The only thing that is not correct is this, and children get it wrong. Why? Because they think interferons kill the viruses. No, they're going to basically signal that there is a cell that is infected with the virus. Got it? Remember that? Yes. And here is a 5-marker question which was being asked, okay, in the previous year. That is why I invested time in innate as well as acquired immunity. I hope that time was useful for you as well. So the first question that comes under over here is that you have to differentiate innate immunity and acquired immunity. So what is the difference between innate and acquired immunity? Can you tell me the difference between innate and acquired immunity? We know the difference. What are the difference? Let's check. Okay, so first one, innate is present from birth. Acquired develops after infection or vaccination. Vaccination we still have not covered. We will be covering it up. Okay, vaccination means basically you are getting the dead or the weakened form of pathogens inside our body. Why? You're doing it knowingly, such that your body knows that something like this can come up. Suppose a lot of people are getting infected with a disease. Now you don't want actual infection to happen to others, so which is why you put a factor, put a thing which could be an indicator that this type of thing is running around. Please produce an antibody against it. That is what you mean. Okay, so acquired immunity can be basically, as I said, develops after an infection, a natural infection that is there, or probably vaccination also. But it is acquired. You get it through your lifetime. Okay, that is there. It is going to be non-specific, you know that. Skin, nothing is specific over here, they're all non-specific, but this is going to be specific. You know, antibodies are very specific. They're going to be produced, if this is there, if this antigen is there, this antibody is going to be produced. So it is specific to particular antigens, and basically, yeah. Now next thing, innate immunity has no memory, but here you have immunological memory, you have memory cells being produced over here. We just studied about it, so this is also correct. Example you give skin and phagocyte, example you give antibodies and T cells, that's all. There is a difference between innate as well as acquired immunity. This is just first part of the question. Now we have more to it. Mention the cells involved in accomplishing the acquired immunity. Mention the cells, this is a 3-marker question, that is innate and acquired. Then you have been asked, mention the cells involved in accomplishing the acquired immunity. So what are the cells that are involved over here? B lymphocytes and T lymphocytes are over here. B lymphocytes gives humoral immunity, okay, by producing antibodies as well as the memory cells. On the other hand, T cells which are there, they are going to produce cell-mediated immunity. Okay, got it? By the help of production of T helper cells or to cytotoxic cells. So cells of the acquired immunity is B lymphocytes and T lymphocytes. It will be good if at all, probably. You can, what do you say, explain a little bit more about it. You might get the easy goodie marks out there. Got it? I hope that makes sense. I hope that works. Cool? Yes? Done? Bye. Now, over here. This is a drill that I have. After every concept, I told you there will be something that could probably make you feel a little more happier. So innate or acquired, you have to choose from it, okay? So call it out for each one, no thinking time. Skin and mucous lining of the respiratory tract, innate or acquired? Skin and mucous lining, it's there from the birth. It has to be innate. It has to be innate. Antibodies made after a hepatitis B vaccine. A hepatitis B vaccine is given to me. Probably something is inserted in my body, which is my body is reacting to it by producing antibodies. The term antibodies itself, it has to be acquired. Why? Because humoral immunity is there. Okay, natural killer cells attacking an infected cell. Natural killer cells, remember, it's a cellular barrier. It's there from the birth. It has to be innate. It has to be innate. A faster response the second time the same antigen appears. The same antigen, the same pathogen appears the second time, it gives a faster response. This is going to be innate or acquired. Innate or acquired? Acquired. Why? Because why faster response? Your body is producing antibodies against it, have memory cells, that means acquired only. All of this is seen in the case of acquired. Tears and stomach acid there from birth, okay? It's going to be innate immunity, and they are very non-specific. Rejection of a transplanted kidney. Rejection of a transplanted kidney, obviously this is an acquired thing. Over here T cells are being involved, cell-mediated immunity is being involved, so this is going to be acquired. Now interferons released by a virus-infected cells. Interferons released by a virus-infected cell. These interferons, cytokine barriers, they are there from the starting point onwards, which is why innate. Got it? So rule of thumb, if it needs a previous exposure, it is acquired. Anyway, that might be too difficult for you, but yes, I hope this works. I hope this was understandable. I hope this class is helping you. And as I always say, if it is, what you have to do, hit on the like button, hit on the subscribe button for getting all the videos for all the chapters. We're almost there. We have covered all the most important chapters. I'll request you, go make sure, watch it. Okay, I put in my efforts and I'm pretty sure it is going to help you really, really well. Okay, done? Works? Okay, cool. Let's go ahead with the next portion which is there, and that is going to be active and passive immunity. So active and passive immunity is concept number 3. It comes under this immunity portion itself, and it's very easy to understand. Just think of it as a separate thing altogether. Okay, active and passive immunity, just think of it as a separate thing altogether. Cool. And over here they come under, we're talking about acquired only. That's the basic thing. It's not coming under innate. Okay. Now think of the scenario. The first scenario is going to be the example for active immunity. Okay. Jasmine Ma'am, for the first time, she got pneumonia. Her body produced antibodies against it, against the viral pathogen, whatever thing was there. Now, you tell me, is it happening naturally? Yes, could be, but that's not the question. Is it her body that is producing the antibodies to keep her safe? Yes. This is active immunity, where your own body is going to protect yourself. Okay? Now over here, it can be triggered because of a natural infection that I am getting, or probably suppose I am taking a vaccination. I'm taking a vaccination as in basically, as I said, a dead or a attenuated portion of one particular pathogen, a portion that can ignite a response in my body. I'm taking that and putting in my body. In that case, my body itself is producing antibodies. It's going to be anti-active immunity. I'm telling you, whenever your body is producing antibodies, we say it is what? Active immunity. Your body is super active over here. On the other hand, suppose when I talk about a baby, okay, a baby which is there, it is said that mother has to breastfeed the baby, at least for the initial time period. Why? Because the baby does not have too many immunological cells. Basically, it does not have too many antibodies in its body. So what is the good thing with the mother's milk? Mother's milk carries the first milk, colostrum which is there, it carries IgA, immunoglobulin A. These antibodies are transferred from the mother to the baby. Now, who is giving the antibodies? Is the baby producing its own antibody? No. Someone else is giving? Yes. It's still working fine? Yes. But since your own body is not actively producing it, okay, you call this as passive immunity. That's when here you say that antibodies are being produced by your body. Here we say ready-made antibodies are given. Ready-made antibodies are given. Now this can also happen, as I said, naturally in the case of a mother to the baby. In the mother to the baby. Okay, that is one thing that is there. In the form of colostrum, colostrum is what? Mother's milk. In the mother's milk, which antibody do you have? IgA. A for Amma, you can remember like that. IgA. Now, similarly, also always remember when you are in the mother's womb, your placenta is also going to help in transfer of some amount of antibodies are there. What is that antibody? IgG. For the first time, a baby receives the antibodies in the mother's womb itself, and the first antibody is going to be G. So, in gamed, G is the first one for the same reason. Then comes A. So the milk, after the baby is out, through the milk you get IgA. Now listen to me. That is again a natural scenario. Here when I got pneumonia, that was a natural scenario. My body was producing antibodies against it. Now I told the second scenario where I am getting vaccination. When I am getting vaccination, what is vaccination? I want to say the second scenario over here. I am going to talk about that. Vaccination is a case where, as I said, you are basically making sure you are inserting something in my body which is either weak or inactivated part of the pathogen. Why you are going to do that? Because you want to trigger my body to produce antibody against it for future protection. Next time if it is actually coming in and affecting me, I need protection beforehand itself, which is why what I am doing over here, I am going to have vaccination. It triggers my antibody production all of what do you say, beforehand itself. This is really, really good. You know, when COVID was there, a lot of people were getting affected with COVID disease. A lot of us were being said that you have to go take the vaccine. Why? Because the vaccine gives an exposure. It gives an exposure, and basically based on that our body will be ready with all the antibodies, the memory cells and things like that, such that one more time if at all the same thing comes, or in actual the same thing comes, my body will be reacting to it. Here the memory B cells and T cells are very, very active, are going to be enabled such that any future exposure which is there can be calculated or can be dealt with. That is known as vaccination. Okay, that is vaccination which you see over here. That is what I said. In active immunity, if at all you're getting an infection naturally, that's when your body is going to produce antibodies by itself, or probably during vaccination also, your body itself is producing antibodies. You say this comes under active immunity only. This comes under active immunity only. Vaccination comes under active immunity. Now, passive immunity, your body, you're getting ready-made antibodies from somewhere. It can be happening naturally from the mother to the child, such as through milk or through placenta, or basically it can happen like this also. For example, just understand, this is a very famous question, very common question which usually comes up. That is, suppose some person gets a snake bite. Okay, snake bite. That person comes to the doctor. You suppose you are the doctor. Will you say, hey, let's wait for the antibodies to be produced from the body. Let's wait for some time so that your antibodies are being produced. No. Why? Because for the first time that person has been hit by or bit by a snake, right? The person does not have any antibodies ready against it. It's for the first time. Now, I cannot wait for the secondary response to happen. Primary response is there and is going to be very, very weak. Very, very weak, because my body has never encountered something like this. So what do? At this point, I need ready-made antibodies. Give me the antibodies against it. If at all you have it, give me that. That's the thing, doctor has to give ready-made antibodies. This is known as immunization. Okay, vaccination is different, where you're making your body produce antibodies. Immunization is different because you're giving ready-made antibodies to your body, because you cannot wait for anything. You cannot wait for your body to produce it. Same thing, tetanus antitoxin, tetanus injection, tetanus injection has been given, antitoxin injection has been given to us. What does it contain? Preformed antibodies. Preformed means initially it is formed, okay, already it is being formed, it is just given to you. They are preformed antibodies that is given to you such that they can neutralize the toxins out there. So in tetanus or in snake bite antivenom or tetanus antitoxin, all of it contains the preformed antibodies. They are ready-made antibodies which is given, and this comes under passive immunization. Why passive immunization? Because your body is not actively producing antibodies, rather you are getting it from somewhere. So here also it can happen naturally, here also it can happen, as I said, through antibody injections and things like that. I hope that's clear. So you have two, active and passive. Active is where your body is producing antibodies. Passive is where you are basically taking the help of ready-made antibodies. It can be naturally done with the help of, in the case of mother and the child, or probably it can happen, as I said, through antibody injections in the snake bite, or antitoxin injection in the case of tetanus toxoid and things like that. Right? In active immunity, either infection or vaccination. That's the only thing. Clear? Clear. Now, colostrum, placenta, antivenom are the three passive examples KCET keep returning to. Yes. So they usually ask you, the snake bite antivenom, what is this type of immunization? Passive immunization, active immunization, passive immunity, this and that. Always understand it's going to be a passive immunization. Cool. Yes. Now here in this particular paragraph, they have mentioned one thing which most of us do not, actually it's a separate line altogether, but we generally do not tend to give more importance to it. But it's an important question. Okay, so using the recombinant DNA technology, new combinations of DNA, we can create it in the lab and all. Okay, with the help of recombinant technology or recombinant DNA technology, we were able to create a hepatitis B vaccine. And these hepatitis B vaccines were produced from yeast. With the help of yeast, we were able to produce a vaccine that is hepatitis B vaccine. Hepatitis B vaccine with the help of yeast. So remember that. Okay, so yeast, genetic material has been taken inside that. Hepatitis B is being caused by an organism. That organism's some part was being taken, okay, some part that can actually ignite our body to produce antibodies against it. So that was being taken, okay, and was merged with the yeast genetic material, and was it was made to act like a vaccine. Okay, it was made to act like in a way that our body will be producing antibodies against it. So I know it's very complicated, so I do not want to get into it. Okay, we are going to study about all of this in biotechnology related chapter, but as of now just remember that hepatitis B vaccine is there, and for the production of that you needed recombinant DNA technology, where you had used yeast as the organism. Okay, so do remember it. That's a question that comes up. Done? Done. Okay. Now, here is a question, a PYQ of 2024 in KCET. Active and passive immunity. The principle of vaccination is based on which property of immune system? The principle of vaccination is based on which property of the immune system? Memory, specificity, diversity, plasticity. Which is that property that we use in vaccination? Memory, Okay, we ignite memory such that basically next time it comes, we can kill the organism very, very smoothly. So answer is going to be memory. Is there any more questions? Let's check. Yes. Injection of an antidote against snake bite is an example of basically anything against snake bite. If at all we are injecting something against snake bite, this is going to be an example of what? Autoimmunity, active immunity, innate immunity, or passive immunity. Just when antibody comes, or basically when snake bite comes, just understand you are giving ready-made antibodies. It has to be passive immunity. It has to be passive immunity. There is nothing else that qualifies better. So the answer for this question is going to be D. Got it? Got it, ma'am. Next one. Match the items of column 1 with those of column 2 and choose the correct option. This is PYQ 2018. Hepatitis B, preformed antibodies, colostrum and PMNL. Okay. Hepatitis B vaccine, we know it is produced with the help of yeast. A goes with S, A goes with S, A goes with S. I just have one option, no, two options are there, so I'll cut off these two options. Now, I always tell you, match the following question, match A and basically D first. If D are different. Here D is R, here D is T. Let's check. D, PMNL, polymorphonucleoleucocyte, goes with either R or T. It goes with our neutrophils. It goes with our neutrophils. So this is going to be your answer. Your answer is going to be what? A. A goes with S. A goes with S. B goes with Q. What is B? Preformed antibodies goes with Q against snake venom. Yes. Colostrum, which is there, it's going to be having antibody A. Colostrum, first milk. Remember that? A for Amma. A for Amma. Before that, through placenta, IgG. Got it? Done. That's all. You can easily find the answer. Very, 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 very easy. Yes. Yes. Next thing that we are going is allergy, but before I go into that, I just want to remind you, because we have studied something like that, with immunization, smallpox is completely eradicated. Immunization means we are giving ready-made antibodies. With that, smallpox was completely eradicated. Right now, polio, diphtheria, pneumonia, tetanus, for this we are basically given vaccines. So vaccination and immunization, I hope you are clear with that. Immunization means ready-made antibodies. Vaccination means their, attenuated form or their weakened pathogen form is being given to your body such that your body produces a response by itself. Cool? That's all. It's not a very big thing. It's a very, very easy thing. So that is also done. Now we are over here. Where are we? Okay, let's solve just one more concept over here, and that is allergy. And then we'll take a short break, okay? So allergy is the next content that we have. And what is there in allergy? Who causes allergy and blah, 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 blah. There are so many things that is going to lead to a issue, okay, in our body. Okay, they are going to lead to an over-exaggerated response. It's not a normal response, it's going to be an over-exaggerated response. This over-exaggerated response is known as allergy. It can be caused because of dust, because of mite, because of this, because of that, lot of these things. You call them as allergens. Okay, you call them as what? Allergens. What exactly happens over here? I'll tell you. There's a cell's name that you have to remember. To cheese badi hai mast mast. Have you heard about that song? So we have mast mast. There's a mast cell, actually not mast cell. They are known as mast cells. Okay, and please do not mind, the reason I'm talking about all of this is because I want you to remember things, and basically with all this small things you might remember things a lot better. So mast cells are over here, and on the surface of the mast cells, what do you have, Baba? You have antibody. What antibody? Allergy, IgE. Allergy, IgE. Always remember, in allergy, IgE is going to be active. Now suppose one allergen came and bounded over here in the antigen binding site. What happens? The mast cells become super active. They're going to release two very important things. One is going to be histamine, and the other one which is there is going to be serotonin. Histamine and serotonin. What do? Let me tell you. They lead to vasodilation. As in your blood vessel, suppose it is like this. Now they are going to be dilated and they are going to look like this. What do? Why vasodilation? Because they want all the immune cells to come over here. Hey, there is an issue, come over here, come over here. But this is what? An over-exaggerated response. This was not needed. Now all of them are coming. Baba, when all of them are coming, when vasodilation is happening, at that time only you should understand that in our body there will be swelling. Okay, a lot of other issues is going to be coming up. This is actually a response that is happening up over here. This is going to be a response that is going to be happening up over here. Always remember that. Cool. Works. Okay, so what do we have? Here histamine, we have serotonin. Over here vasodilation is going to be there. There will be swelling. Okay, there will be swelling, there will be watery eye. Okay, we feel like it's just like a common cold symptom, but it is not going to be common cold symptom. It's going to be much more beyond that. So sneezing will be there, watery eyes will be there, runny nose, difficulty in breathing. These are all examples, or these are all symptoms of, what do you say, allergy. And as I said, it can feel like it's a symptom of common cold, but it's not. Okay, when you see difficulty in breathing and runny nose coming together, this is a lower respiratory tract disorder, this is a higher upper respiratory tract problem. All of them are coming together. Watery eyes is there. Just understand it's going to be allergy. And common allergens can be dust mites, pollen, animal dander, things like that. What is allergy? It's an exaggerated immune response to environmental antigens which are there. Causes? Release of histamine and serotonin from the mast cells. The antibody involved over here is IgE. This is a very famous question. Okay, diagnosis: small doses of allergens are tested on the patient. Small doses have been tested, and based off that, basically they come up with conclusion. So suppose you go to a doctor with all these symptoms. Okay, they will ask you, they will basically do the IgE test on you. If at all the IgE level is inflated, okay, it's very much elevated in your body, just understand that it's an allergic response. You get it? Treatment. This is equally important, and this sometimes we miss. So what are we talking about? First of all, before I go ahead with treatment, we have mast cells. On the surface of it we have antibody E. Okay, now when it is active, it signals the mast cells, they produce histamine, serotonin, that leads to vasodilation and things like that. Now if you want to subside this, if you do not want this reaction to happen, what are you gonna do? You're gonna give antihistamines. You might have seen it. Okay, some people take this medicine, cetirizine. Some small allergy comes, they take cetirizine. Why? Cetirizine is an antihistamine, and you feel sleepy and things like that. So it's an antihistamine. That's the easiest thing to remember. But you have two more things. One is adrenaline, and the other one is steroids. One is adrenaline, it's actually a hormone, okay, and the other one is going to be steroids. So adrenaline and steroids plus antihistamine, these are three things which are very important over here. Do not forget. I'm repeating again: antihistamine, adrenaline, as well as what do you have? You have steroids. These three things, please do not forget about them. Okay, let's just try to remember it, recall it. What is allergy? Exaggerated response to an antigen. Okay, what is an antigen? Sorry, what is an allergen over here? Not an antigen, allergen. Allergen can be dust mites, can be pollen, can be animal dander, it can be anything. Okay, which are the cells which are most effective over here? Mast cells. Which is the antibody which is effective over here? IgE. What is being released? Histamine and serotonin. What is basic diagnosis? Take small portions of allergen and check it out. If it's causing allergy, then be away from it. Yes. What is the treatment that is offered? Antihistamine, adrenaline, as well as one more thing, that is going to be steroids. Done, ma'am. Over here, now see. A person shows symptoms like sneezing, watery eyes, runny nose, difficulty in breathing after an exposure to certain substance in air. Which type of antibody is produced during such condition? IgG, IgE, IgM, IgA. What do you think is the answer for this? If at all a person have all of this, it is going to be IgE, because it has to be allergy. It was a simple one, no? So that is why I was not wasting your time. Otherwise, probably I would have made you think. Done. Only one question is there. Okay, one question is there. Got it? So these type of questions could be coming in your second PUC as well. So please take a note of it. I had actually a page for making all of it. But anyways, Now, the next topic that we have is going to be autoimmunity and lymphoid organs. I'm going to take a short break. My legs are paining. So I'll come back. Okay, I'll come back and we will complete the chapter. Then in one go, I hope until now everything is super clear. If you have any doubts, put it down in the comment section. Comment section, not in this particular premiere. And also if you're loving the class, let me know in the comment section itself. And let's see very, very soon. Okay, children. So let's go ahead with the next topic, that is autoimmunity and lymphoid organ. We will start with autoimmunity and then we'll slowly shift to lymphoid organ. Listen, autoimmunity which is there is a very, very fun topic, and I'll tell you why. So until now, what did we study? That basically we have WBCs in our body, and these WBCs are the one that safeguards us from any sort of pathogen out there. Any sort of pathogen which is there, it is going to kill them, because our body recognizes that this particular cell which is coming, or this particular thing which is inside our body, is foreign, and basically it's different from the cells that we normally have. Right? Yes. So what our body has a superpower to understand what's ours and what's foreign. Right? In autoimmune disorder, this particular ability is somehow lost. Our body is not able to understand what's ours and what's foreign, which is why it ends up damaging its own cell. Now, don't you think that's scary? Yes. And that's what exactly happens when someone has an autoimmune disorder. For example, in your NCERT, there is only one example given, and that is rheumatoid arthritis. What exactly happens over here? So, you know what? If you pull in your arm like this and you just do this, are you able to do it very smoothly? Yes. Why? Why are we able to do it very smoothly? The reason being that between our joints, we have a layer, a very thin layer. You call it a synovium. Okay, what do you call it? Synovium. This synovium is responsible for production of a fluid that is known as synovial fluid. And whenever you have fluid, okay, why do you go and oil your or grease your, your bike and stuff like that? The reason being that your cycles and all. The reason being that you do not want friction to happen there, right? It reduces friction. The same way, here we have fluid between our joints. The reason that we do not want friction to happen, we do not want the bones and all to just rub against each other and get damaged. That is why we have all of it. Now think of the scenario where the cells of the synovium is getting damaged by our own cells. It's saying that, hey, you are not ours, you move out. When that happens, what is going to be there? The problem is that over here, first of all, you will not have fluid, but before all of it, you will be having inflammation, you will be having pain. And basically, these are the symptoms that you can find in rheumatoid arthritis. It can go even worse. It can definitely go even worse. Why? Because your whole immune system is active right in between your joints. And your joints are not right over here. They're everywhere. You have joints everywhere, my dear children. And it is going to be a painful disease. Similarly, you have so many other diseases such as Hashimoto and all. If at all you're interested, I'll request you go and search for it. This is just a small topic in your NCERT, but it makes so much sense, which is why I thought I should be going ahead and explaining it in a best possible manner possible. Yeah. Anyways, so listen, this happens in our life also. Sometimes, we do not recognize what's our own and what's not. We go on like cursing ourselves. Like, Jasmine, you did that. Jasmine, you're stupid. Why did you do that? Who does that? And blah, blah, blah. In this whole process, we are damaging ourselves. You should know that. So we should not curse ourselves. Rather, we should make ourselves understand that, hey, you did wrong. Probably we have to make things a lot better. This is what we have to change. So just a small moral reminder for all of you. Okay, anyways. So what happens in autoimmune disorder? The body mistakenly attacks its own cells. That is what is going to happen. Causes, genetic and other still unknown factors. It can be genetic reason. It can be some other reason, but it's still unknown. It's not, people are searching about it, but they are not able to find a rock solid answer for it. Now, example, rheumatoid arthritis, which causes joint inflammation. And remember, autoimmunity is a failure of self-recognition. What is it? It's a failure of self-recognition. Okay, and a pathogen problem. It's not infectious. It's not going to be infectious. If I have rheumatoid arthritis, get is, it's not like you will also have it. Okay, it's not like you are also going to have it. Please do note that. So it is not infectious. Just remember, it's a disease where our body fails to do self-recognition. Okay, self-recognition failure happens over here. Done. So we have done the types of immunity and blah 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 blah. A lot of things are there. We spoke about allergy, the exaggerated response, and we spoke about this also where our body fails in self-recognition. Now we are going to talk about the organs where your B lymphocytes and T lymphocytes are going to be made. Okay, where they're going to mature, where they're going to act, and all of it. It's going to be a super interesting topic. Listen to me, and it's usually a 5-marker question that comes from this particular chapter. So lymphoid organ, Baba, we have 2 types of lymphoid organs. I can categorize them: primary lymphoid organs and secondary lymphoid organs. Okay, the primary ones are the ones where your B and T cells and everything are going to develop for the first time. Okay, they are going to form there for the first time, and basically they are going to mature. Okay, mature into what? Mature into antigen sensitive lymphocyte. This term is very, very important. What do you mean by antigen sensitive? Antigen is what? Pathogen. Antigen is basically pathogen. We're talking about pathogen. Right. So when I say you become antigen sensitive, that means that your body recognizes the antigen, and probably next time the same antigen comes, it is going to fight against it. Right. So when I say antigen sensitive, it means that it knows its enemy. The cells are going to recognize their enemy. They know that, okay, if an antigen comes, I basically have to respond to it. That is what I mean by antigen sensitive. So when we are kids, we are very innocent. Okay, when we grow up a little bit, we are aware about a lot of things. We know what's good and what's bad. The same thing you can imagine. Okay, so this is the place, primary lymphoid organ is the place where they are going to form, okay, and then they're going to mature into understanding that basically this is an antigen and I have to kill it. That's all. So I'll say that they mature into what? Antigen sensitive lymphocytes. They become antigen sensitive lymphocytes. Now they just recognize it. They just recognize the antigen. That is what I mean. I don't mean that they're going to fight against the antigen. That is not going to happen in the primary lymphoid organs. In the primary lymphoid organs, it's like the schooling. Okay, we know what's good, what's bad. In real life, you're going to come into the real life later on where you're actually going to see the bad things. And probably you might be fighting against it. Okay, so you're just becoming antigen sensitive. There's a new term that you will hear, and that is becoming an effector cell. Becoming an effector cell. Effector cell means basically now it's fighting against that antigen. Okay, that means it's showing its effect out there. You get it? So primary lymphoid organs is where it becomes antigen sensitive. Secondary lymphoid organs are the place where the cells are going to become effector cells. They're going to do the fighting scene. Remember, this is very, very important. That is why I'm stressing a lot on it. Okay, now what are the primary lymphoid organs that you have in your body? Okay, we have bone marrow. That is the first one that we have. Bone marrow. If you see a bone, okay, inside the bone, you have a space. Okay, you have a space which is basically filled with red and yellow marrow. Red and yellow marrow. Yellow marrow have cells that is going to form fat. Okay, red marrow have hematopoietic stem cells. Basically, I'll say these cells have the capacity to become different type of, blood cells. It can be RBC, that is your red blood cells. It can be WBC, or it can be platelets, any of it. They have the potential to become different type of blood cells out there. Okay, that is there where inside your bones you have red marrow. Inside your bone you have red marrow where everything like this is happening. And when I say that here WBCs are produced, white blood cells are produced, or RBCs are produced, I am also talking about a type of WBC which you call as what? Lymphocytes. In lymphocytes, your B and T lymphocytes are also going to be formed over here. They develop over here. Got it? In your bone marrow itself. Cool, cool. Now listen to me very, very carefully. The B and the T lymphocytes are being formed over here. B stays here itself. So bone marrow, B, you can remember like that. B lymphocytes, they stay back over here itself and say that I am going to mature here itself. I do not want to live this particular place. Some people are homesick, right? So this B lymphocyte is homesick right there. Now, what about T lymphocyte? T lymphocytes that says that, okay, you have given birth to me. I have been formed over here, but I cannot stay over here. I want to explode. So I'm going to go to the next place that is known as thymus. that is known as thymus. This is a whole separate thing that we have. Where is your thymus? Thymus is right over here behind your sternum. You know, you have a sternum over here onto which your ribs is being attached. This is known as chest bone. So just behind your sternum you have the thymus, okay, and the thymus which is there, as you age it is going to become smaller in size. Anyways, this thymus is the place where the T lymphocytes is going to go mature and become antigen sensitive. So what did we study? We studied that primary lymphoid organs are the place where the development happened, where the maturation happened to antigen sensitive lymphocytes. There are two primary lymphoid organs. One is going to be bone marrow, where basically all the blood cells, all the different type of blood cells are being produced, and by that I mean the B and the T lymphocytes are also being produced over here. The B lymphocytes is going to stay back over here itself to mature. Rather, when you talk about the T lymphocytes, they are going to move to the thymus. They will be moving to the thymus for the maturation process, and they become what? Antigen sensitive there. That's all. That's all. Okay, so that is written over here. Development and maturation of antigen sensitive lymphocytes. Bone marrow produces all blood cells. B lymphocytes also mature here itself. What about thymus? Maturation site for T lymphocytes, which is why the T over here stands for thymus itself. It shrinks with age. As we age, it is going to shrink also. Got it? That's all. Okay, that's all. Now we're going to talk about the secondary lymphoid organs. What about the secondary lymphoid organs? These are the place where for the first time your B and the T lymphocytes are going to be face to face with the antigens out there. And probably they're going to kill them. So these locations where they actually meet with the antigens and going to kill them are known as what? Your secondary lymphoid organs. Okay, the first lymphoid organ that we have over here is spleen. It's more located towards your stomach region. Okay, it's located towards your, actually below, a little below your stomach region over here. And what exactly happens in the spleen? So spleen is an organ which is known as graveyard of RBC. It's known as graveyard. What do you mean by graveyard? You might have seen the people bury people when they die, right? That's that place where they bury people. That's known as graveyard. Graveyard means after the death, what do you say, where you bury people and all, that's the place, right? Right. Now the spleen is known as graveyard of RBC. That by that I mean the old and the worn RBCs, while they move through the blood vessels of the spleen, what is going to happen? Our body has a mechanism to trap them and basically break open them. You have in the RBC, what do you have? You have hemoglobin, you have iron and all. You take the iron and everything, and rest of everything is going to be, what do you say? It's going to be damaged, or there will be some use done to it. Okay, there will be something done to it. But that's not our concern. Our concern is that while the blood is being traveling around, there will be some pathogen also coming over here. There will be some pathogen also which is going to come inside our spleen, because it comes as a part of blood circulation. Now when it comes, you should understand this very, very important thing, that is, when the pathogen is going to come, there will be one more guy ready up over here. There will be one more guy ready up over here. And who is this particular guy? These are going to be your lymphocytes. So basically these are sites where lymphocytes are going to be there. These are sites where lymphocytes are going to be there, and they're going to counteract on these cells out there, the damaging cells, and they're going to kill them up. Cool. Which is why I'll say spleen is a secondary lymphoid organs, because I have so many lymphocytes up there doing their job. So what does the spleen do? Filters blood, contains lymphocytes and phagocytes that trap the pathogens out there. Okay, aren't the lymphocytes becoming effector cells over here? Aren't they killing it? Yes. So which is why I call spleen as a lymphoid organ. Similarly, you have lymph node. If you remember, I spoke about lymph node. Okay, lymph node. We spoke about it during elephantiasis, and I told you that elephantiasis, when we studied about it, it is going to be of help for you. It is going to be of help for you. Where is it that? Yeah. Here we studied that in between the cells, from the capillaries, lot of things is going to be oozing out, and to carry all of it, you have lymphatic vessels. In the lymphatic vessels, if you remember, you have lymph nodes over here. You have what? A swollen region over here, lymph nodes. What does a lymph node contain? It contains so many lymphocytes. They contain so many lymphocytes. So whenever from the fluid that comes from your blood vessels, suppose it has any pathogen, and this pathogen is now between the cell, the fluid has been taken into the lymphatic vessel. Now the pathogen is basically within the vessel. This pathogen, when it comes over here, it's going to be killed by the lymphocytes, because this is another site for action. So you have lymph nodes, and you have it throughout your body. You do not have it only at one place, you have it throughout your body. Please do remember it. And it's a very, very, very important thing. Okay, it's a very, very, very important thing out there. So over here, where are we? Yes. So we have lymph nodes, structures in the lymphatic system that is going to trap the antigens. Done. That was the second lymphoid organ that we had. Now the next one that we have is MALT. What do you mean by MALT? It is mucosa associated lymphoid tissue. Now this is not something that you have to mug up. Listen to me carefully. Your whole tract, whatever tract you're talking about, it has multiple layers. Mucosa, and everything is there. There is one layer which you call as mucosa. Okay, mucosa layer. And in this mucosa layer, suppose there is any tissue that is associated with it, as in basically in the suppose when you go to intestine, when you talk about your intestine, in your mucosa layer you have a lymphoid tissue which you call as Peyer's patch. What do you call it? Peyer's patch. What does this Peyer's patch do? They are richly supplied. They are known as lymphoid tissue. The reason being that they are richly supplied with blood vessels. Okay, sorry, not blood vessels, lymphocytes. So they are going to trap the pathogens out there. Similarly, at different places of your body. Okay, here when you talk about your throat region and all, you have tonsils. What is tonsil? It's a lymphoid tissue which is associated with your mucosa layer. Your innermost layer over here has a lymphoid tissue over here. This is known as tonsil, and this tonsil is richly supplied with what? Lymphocyte, which is why if you have any sort of infection, it gets swollen and it pains. Why? Because your body is actually fighting up there. Your body is trying to fight up there. Okay, so these tissues which are associated with your mucosa layer, you call them as mucosa associated lymphoid tissue. Okay, MALT. And actually 50% of the lymphoid tissue of the body in the respiratory, digestive, urogenital tracts, basically they come under MALT. Okay, 50% of the lymphoid tissue of your body is basically MALT itself. 50%. And as I said, example for that, in the digestive system, you have what? You are going to have the Peyer's patch. You're going to have the Peyer's patch in your intestine. Similarly, over here, the starting of the respiratory system and all, what do you have? You have your tonsils. You have your tonsils. They are the lymphoid tissue which are associated with the mucosa layer of your body. And 50% of the lymphoid tissues of the body are like this only. Okay, so please do remember it. Now I'm going to show you the pictures which makes you to understand things a lot better. So primary lymphoid organs are where the lymphocytes are going to be made and mature, and secondary lymphoid organs are where they are going to become effector cells. Okay, over here, this is the bone marrow that we have. This is the bone marrow that we have. So inside the bone you see red color thing and a yellow color thing. So we have yellow marrow and we have bone marrow. Sorry, we have red marrow. Red marrow is the place where what do you have? You have blood stem cells. You call this as hematopoietic stem cells. Do not need to remember that big term, but it's okay. Okay, so you have stem cells out there which are going to produce different types of different type of blood cells. It can be red blood cells, it can be white blood cells, it can be platelets. Under white blood cells you have what? Lymphocytes. You have B and T lymphocytes which are going to be formed. So B lymphocyte stays back here only for maturation and to become antigen sensitive. The T lymphocyte is going to go to the thymus. It is going to go to the thymus, which is right behind your sternum. Cool. Works, and T lymphocytes are going to mature up there. Now over here, if at all you see, here there is a small structure. I cannot zoom in further, I think. Can I? No. I cannot zoom in further, otherwise I would have shown you. Here, right beside your stomach over here, you have spleen which is there, which is known as graveyard of the RBC. Here, when the blood comes along with any pathogen, your WBCs which are there, lymphocytes are going to be super active and they are going to damage anything that is there to damage our body, which is why you call this as a secondary lymphoid organ out there. And you say that the cells become effector cells. They are not antigen sensitive anymore. They are not just antigen sensitive anymore. They are going to be effector cell. Similarly, all over your body, throughout your body, I told you have lymphatic systems. This bulge thing that you see over here, they are going to be lymph nodes. Okay, they are going to be lymph nodes, and I told you whenever you go to the doctor saying that you are sick and all, sometimes the doctor check over here. Why? Because they are checking if at all if there is any swelling in your lymph nodes. If there is a swelling, it means that probably your body might be fighting against this. Okay, similarly, I did not have the picture for the Peyer's patch and all. Peyer's patch, which is there in your digestive system, and your tonsil, which is right over here, they are all mucosa associated lymphoid tissue, and 50% of your lymphoid tissue of your body is basically associated with MALT. Cool. That's all. Now here is a 5-marker question that had come in your second PUC, and I told you this particular concept carries 5-marker. So that's why I said that is important. What are the lymphoid organs? Write the functions of the following in response to the immune system in our body. So what are lymphoid organs? Write the functions. So what are lymphoid organs? You have to mention that and write the functions of the following. Following as in you have bone marrow, you have thymus, you have spleen, you have lymph nodes being mentioned in your question. You have to answer that. So first of all, let's start with what are lymphoid organs. Organs where the origin, maturation, proliferation as an increase and all of lymphocytes are going to occur. There are primary organs such as bone marrow and thymus, which produces antigen sensitive lymphocyte, which migrate to what? Which moves to secondary lymphoid organs such as spleen, lymph nodes, and become effector cells after the antigen exposure. After they come in contact with the antigen, they become sensitive. They become effector. Okay. Now bone marrow, the main site where all blood cells including lymphocytes are formed, provides a microenvironment for B lymphocyte maturation into antigen sensitive cells. Done. What about thymus? Primary lymphoid organ for T lymphocyte maturation. Immature T cells become antigen sensitive T lymphocytes over here. That is also done. Yes. Now spleen, secondary lymphoid organ that filters blood and traps the blood-borne antigen, contains lymphocytes and phagocytes that help antigen sensitive cells into becoming what? Effector cells. Done. Lymph nodes trap antigen from the lymph entering the fluid, entering the body, provide sites for lymphocyte antigen interaction. Same thing that we studied so far. Okay, if you write this answer, you get straight 5 marks. But for that, you should not be mugging up things. Mugging will not help you. From the malt portion, okay, mucosal associated lymphoid tissue and all, you might get an MCQ based question. Theoretical question usually does not come up. Okay, but from the other part, you will get a theoretical question. As I showed you, this had come in your second PUC. Cool. Works, understanding, and everyone over here who is enjoying the session, who is able to understand things, make sure you hit on the subscribe button right now. Okay, now we are going to go ahead with HIV/AIDS, one of the most important thing in this particular chapter. Actually, everything is important, but still. Okay, so what is HIV and what is AIDS? Listen to me very carefully. HIV is actually human immunodeficiency virus. What do you mean by that? It's a virus that makes human body immune deficient. Immune deficient means that we are not going to have a strong immunity over here. So human immunodeficiency virus. It's a virus that is going to cause the disease. This is a disease. What is a disease? Acquired immunodeficiency syndrome. So what do you mean by that? This is a disease that we acquire during our lifetime. We get it during our lifetime. It makes us immune deficient, and basically it is going to show a lot of symptoms. The group of symptoms together, we call them as syndrome. We call it as syndrome. So human immunodeficiency virus, HIV, is going to cause acquired immunodeficiency syndrome out there, and that is what we are going to study about. If at all that particular, wordings are too difficult for you to remember, you're going to remember it slowly. Okay, just don't think about it very much right to this point. Okay, while we talk about HIV again and again, it will be filled in your brain automatically. Cool. So what is AIDS? A deficiency of the immune system acquired during life. It is not congenital, as in you're not born. It's not a genetic disorder that comes along. Okay, it's an infectious disease that you get. Okay, now syndrome, what do you mean by that? A group of symptoms associated with immune failure. Now, first reported in the year 1981, it has since caused more than 25 million deaths globally. It was first reported in 1981, and it has a very bizarre story, which if you want, you can go and search. But yes, so 1981 was the year where it was being found, and causes HIV, human immunodeficiency virus, a retrovirus with an RNA genome enclosed in a protein envelope. Now that is important. Over here, when you talk about this particular organism, okay, it is going to have this particular organism that is your retrovirus. Okay, it's a retrovirus, which are a group of viruses that usually affects human being only. Okay, so these retroviruses which are there, they are going to have a protein covering around them. protein covering, and inside there they have a genetic material, and this genetic material which is there, this genetic material which is there, it is going to be made up of what? RNA. They do not have DNA as genetic material, they have RNA. And I'll tell you something which you can probably remember. It's not given in your NCERT, but it's good for you to remember, such that you do not make any mistakes if any question comes in the form of MCQ. The RNA which is there over here, you see this is single stranded. This is going to be what? Single stranded. And how many of them do you see? You see 2 of them. You see 2 of them. So there are 2 single-stranded RNA. Remember, they are not double-stranded. They are not coming together. They are single itself. Single, not ready to mingle. Okay, so they are going to be single-stranded. SS is what you write it. Single-stranded RNA. How many of them are there? There are almost 2 of them, ma'am. And basically, we say that it is having an RNA genome because of the same reason. It does not have DNA. Now, it is covered by what? A protein covering, which is basically a protein capsid, which is there. Done. It's what is a retrovirus. It's going to be a retrovirus. So we have rhinoviruses, we have so many things, so do not get confused. Rhinovirus caused common cold, and over here retrovirus is the one that is going to cause HIV. Important. HIV/AIDS does not spread by touch or casual physical contact, only through body fluids. So basically, if I have HIV, God forbid, okay, and I give you a shake hand, will you also have the disease? No. Because, as I said, it's not a disease that is going to be transmitted merely by a touch and things. Oh, I didn't say it, but I'm just going to talk about it. It's not going to be merely transmitted by a touch. You need the exchange of body fluids, and by that I mean any type of fluid which is there. It can be genital fluid, it can be basically your blood, it can be anything like that. Okay, now there's a common question that comes around, and that is, mosquito bite, can it cause AIDS? I'm going to answer that, okay, but before that, let's talk about the actual transmission modes. Okay, so just going ahead with whatever we study right now. What do you call HIV? Human immunodeficiency virus. What is it called? Cause acquired immunodeficiency syndrome. Okay, ma'am, done. When was it reported? 1981. For the first time it was reported in 1981. What is it actually? It's a retrovirus. Okay, what genome does it have? RNA or DNA? RNA. What type of RNA? Single-stranded RNA. ssRNA. How many of them? 2 of them. Done. Does it have a protein coating? Yes, they have a protein coating, ma'am. Okay. Does it transmit by a mere touch and all? No. It transmits by transfer of body fluids, right? And to get better understanding of this, let's talk about these things which are given over here. First thing, if you have sexual contact with an infected person, if you have sexual contact with an infected person, what is going to happen? The fluids are going to be exchanged. Your body fluids are going to be exchanged in the process of sexual contact, which is why a person, if at all they have HIV, you can get the disease. Okay, you can get the disease. So who are those people who are going to be in high risk category? People with multiple sexual partners are the people who are in high risk groups. So we're going to study it parallelly. So these two are different type of questions. What are the different modes of transmission and who are under high risk categories? So basically, if we know this, we know this also. There is no mugging up thing. Okay, sexual contact with what? With an infected person. Now, over here, we have studied in the previous chapter, that is previous to previous chapter, that is reproductive health, that there is condom, and condom is the only what do you say, contraceptive device which can prevent HIV/AIDS as well. Yes, the reason being that condom covers the entire penis, or basically the entire vaginal region out there, and which is why the fluids might not be exchanged. But again, there are chances of failure. So no. Okay, so over here, sexual contact with infected person is something that can cause the disease. Next thing, transfusion of contaminated blood or blood products. Now, as blood is a fluid, so if someone has HIV/AIDS, and basically suppose I go to a hospital and I have immense bleeding, okay, some problem, internal bleeding, and I met with an accident, something happened. Okay, in this particular scenario, what is going to be there? I need blood. Now, in the hospital, they are going to take the blood from the blood banks and things like that. Now, these blood banks and things, if at all they have not checked the blood properly of the person before taking, what is going to happen? There are chances that that blood could be infected. The other person also does not know that I have HIV. The other person does not know that that particular person has HIV, which is why they gave the blood. But apparently, the blood bank people also didn't check it. Now, you're giving it to someone else. There are chances that they can get it. Okay, so the transmission of contaminated blood or any blood products can also lead to the disease. Now, who are the high risk people? Individuals needing repeated blood transfusions. So, you know, there are so many diseases that we have. For example, just a second, we have so many diseases such as thalassemia, about which we studied in Principles of Inheritance and Variation, where you need blood transfusion, repeated blood transfusion. So people who are having these diseases, they come under high risk category. Why? Because of the same reason. If at all they're not taking blood from a very good place out there, it can lead to issues. Next thing, sharing infected needles, example by intravenous drug users. So there are drug uses. Okay, you might have heard about eating drugs, snorting drug and things like that, but you might have also heard about in movies and all, they inject the drugs, right? This is intravenous drugs. You're putting inside the veins. The drugs are being basically put inside your body. That is what you mean. In this particular case, suppose the needle goes inside. Your needle is going to be wrapped around by the blood of that person. Now the same needle is being used to put drug inside you. The blood which is there, it is now in contact with your body. Right? So intravenous drug users or sharing, if at all you share infected needles. Now there's a case of drug users, but apart from it, in the hospitals also, previously lots of people used to have diseases. Why? Because they use the same syringe every time, but now it's not like that. In front of you, they are going to open and show that this is a sterilized new needle which is there. Otherwise, don't let them use it. Okay? So that is how it works. So who are the people who come under high risk category? The drug addicts using what? Shared intravenous needles, they come under high risk category. And also, if at all you use a contaminated syringe and all in hospitals, that can also lead to diseases. Please note that. So that is another transmission mode. Next one is mother to child transmission through the placenta. It's a very rare thing that happens. Okay, it's a very rare thing. It's not like every time during childbirth a person has to have it, because now you have provisions. You get antiretroviral drugs. You get so many drugs during pregnancy and all, such that there is nothing like this happening and the baby is being safeguarded. But yes, it can happen. Mother to child transmission through placenta, and it said even through breast milk can happen. Even through breast milk can happen, but there is no solid evidences and all. Still research and everything is going on. But yes, this is there. Mother to child transmission could happen through placenta. I'm talking about breast milk. Breast milk is totally different. Through placenta, yes, it can happen, because blood can be exchanged at least during the delivery time. Okay, at least during the delivery time. So children born to HIV infected mothers also come under high risk group. It's not like everyone will have it. There is no guarantee about that. The reason being that I know a person who is basically, whose husband was HIV infected, which is why the lady was also HIV infected. Their baby is not. Okay, their child is not, and they are living a very happy life out there. Okay, there is no issues around it. So that's why I'm telling you, it's not like it's a necessity. It can happen if at all the blood and everything is being exchanged. Usually it does not, but during delivery there are chances that it can surely happen. Cool. Now, so what are the different transmission modes are there? Sexual contact with an infected person. Okay, next thing, transmission of contaminated blood or blood products, sharing infected needles, or mother to child transmission. In any of these cases, did you see anything like that? It does not include fluids. Everywhere fluids are there. Sexual contact, there is fluid, genital fluids are there. Transmission of contaminated blood is there, blood is a fluid. Sharing infected needles surrounded by blood, same. Mother to child transmission through the placenta, again, fluid exchange is happening out there. So when I say a person having a shake hand, a person who is having HIV, giving a shake hand to you, do you think that you will transmit the disease? You'll get the disease? No. Okay, so it's a myth. So that is why we should not be stigmatizing them. We should not be saying that, hey, you have HIV, please don't be friends with me. That should not be happening. They have their own shares of struggle. They make sure that there is no contamination happening at the best capacity out there. So yes. Okay, that is how it works. Now the mosquito related question. Okay, the mosquito. Ma'am, a mosquito that has bit HIV patient, if at all it comes and bites me, will I have HIV? Again over here, mosquito drinks blood, does not give you blood. Papa guy, why will it give back the blood? It worked really hard for getting that particular blood, right? So when mosquito comes and bites, I always tell you that basically it's the saliva that goes around, not the blood. Okay, so obviously there is no mosquito-based transmission also happening. Now there's a question that was asked when I used to teach in an academy over there. The student asked me, ma'am, can HIV transmit through kissing? Now that's a very common question, and I think that you must know that. You are in that particular age group, probably a lot of exploration, everything would be happening. So merely by a kiss, it will not be, what do you say, exchange, it will not be happening. But if a person who has HIV, not aware about HIV disease out there, and has some ulcers, okay, has some broken inside their, what do you say, mouth and all, if they have some broken ulcers from where the blood and everything is oozing, and basically if we have a lip to lip kiss out there, and there is a chances of the fluid exchange and things like that, there is a chance for transmitting the disease, which is why stay safe, my dear children. It's better to be in the safe zone and not to explore beyond a point. So yes, this is what it is, and this is a very important thing. I don't think there's a shame over here to talk about it, because if anything happens, okay, that is even more riskier. So yes, that is it, and this is a very important, what do you say, second PUC question, that is transmission modes, and also people who come under high risk groups out there. Cool. And mosquito bites, shaking hands and sharing food do not transmit HIV. Okay, now listen to me carefully. We're just going to go close it up and talk about the transmission modes. First thing, sexual contact with multiple people or sexual contact with infected person. Transmission mode, first one. Second one, transmission of basically blood or blood products which is there, contaminated blood or blood infected products out there, blood related products. Next thing, basically sharing of infected needles that can cause a disease. Lastly, mother to child through placenta. These are the four things which are there. What is a high risk category? High risk category, first thing, people who have multiple sexual partners. Second thing, people who undergo repeated blood transfusion, if at all they have some diseases like that. Third thing, people who are addicted to drugs and basically use intravenous drugs out there. And fourth thing, basically a child born to a HIV infected mother. Got it? Yes. So that is how it is going to go. I hope that is clear to you. Now, what happens if at all the HIV virus gets inside your body? Now, this is a 5-marker question that could be coming up. Give the schematic representation of HIV virus, okay, attacking our own body. So what is a schematic representation? Let's talk about it. Over here, you have your retrovirus, that is HIV, human immunodeficiency virus out there, which has a viral RNA code. What do you mean by that? It has a viral RNA. RNA is the genome out there. It has a viral protein coat also. It has a coat which is made up of protein. Okay. Now what happens? In our body, if you remember, we spoke about cellular barriers. And cellular barriers, there were polymorphonucleoleucocyte neutrophils and macrophages which were responsible for what? Phagocytosis, for taking in the cell and killing it up, right? So these macrophages are basically the first one to be attacked by HIV. These are the first one to be attacked by HIV. But the actual target of HIV is not macrophages. It is going to be what? T helper cells. Didn't understand? I'll tell you. So if you want to get over here, you first need to get over into the macrophage. There's a reason for that. I'm going to talk about that right over here. So this cell which is there, just imagine that this is going to be what? A macrophage which is there. What is going to happen? The viral RNA is going to, or the virus is going to come over here. When it comes over here, basically, since it's a macrophage and all, it can get inside. It can easily get inside the cell. Okay, now it is inside the cell. What exactly happens is that over here, it gives its viral RNA. The viral RNA that it carried, it basically transferred that into the cell. Right? So you have the viral RNA right over here. Now, pause it right up there. Come to this particular own cell's nucleus. In our nucleus, what do we have? We have DNA or we have RNA? As genetic material, we have DNA. DNA which is there, we know it is going to give its information to an RNA, and RNA basically gives an information to form the proteins. That is how it usually works, right? So DNA gives information to make RNA. RNA is being made over here. This RNA moves out of the nucleus, and the RNA, basically with the help of ribosomes, they are going to help in the formation of proteins. That is how it usually works. Now, this virus that has come over here has come with a mind that I have to take over the territory entirely. So if at all it wants to do that, it has to be one amongst them only. But this guy already had a RNA as its genome. Then what do? Listen to me carefully. While it comes with 3 different enzymes. 2 of them are given in your NCERT, and at least 2 of them you try to remember. The first enzyme that it carries is going to be reverse transcriptase. Reverse transcriptase. What do you mean by that? What does it do? So for those of you who probably have not studied molecular basis of inheritance, just giving you a gist over here, you have your DNA. This is your DNA. Your DNA is going to make an RNA, mRNA actually. You call this process as what? Transcription. Transcription. And this RNA basically is going to move out of the nucleus. It is going to attach with a structure which is known as ribosome. These ribosomes are going to help the RNA in basically making up the proteins. This process is known as translation. So the information is given over here, the information is translated to produce proteins over here. So first we have transcription, then we have translation. This is how things are going to work. Okay, now listen to me carefully. In here, you have an RNA and the cell has a DNA. If you want to be one amongst them, basically you have to convert your thing into a DNA itself. So it undergoes transcription, but it is not a normal transcription, it's basically ulta of it. So what do I say? It's going to be reverse transcription. It is going to be reverse transcription, and for that it has an enzyme which you call as what? Reverse transcriptase. So viral DNA is produced by what? Reverse transcriptase. You have it, you have the DNA which is being produced. Now when you have the DNA, okay, when you have the DNA, this DNA is now slowly going to get inside the nucleus. Now inside the nucleus, it has to integrate. It has to integrate with our normal DNA. For that, you need another enzyme out there which you call as what? Which you are going to call as integrase. What do you call it? You call this as integrase. So first reverse transcriptase for making what? A DNA out of RNA. Now this DNA is going to get integrated into our genome out there. For this you need an enzyme that is known as integrase. Now it has integrated. It has integrated. What exactly is going to happen? The DNA over here now forms the RNA, and the RNA forms the protein. But what protein? Viral protein. What RNA? The viral RNA. Okay, the body is going to make its own DNA and protein and everything like that. But the portion where this got integrated, the DNA is also there, this DNA is also there. So it can make its own RNA, it can make its own protein. It can make its own RNA and it can make its own protein, and tada! What have you done? Basically, haven't you created baby viruses all over here? Yes, you have done that. Over here, new viral RNA is produced by the infected cell. New viral RNA is being produced and new viruses are also being produced. Why? Because proteins are also being produced. These RNA are going to give information to form the proteins also. So the proteins are also being made. Now you have baby viruses which are there. Now these baby viruses which are there, they are going to move out of the macrophages. They have already increased their number. They have increased their number, and now they are going to affect what? Your T helper cells. And if you remember, T helper cells was a helping one. That is why you call it helper cell. It was helping everything to get mediated very, very easily. Hey, when something attacks, it goes and say, hey, you become active. Hey, you become active. Everyone becomes active because of the information that was given by what? The T helper cells. Now, if this guy is being affected, what is going to happen? Our immune system is going to go tush. Our immune system is going to go low. That is exactly what is going to happen. And this is very, very, very important for us. So I'm just going to read it once. Okay, you have your retrovirus, the viral RNA code, and you have the protein code out there. Together they come over here, affects your macrophages first. The macrophages, what is going to happen? The RNA gets introduced into the cell. The viral RNA is going to be converted into the DNA by reverse transcriptase. Reverse transcriptase enzyme which helps in reverse transcription. Now you have got the DNA. It's not converted, it's basically it helps in the formation of the DNA. Okay. Now viral DNA incorporates into the host genome with the help of another enzyme, that is integrase. Now it's there in the host genome. It uses our machinery to produce what? To produce RNA, and these RNA can be helping produce the production of what? Proteins. It makes so many other viruses. These viruses are going to move out and are going to affect the other cells, especially the T helper cells, because that is what they wanted to attack. Your macrophages over here, I will give it a name. I'll say is the factory It is going to be the factory of HIV virus. Why factory? Because here is where it is going to divide itself and increase its number. So this is going to be a factory of HIV virus. Got it? Now I'm just going to revise it. Just give me a second. Okay, so over here, after the infection, what is going to happen? Virus entry. After infection, HIV enters the macrophages. Replication happens. The RNA genome is converted to viral DNA using what? Reverse transcriptase enzyme. Do not forget it. And you do not have to mug it up. Remember, reverse of transcription, which is why you need reverse transcriptase. Okay. The viral DNA which is there integrates into the host DNA with the help of what? You have integrase enzyme. You have integrase enzyme. Macrophages acts as HIV factories, continuously producing new viruses. I told you it is going to act like a HIV factory. Lastly, helper T lymphocytes attack. HIV enters the T helper cells, replicates and produces progeny viruses there also. These viruses infect more T helper cells, leading to their progressive decline. And when they are declined, your immune system becomes deficient. Okay, and that is what you mean by human immunodeficiency virus. And what does it cause? Acquired immunodeficiency syndrome. Now you're going to show a lot of symptoms together. That is why you call it as syndrome. This particular picture which is there, you will be asked to draw this. You will be asked to draw this. Schematic representation is being asked. So we should just know about this. Cool. Is it too difficult for us to remember? Is it too difficult for us? I don't think so. It should be. It's an easy diagram, not too difficult. Okay, if you want, probably I can, but I don't think there's a need for it. It's a very straight and simple thing. Right? Right? Or do you need it? Well, whenever I go and come in front of, what do you say, camera, I feel like all my dear children need some help. So I go ahead and do everything. But then I realize that time is going. Okay, so listen, this is a viral protein. This is going to be the viral RNA that we have. Right? Over here, this is going to come and it's going to affect a cell. So this is suppose the cell that we have. This is suppose the cell that we have. Over here you have the nucleus. In the nucleus, what do you have? You can just make it like this, it's fine. This is going to be your DNA. And what do you write? Host DNA. Because this is a host for the virus. This is going to be host DNA genome. Host DNA genome. Now while it comes, you can just make it like this. Over here you have the thing. The viral RNA is being introduced. Write it like this. Viral RNA is introduced. Okay, then what happens? The viral RNA is now with a different, you can probably use a pencil over here and just mention viral RNA is now going to make viral DNA. This is viral DNA that is being made. And for that, does reverse transcription. Does reverse transcription, I'm just writing it over here because there is no space, with reverse transcriptase enzyme. Just underline this. This is very, very important. Okay, you have got the viral DNA. Now what happens? For making things even more better, you can write infection by the virus to the macrophage. What do? Put number 1, put number 2 over here, put number 3 over here. So we know the steps entirely. Okay, now number 4 is what? Number 4, integration of viral DNA into host genome, host genetic material. That is what you mean. Now once you do that, after that you can mention over here with the help of integrase, okay. After that, what do you get? You get viral RNA. So fifth one is going to be viral RNA is going to be formed, and later on you can just mention progeny virus is formed. So viral RNA is being formed, and if you want, you can also show, okay, some proteins like this. Viral protein is being formed, or you can just mention viral RNA and viral protein is being formed. That will be more than enough, because these proteins you might not understand. Protein coating is what you think, so you can put it like that. So viral RNA and viral protein is being formed, and later they all come together to produce progeny viruses. They produce progeny viruses, and that's the end of it. So this is the fifth one. This is going to be the sixth one. Viral RNA, that is this, and viral protein. You just mention it separately, and viral protein is formed. Later this happens. That's all. Simple diagram. Okay, you have to mention the key thing: infection, introduction of viral RNA, then reverse transcription, then you got viral DNA, then you have to introduce it inside the host genome, then they produce viral RNA as well as the viral protein, and that comes together to form the progeny viruses. Finally, the progeny viruses which are there, viruses move to infect other cells. Okay, what is this? This is going to be a macrophage, which is an HIV factory. Will that work? Okay, just make it and it's done. Cool. I hope that works, gives you 5 marks. Cool. Now, over here, I have what is the effect of HIV? What is the effect of HIV? Effects on the body. Does it have good effect? Obviously no. Decreasing T helper cells is equals to weakened immune system. We know that. Symptoms: fever, diarrhea, as well as weight loss. First of all, it takes huge lot of years to identify whether the person has the disease. So many years. You might live for 10 years without showing much drastic symptoms out there, because it takes time for the viruses to replicate, increase the number. If you want, it depends, okay? It's not like it's going to be the same for all the organisms out there, but yes. Okay? Yeah, works. So over here, what do we have? Effects on the body: decreasing T helper lymphocytes, weakened immune system. Symptoms: fever, diarrhea, and weight loss will be there. Opportunities: infection. You have bacteria that is going to infect you. What bacteria? Mycobacterium. Apart from it, you have viruses. Apart from it, you have fungi and the parasites such as toxoplasma. Toxoplasma attack the immune system, which makes it very, very weak. Okay, already your immune system is weak. Apart from it, all of these opportunistic infection, as in infections which are not normal, okay, they are opportunity driven. Depending on the situation, they are going to come and affect us. So first is a bacteria. As I said, it's going to be mycobacterium, which is going to show the effect. Okay, apart from it, there are viruses, other viruses. There can be fungi and other parasites such as toxoplasma that is attacking when your immunity is going to be actually very, very weak. So please do remember it. What bacteria? Mycobacterium. What bacteria? Mycobacterium. Apart from it, viruses, fungi, and apart from it, parasites such as toxoplasma can also attack, because your immunity is actually going to be super weak. Okay, works. Now, diagnosis and treatment. For diagnosis, what do you have? You have ELISA, enzyme linked immunosorbent assay. What do you have? You have ELISA, which is going to be what? Enzyme linked immunosorbent assay. Enzyme linked immunosorbent assay. This is the test, diagnostic tool for understanding if a person has the disease or not. That is HIV/AIDS or not. Treatment: antiretroviral drugs to prolong life but cannot cure AIDS. Please understand, AIDS is not a disease that can be cured. Okay, you will be having it, but to make sure that your life is prolonged, that you live for a very long time, you will be under what? Antiretroviral drugs. You will be under antiretroviral drugs. Please do remember that. Works? I hope that is clear. Yes. Now over here, because I know that it will be too much for you to remember, enzyme linked immunosorbent assay, what do you mean by that? How does it work? How does it help in identification of whether a person has the disease or not? To make things a little easier for you to remember it in the form of a story, let me tell you. So what exactly happens is that when HIV virus infects you, your body is going to produce antibody against it, right? Yes. So this is a general thing. The same type of antibodies are going to be produced throughout different people who have HIV, right? So what have we done is that we already know that these are the antibodies which are going to be produced, and we keep it ready. We keep it ready over here in this particular tool that we have, right? These are what? The antibodies, and we know that these antibodies are produced only in people who have HIV. Now, a person comes who has a doubt that whether they have HIV or not. Their blood sample is being taken, the antigens are being taken. Okay, in the blood sample, what do we have? We have the antigens. it is made over here to react with it. Suppose the antigen comes and binds over here. What do you mean by that? It means that these antigens are HIV viruses, then only they can come and bind, because these antibodies are specific against HIV only, right? So this person has a disease, but to confirm it, we allow second set of antibodies to come and attack. So basically over here we have one more type of antibodies present. We have one more type of antibodies present, and these antibodies, Baba, over here are going to be linked to enzymes. They are going to be linked to enzymes out there. So over here you have an antibody present already, and you have antigens being put down. This particular antibody which is coming is known as secondary antibody, and it's linked with an enzyme, because you cannot clearly see that all of this interaction has been taking place. So that is why I am putting an enzyme out there, and basically after that I am going to put a coloring substance. If this enzyme reacts with the coloring substance, what is going to happen? A color change is going to be observed. Which means that basically all these interactions have taken place line by line. If the color change is not happening, that means no, this particular interaction has not taken place at all. Okay, so enzyme linked immunosorbent assay, this is what you mean by that. Okay, this is one type of it. There are multiple different types of the same thing. Cool. So what do? You have the antibodies. You know that these antibodies are HIV specific. You take the sample from the organism, from one person who feels that they have the HIV. Now they come over here, they give the sample. If the antigen comes and binds, I cannot see it, which is why I'm going to treat it with another secondary antibody which is linked with enzyme. Then I put coloring substance. If the change is there in the coloring substance because of these enzyme being working, then I will confirm that the person has the disease. So in your NCERT, I told you in the beginning of the chapter, while we spoke about typhoid disease. Typhoid is the only disease there, infectious, where we had Vidal test, and apart from that you just have one more disease which has a diagnostic tool, and that is HIV. We have ELISA over here. We have enzyme linked immunosorbent assay over here. Do remember that this is the second infectious disease that we have, for which we have a diagnostic tool. Apart from it, you have cancer, but cancer is not definitely infectious in nature. Okay, so what are the effects on the body? Your T helper cells gets lower down. You have symptoms such as fever, diarrhea, as well as weight loss, but it can be because of so many reasons. You do not expect it to be HIV, but then there are some opportunistic infections which are going to affect you. For example, bacteria, mycobacterium is going to affect you, viruses are going to affect you, fungi is going to affect you, some parasites such as toxoplasma is going to affect you, and this is going to weaken your immunity. Diagnosis and treatment. Diagnosis is ELISA, enzyme linked immunosorbent assay. The treatment that we have is basically antiretroviral drugs, which is going to prolong life, but it is not going to cure AIDS. It is definitely not going to cure AIDS. I hope that is clear. Yes, so antiretroviral drugs, please remember, antiretrovirus. This is a retrovirus, against it, antiretrovirus. Done? Okay, ELISA is a diagnostic test for AIDS, Vidal is for typhoid. Never swap these two. Okay, do not swap both of them out there. Now before I go ahead, there's a line in your NCERT which I really want. While we are covering this one shot, I have made a promise that we do not miss out on any important information which is there in your NCERT. So where is it? I closed it down. Where is it? Just give me a second. I actually searched with, yes, over here. Okay. Come on. Yes. Prevention of AIDS. You can see it. I hope you can. If not, I'll just zoom it a bit. As AIDS has no cure, prevention is better option, the best option out there. Moreover, HIV infection spreads due to conscious behavior patterns, and it's not something that happens inadvertently. Obviously, generally it is not like that. Yes, it can happen to people who are not very much aware of things. For example, I go to a barber shop, the barber uses the same shaving thing that is used for another person out there, they can easily get HIV, right? So that can happen. But mostly it is a conscious thing, because we are all as of now aware. A lot of people are not, because obviously education has not reached until them, and it's your job to make them aware. Okay, it's not like pneumonia or typhoid which you do not know and you're not aware and you get it. So anyways, of course, infection in blood transfusion patients, newborns from mother, etc. may take place due to poor monitoring. The only excuse may be ignorance, and it has been rightly said, don't die of ignorance. In our country, the National AIDS, this is important, the National AIDS Control Organization, what do you call this as? NACO. National AIDS Control Organization. National AIDS Control Organization as NACO, and other non-governmental organizations, that is NGOs, are doing a lot to educate people about AIDS. WHO, World Health Organization, has started a number of programs to prevent the spreading of HIV infection, making blood from blood banks safe from HIV. Okay, what are the steps that WHO has done? Basically, making sure that the blood from the blood banks are safe from HIV. Okay, ensuring the use of only disposable needles and syringes in private hospitals, private and public hospitals and clinics. Free distribution of condoms, because as I said, condom can prevent sexually transmitted form of HIVs out there. Controlling drug abuse, advocating safe sex, and promoting regular checkups for HIV in susceptible population are some such steps taken. So what are the steps taken? You should be knowing that use of disposable needles out there, making blood safe from the blood banks out there, what do you say, free distribution of condoms out there, controlling drug abuse, okay, advocating about the safe sex, and all of it comes under the programs that WHO as well as National AIDS Control Organization along with NGOs and all have tried to do. Infection with HIV, the infection may spread to many people. Okay, infection with HIV or having AIDS is something that should not be hidden. Because if you hide it, there are chances that more people can get it. They are not aware about anything, right? So since then, the infection may spread to many more people. HIV/AIDS infected people need help and sympathy instead of being shunned by the society. And that's because of us, that they do not speak out. Because we stigmatize them. Just imagine a situation, one day in your life, it changes everything. People are saying, not talking to you, they're moving away from you, they're scared of you. How will they feel? Will they open up? No. They will not. So it's our role, our duty to make sure that we do not stigmatize them. I know when I was in 12th grade, I used to go to do street plays for awareness about HIV. I have seen people who have HIV in my life, okay, and they're just normal human beings. It's just that they have disease, and rather of stigmatizing them, we should be making people aware that basically this is how it spreads. This is what you should do. This is what you should not. Okay, do not shun them in the society. That is not something we can do. So please remember NACO, it's very, very important. National AIDS Control Organization. Apart from it, you have NGOs working for it. Apart from it, you have World Health Organizations working for it. World Health Organization working for it. Done. That's all about it. That's all about HIV that you needed to know. Now right over here, I have a question, and this is a KCET PYQ of 2025. In which of the following HIV replicates and produces its progeny viruses? In which of the following HIV replicates and produces its progeny viruses? Helper T lymphocytes, memory T lymphocytes, killer T lymphocytes, or suppressor T lymphocytes? In which of the following HIV replicates and produces progeny viruses? If at all you had option macrophages, probably you would have got confused, but here there's just helper T lymphocytes. Please go with it. So you have to go with it. It's going to be helper T lymphocytes. Got it? Yes. Next question. During replication of retrovirus, what is going to happen? Viral protein is introduced into the host cell. During replication of retrovirus, what is happening? This is a PYQ 2018 question. Viral protein is introduced in the host cell. Viral RNA is introduced into the host cell. Viral DNA is introduced into the host cell. Transcriptase enzyme is introduced in the host cell. So during replication, what is going to happen? During replication of retrovirus, viral protein is introduced. Viral protein does not get introduced. Viral RNA is the only thing that gets inside. Okay, viral protein stays outside only. Viral RNA is introduced. Yes, that could be correct. Viral RNA is introduced. Viral DNA is introduced. No, it's not introduced. It's converted. Viral RNA gets converted to, not converted, basically it gets reverse transcribed to the DNA out there. So this is also wrong. Transcriptase enzyme is introduced. No, it's reverse transcriptase enzyme that is being introduced. So over here, the only answer that we have is going to be B. It's going to be B. Got it? Yes, ma'am. Now, PYQ 2019, again, identify the incorrect statement. HIV is transmitted by mosquito bite. You have to find the incorrect statement. HIV is transmitted by mosquito bite, is it? Pneumonia is a bacterial disease. Cancer is a non-infectious disease. Ringworm is a fungal disease. What do you think is the answer for this? Come on, think about it. Come on, think. Okay, what do you think is the answer for this? Pneumonia is a bacterial disease. Yes, Streptococcus pneumonia as well as Haemophilus influenza, if at all you remember. Cancer is a non-infectious disease. It's non-infectious. You do not get it if at all someone has it. Ringworm is a fungal disease. Yes, Microsporum trichophyton, epidermophyton, they cause it. What about this? HIV is transmitted by mosquito bite? No. HIV is not transmitted by mosquito bite. This is merely wrong. Yes, so if we know things, we know things. Okay, PYQ 2019, same here, one more question had come in KCET. Identify the enzyme that catalyzes the step labeled as, okay, in the given schematic representation of replication of retrovirus. Where is the picture? Picture is not there, huh? Okay, picture is not there. So probably they might have given this particular picture where you had your DNA, you had your RNA. Okay, where is it? You had your RNA and then now it was forming a DNA. So this is what they asked. What is this particular thing? So identify the enzyme that catalyzes the step labeled as this in the given schematic representation. Reverse transcriptase, RNA polymerase, recombinase, DNA ligase. What do you think? From RNA you're getting DNA. This is going to be reverse transcriptase. A is going to be the answer for this particular question. The picture got removed. So sorry. Okay. Now what do we have? This is a 5-marker question, as I told you. The schematic representation based question can come, or directly you will be asked to make it also. This was a based question that had come. This is a 5-marker question from your second PUC. Okay, the flow chart shows replication of retrovirus in the host. Answer the questions given below. Fill in the missing data in box 1 and 2. Fill in the missing data given in box 1 and 2. Let's check it. Retrovirus. Virus infects the normal cell, viral RNA is introduced in the host cell. Reverse transcription happens and after that what do you get? Viral DNA is being formed. Viral genetic material in the nucleus of the host cell. After viral DNA is being formed, basically it goes in the host cell. Viral DNA incorporates into the host genome. Viral DNA gets incorporated. After that what happens? Basically they are going to form viral protein as well as viral RNA. And finally the viruses come out, right? So what is going to be there over here? At the end of reverse transcription, viral DNA is going to be formed. At the end of viral DNA coming out of the genome, okay, viral DNA is going to be incorporated into the host genome. After that what happens? Viral RNA and viral protein is going to be formed. Later on the viruses come out. Right. So over here, fill in the missing data in the boxes 1 and 2. What will be box 1? Viral DNA is being formed after reverse transcription. Second, box 2, viral components such as protein and RNA are being synthesized. That's what I said. Yes, that's all. Give an example for a retrovirus. Retrovirus example, HIV, human immunodeficiency virus. Name the disease caused by this retrovirus. Acquired immunodeficiency syndrome. You just do not have to write AIDS. You have to mention it. Acquired immunodeficiency syndrome. Name the diagnostic test for the disease. ELISA. Enzyme-linked immunosorbent assay. Enzyme-linked immunosorbent assay. So HIV, human immunodeficiency virus, AIDS, acquired immunodeficiency syndrome, ELISA, enzyme-linked immunosorbent assay. I hope that's done. That's all. Right? So here is a drill that I have. You have to tell me, is it a myth or a fact? This is the fun thing that is going to be done. And post that, we are going to go ahead with cancer. Okay. HIV can spread through a mosquito bite. Myth or a fact? Mosquito bite, myth. A retrovirus carries an RNA genome. A retrovirus carries an RNA genome. It can carry an RNA genome. It's a fact. Okay, it can carry an RNA, as in basically RNA is the genetic material out there. Correct. Antiretroviral drugs can cure AIDS completely. Antiretroviral drugs. Can it cure AIDS completely? No, Baba. It can just prolong life. So this is going to be a myth. This is going to be a myth. HIV first enters the macrophages, which act as virus factories. Does it? Does it enter macrophages first and do they act like factories? Yes, this is going to be a fact. AIDS is a congenital disease present from birth. AIDS is a congenital disease? Is it a congenital genetic disorder that you get from birth? This is going to be a myth. It's not a genetic disorder. You acquire it. ELISA is, listen, if you're saying that a baby gets it, it's because of infection. It's not genetic disorder. It's an infection that happens during blood. Okay, if at all the blood is being missed during delivery. So obviously it cannot be congenital. Now, ELISA is a diagnostic test for AIDS. It is going to be a fact. Every myth here has appeared as a wrong option in real KCET papers. So please know that. Okay, so we have perfect idea about it. Everything is written over here. So I think that could be helping you. So my dear children, I really hope, you know what, I am having fun, what do you say, teaching this particular chapter. Also because, as I said, this is one of my favorite chapters out there in this particular NCERT. I hope you are also loving it, and I'm reminding you once more, if you are loving it, make sure you share it with your friends, join the WhatsApp channel for getting the PDF of this particular class. And apart from it, there is one more thing that I want to tell you. So we have done one thing for you guys, and that is basically we have come up with a all-in-one page. Okay, all in one page. So for that, I might have to go to YouTube, and in YouTube I have to go to Diksha Karnataka. Do I have it? So let's go ahead. Okay, so let's go ahead and check it out. Just a second. Over here I have Diksha Karnataka, and then I click on this. After I click on this, I have some playlist over here. Just give me a second. Yeah. Suppose this is the playlist that I have for all my one-shot videos. In this particular thing, if at all you check, there is join the free ACE KCET 2027 course. This is a free thing. You do not have to do anything. You do not have to buy and all. Okay, you just go click on buy now. It leads you to this particular thing. It's for 0 rupees, available for you, where everything important is given. You might have to fill in your number chapter wise. Okay, segregation has been done subject wise, bio, physics, chemistry, mathematics, chemistry not yet, but mathematics, everything will be there stacked up. Whatever is done in YouTube, it will be stacked up there. You will be getting your PDF up there also, but I'll still request you to join the WhatsApp channel for getting all the updates as well. Cool? Works? So make sure you do that. It will be there under this particular video also. Yes, that was just a reminder. Now going ahead with cancer. What is cancer? It's a non-infectious disease, definitely. There are a few things that you should know. The characteristics of the cancer cells. This is a very important KCET PYQ, and apart from that, it has been asked in the MCQ questions of your second PUC as well. What is the characteristic feature of cancer? Which one is not? So you should know it, which one is. First thing, if you have a normal cell over here, and cancerous cell over here, what is going to happen here? The normal cells, they are going to divide. They're going to divide and basically probably make 2 more cells out there. What about the cancerous cells? They divide. This is known as what? Uncontrolled cell growth. Usually we have a regulation that a cell can divide these many times only. Okay, when it follows all the thing, there is known as cell regulation that is happening up there, which is why it is going to divide only these many times. But in the case of cancer cells, what is going to happen? They are going to divide uncontrollably. They are going to divide uncontrollably over here. Okay. Next is contact inhibition lost. So listen to me. Apart from the regulation thing that, hey, you only have to divide these many times, that is the loss anyways in cancer cell. Apart from it, they also lose one very important thing that is known as contact inhibition. What do you mean by that? Suppose a normal cell is there. When it divides, when it forms 2 cells over here, it comes in contact with the other cell and says that, okay, there is no space, I should not be dividing further. This is known as contact inhibition. When you come in contact, you are being inhibited out there. In the case of cancer cells, they're going to divide. What? Contact inhibition. There is no contact inhibition. It keeps on dividing. It has lost the property of contact inhibition. It divides and like, you also divide. It goes on like that. So there is what? Loss of contact inhibition. This and this point are 2 separate points. Please remember it. Okay, sometimes people just mix it up. So uncontrolled cell growth is also because of loss of contact inhibition. But apart from that, there is loss of regulation in the cell also. That is why you have uncontrolled cell growth. Then contact inhibition loss. The next one is going to be metastasis. And this is most malignant feature. Okay, if you are asked what is the most dangerous feature of a cancerous cell, it is going to be what? Metastasis. It is going to be metastasis. What do you mean by metastasis? You might have heard that in cancer patient, now it has spread. It has spread to different places. What do you mean by that? This spreading which is there, it is known as metastasis. From one place, the cancer cells are going to go to different place or different body parts. Remember, that is what you call as metastasis. So cancer cells spread via via the blood to distant body parts, forming new tumors out there. And this is the most malignant, okay, most dangerous feature of a cancerous cell. Remember it. So we have 3 features to be specific. Usual question, again a 5-marker question. So whatever I am saying as a 5-marker could be coming as a 5-marker. So we studied about HIV/AIDS, we spoke about lymphoid organ. I showed you the example also. It's not like I'm making up the story. I showed you the example, the questions that have come. Similarly, in the case of cancer, the entire cancer thing can come as a 5-marker question. Okay, what is the characteristic, what are the things that causes cancer, and what is a diagnostic test? All of it can come as a 5-marker thing, which is why I'll request you to make sure you pay attention to what I'm saying right now. Okay, so we have uncontrolled cell growth, we have contact inhibition, loss of contact inhibition, they do not have it, okay, loss of contact inhibition, and metastasis, which is going to the most dangerous property. Now, before I go ahead with all of that, there are tumors. You know, tumor is there. Tumor is also basically a cell is there, a cell grows uncontrollably. But over here you have 2 types of tumors, benign and the malignant. Benign tumors, they are confined to one location only. They do not move around in your body. They do not show metastasis property. The cells do not show metastasis property. Malignant form of tumors are basically caused by the cancerous cells out there. They're going to rapidly divide and invade the tissues, and they're going to spread around. Okay, so there are 2 types of tumors, benign, which does not move around and all, malignant, which is basically made up of cancerous cells which can basically move around, shows a property of metastasis, which is why you call it as malignant tumor. Okay, metastasis is called the most feared property of the malignant tumor. Remember that exact phrase. Yes, remember that exact phrase. So these are the properties. Will you forget it? I hope you don't. So PYQ 2020, KCET PYQ 2020. Certain tumors are called malignant because of what? Okay, because of what? They are not neoplastic. What do you mean by neoplastic? Neoplasticity is something, neoplasticity means basically they are allowed to change. They are neoplastic means plastic things you have seen, they can easily be changed to different things. Okay, so cancer cells, they are neoplastic. They can change very soon. Here it is said that they are not neoplastic, so this is going to be wrong. Certain tumors are called malignant because they are not neoplastic, wrong. They are confined to specific locations, wrong. They invade and damage surrounding tissue, yes, that is why you call them as malignant, dangerous form. They show contact inhibition, they do not. Okay, they do not. So the answer for this question is going to be C. This is PYQ of 2020, KCET PYQ 2020. Got it? So right there I showed you a question. Similarly, which is the most feared property of malignant tumor? This is KCET 2021 question, the next year question. Neoplasty, metastasis, rapid invasive growth, loss of contact inhibition. Now we see that all of the properties are of cancer only, but the most feared property, as I told you, it is going to be metastasis. It is going to be metastasis. This is the answer for the question B. Cool? Yes. Now the next thing that we have over here is going to be types of carcinogens. Okay, not question, basically concept that we have is types of carcinogens. So how many different type of carcinogens we have? What do you mean by carcinogens? First of all, carcinogens means the things that causes cancer. The reasons or the causative agents of what? Cancer. That is what you mean by carcinogens. So you have 3 different types of carcinogens. One is physical, the other one is chemical, and the third one is going to be biological. In the physical one that we have radiations. You know, ionic radiations are there, non-ionized, and ionized radiations are there. So over here, the ionized one, basically what they do is that they break down the compound, and these things can go and react to other things out there, can cause a lot of trouble, which is why you say ionizing radiations are basically harmful. Non-ionizing radiations, they are not that harmful. They are also harmful, but not that. So under physical carcinogens comes these non-ionizing as well as ionizing radiation. Your X-rays, your gamma rays, your UV rays, all of them, they can cause DNA damage, as in they can cause mutations in your DNA, changes in your DNA, and these changes can lead to what? Cancer. these changes can lead to cancer. So physical carcinogens, as in you're talking about all the different type of radiations that you have. As I said, both ionizing and non-ionizing. Ionizing ones are more dangerous. Okay, X-ray and all is ionizing radiation. Anyways, so X-ray, gamma rays, everything causes DNA damage, which is why they come under physical carcinogen. Now, chemical carcinogens. Chemical as in some chemicals are being, suppose we inhale some chemicals, or probably we are in our bodies, there is some chemical being put, we eat it up, or there is something that is happening out there. These chemical carcinogens can again go react with our DNA and can cause issue. The most common chemical carcinogen that we have is tobacco smoke. You know, tobacco smoke that is there, it's a carcinogen. It can lead to lung cancer. It can lead to what? Lung cancer. So tobacco smoke which is there, the chemical carcinogen is linked to what? The lung cancer. Okay, it's a chemical, and that chemical when we inhale, basically it can lead to cancer. Not just of lungs, I'm telling you, my brother, okay, my brother-in-law actually, he is a doctor. Okay, he is an oncologist. He treats cancer. So over here, he has shown me several pictures of people who have got throat cancer, okay, tongue cancer and things like that. They have to literally remove their tongue. I know it sounds gross, but this happens because of chewing tobacco, because of smoking. Okay, a lot of issues are being caused. Please be very, very cautious. I know out of curiosity, a lot might be trying up this thing, but it happens. It happens, and it could happen. It could be you. So do not let that happen to you. Okay, so that is one very important thing. Just give me a second. I'll just take the pen. Yes. So tobacco smoke is going to be acting like a carcinogen. It can affect the lungs out there. Yeah, that's all. Now, biological carcinogen over here is going to be the most important form of carcinogen, from where you get most of the question. Okay, under biological carcinogen, it means some organism that can cause cancer. Okay, some organisms which are somewhere involved in causing cancer, or probably our own cells which are involved in causing cancer. It's not physical thing, it's not a chemical thing altogether, it's biological. First one that we have is oncogenic viruses. So there are some viruses which have some genes which can cause cancer. What do you call these genes as? Oncogenes. You know, oncologists are doctors who treat cancer. So oncogenes are there. These genes are transferred into our body. When they are transferred, this DNA, when it's transferred to our body, DNA is what? So gene is what? Gene is a segment of your DNA. When this is being transferred in your body, you can have cancer. So there are some oncogenic viruses. They contain some viral oncogenes that can cause cancer if at all they are transferred to us. Okay, this is one case. Second thing, cellular oncogenes, or basically proto-oncogenes. What do you mean by that? So, you know, within our cell, there are certain genes which you call as proto-oncogenes, as in they are there in our body doing a normal function. They are there in our body doing a normal, very, very normal function out there. But suppose there is some mutation in them. Suppose there is some mutation in them, they become an oncogene. They are going to become an oncogene, and they are going to cause what? Cancer. Now these genes are there with you, me, everyone. We all have the proto-oncogenes. If at all there is a slight mutation happening because of so reason out there, what is going to happen? We can get cancer. Okay, you call them as cellular oncogenes because they are inside the cell. You also call them as proto-oncogenes. They are normal genes that can trigger cancer under specific conditions. Under specific condition. Proto-oncogenes are already there inside normal cells. They are not an outsider agent. Please do remember that. Okay, so I'm just going to revise it because I know we need it. So we have carcinogens. What are carcinogens? Carcinogens are agents that can cause cancer. We have three broad categories: physical, chemical, biological. Under physical, we have radiations. It can be ionizing, it can be non-ionizing. Basically, examples are X-rays, gamma rays, UV rays. All of it can cause DNA damage, which is why we say that we should be applying sunscreen and all before going under sunlight. Why? Because it can have harmful radiations on our skin. We can have problems out there. Okay, it can lead to skin cancer also. So it is, you know, in outside America and all, people did not have pigments to protect their skin out there, which is why they have are a lot more prone to skin cancer. So anyways, so that is probably your research sector. Go research about it. So that is something. Physical carcinogens are there. Second thing that we have is chemical carcinogens. For example, tobacco smoke is the most important one that we have. Asbestos, you might have heard about in construction and all, people use asbestos. Inhaling that in too much amount can also cause cancer. So there are chemicals out there. Okay, then we have finally the biological carcinogens. They are the most important ones. It can be oncogenic viruses, as in viruses that contains the oncogenes. If that oncogene is transferred in our body, we will have cancer. Okay, so oncogenic viruses are there. Apart from it, we have cellular oncogenes. Inside our body, inside our cell, we have some cellular oncogenes. You call them as proto-oncogenes as well. They are very, very important. Okay, they are going to be very, very important. What are they going to do? Under specific condition, they usually do normal work, but under specific condition, they're going to be mutated and they're going to show a different thing altogether that can be problematic for us. So do know about them also. Proto-oncogenes, please remember, very, very important. Okay, so we studied about the features of cancer cell under uncontrolled cell growth, loss of contact inhibition, metastasis. Okay, we studied about types of carcinogens out there. Now we are going to go ahead with the cancer detection techniques. Okay, diagnostic methods. So early detection is very, very crucial, and for successful treatment, if at all you detect it early, probably you can prevent the process of metastasis to happen. Okay, or basically worsening of this to happen. So over here, what do we have as the first thing? The first thing that we have is biopsy and histopathology. You might have heard about biopsy. What is biopsy? Biopsy means, suppose there is a group of cells over here which you feel that it's cancerous. Okay, there's a lump being formed and you feel that this particular lump is a group of cells that is basically cancerous cells. What do? You take a part of it, a little bit of it, a tissue. Tissue is basically a group of cells, right? You take the tissue, this is known as biopsy. Later on, you work around this, you look it under the microscope, you check around how it's working and things like that. That comes under what? Histopathology. Okay, so first of all, a tissue sample is stained and examined under a microscope. First of all, the tissue is being taken, that is known as biopsy. It is being sent for biopsy, we say. Actually, it's a method of taking up the tissue. Then further, when you test it and things like that, we say that is a part of histopathology. So we have biopsy and histopathology, which we sometimes use interchangeably. Just understand, the part of the tissue which you feel could be actually a cancerous sample, we are going to check it under the microscope, and it has its own techniques. We do that under the lab condition, that is coming under biopsy and histopathology. Okay, next thing is blood and bone marrow test. Blood and bone marrow test. So over here, suppose our blood count, our cell count should be this much, but when we do the tests, the blood count test and things like that, we find that the number is elevated. When does that happen? In cancer case, it can happen because of so many other reasons, but in cancer also it can happen. The cells keep on dividing, uncontrolled cell growth, right? Remember? So there can be a direct increased cell counts. For example, in leukemia and all, a type of cancer, you can easily find it. Okay, so we have biopsy and histopathology. Apart from that, we have what? Blood and bone marrow test being done, where we see uncontrolled cell growth. That can be an indicative factor of cancer. Next thing, this is the most important thing under detection, and that is going to be imaging techniques. Okay, so the first one that we have over here is going to be radiography. It's going to be what? Radiography. Okay, over here we have X-rays. What does the X-ray do? X-ray help in finding the internal cancers. Okay, what do we have? We have internal cancers to be found with the help of X-rays. This is very, very important. Okay, please remember, internal cancers is something different, and with X-rays you have a harm also, and the harm is that you are going to use ionizing radiation. Okay, you are using X-ray. X-ray is what? Ionizing radiation that can cause harm to your body also. Okay, yes. Next thing, CT scan. CT scan again. Over here, it also uses X-ray, but this is for 3D imaging of internal organs. So this is why I specified internal organs. So you might be thinking, ma'am, if not internal organs, what will I see with the help of X-ray? So yeah, I know it is internal organs with X-rays, but I wanted you guys to understand a slight difference out there. With CT scan, again, you are using X-ray only, which is ionizing radiation. But with this, we get a three-dimensional imaging of the internal organs. We get a three-dimensional imaging of the internal organs. and that makes things even more better. Okay, so when a normal thing is there, initially we are asked to do x-rays, then we will say that you have to go ahead and do CT also. Okay, why? Because you are not very sure about it, you want to examine once more. Then we have one more very important thing, that is MRI. And MRI is considered to be the safest among three of them. Normal radiography, okay, or CT scan, okay, that is MRI is going to be even better than both of them. The reason being that over here you are not using ionizing radiation. First of all, you are not using ionizing radiation, rather you are going to use non-ionizing radiation, and you are going to use magnetic field. You are going to use magnetic field and also non-ionizing radiation. Okay, that is why it is considered to be safe, and basically it helps in finding physiological changes even in living tissue. Even in living tissue, small changes which are happening that can be easily found out with the help of what? MRI. So they can ask you directly what are the different imaging techniques which is used for finding problems within the internal organs and things like that. Just understand all three of them are there. Okay, radiography will be there, the first one, where you have plain x-rays. It helps in finding problems within the internal organs, the cancer in internal organs. CT scan is there, which helps in which again uses x-rays, but it gives 3D images of the internal organs. Next one is MRI, which is considered to be the safest. Over here, what are we doing? There's a slight change. We use non-ionizing radiation, and we use magnetic fields. Okay, magnetic resonance imaging is what you call it. Magnetic resonance imaging is what you call as MRI. So you are going to use magnetic fields or non-ionizing radiation for that. It is used to find any pathological or physiological changes in the living tissue. In the living tissue, this is the most important part of it. So until now, we know biopsy and histopathology, then blood and bone marrow test is there, then we have imaging techniques, and now we are going to go ahead with cancer-specific antibody test. As I told you, our body is going to react by producing antibodies against certain things. If we know that these type of antibodies are produced against cancer, and if we find the same type of antibodies in someone else's body also, so we basically can say that they might be having cancer, right? So cancer specific antibody test identify the specific cancer markers out there in the body, and that can help. Now molecular biology techniques. Okay, molecular biology techniques are still working on. So they help in detecting inherited cancer genes. With the help of that, we can find if a person can have a probability of having cancer. Do they have this particular gene? You know, sometimes we see breast cancer. This is genetic also. Okay, not all cancer is going to be genetic, but some of them shows genetic features as well. Breast cancer is one among them. A female has it. A lot of, if the family is big, you might see a lot of people have it. Okay, so in my in-laws family, my mother-in-law had cancer. Okay, by God's grace she survived, and she is healthy and fit and fine. But similarly, her sisters also have also been diagnosed, they've also been treated. But what I'm telling you is that there are some forms of cancer which is there as genetic part of it. Okay, so with the help of molecular biology techniques, we can detect inherited cancer genes and help in prevention by advising high-risk individuals to avoid carcinogens, avoiding tobacco to prevent lung cancer and all of it. So if we know that, okay, this is the case, you might get it, probably we can just tell them that, hey, you have to be careful about a lot of things out there. Okay, so that is the second thing. That's the last thing that comes under. These are the few things that are there. For internal organs, the trio is radiography, CT and MRI. Please, Vidal test is never used for cancer. This is why it has been put like that, is because lots of KCET questions have asked that. So yes, cool. So if at all we want to revise, can I just... Okay, so what do we have? Biopsy, histopathology, where your tissue sample is being taken from the cancerous cell and they are being tested under the laboratory condition. Okay, they are being examined under the laboratory condition. Then you have bone marrow as well as blood test being done. Increased cell growth, if at all it has been found, we can just understand that that person can have the disease. Okay, the next one that we have is basically this one. What do you call this as? Imaging techniques. We have x-rays, that you call as radiography. Basically it helps in finding internal organs cancer. CT, which helps in 3D imaging of internal organs, and the last one is going to be MRI, magnetic resonance imaging, where we use non-ionizing radiation and magnetic fields to identify any issues, pathological or pathological means anything that has that might seem like disease causing symptoms and things like that. Pathological or basically physiological changes in the living tissue can be identified with the help of that. Finally, we have cancer specific antibody test, and apart from that we have molecular biology techniques. Cool. Cool. Now over here, there are few questions that is going to be there in KCET PYQs form. Identify the techniques useful in detecting the cancer of internal organs. CT, MRI, radiography, all of the above. What do you think? Ma'am, internal organs, no, radiography only or CT only, and what about MRI? MRI is for living tissue. Living tissue is not internal. It's internal only, right? So basically it is going to be all of them. In that particular case, Baba, it is going to be what? All of the above. Identify the techniques useful in detecting the cancer of internal organs. The answer is going to be all of the above. Done and dusted. Easy question. Now you know that it's easy. Why? Because we have solved it. Which of the following are the techniques? PYQ 2025 in KCET. Which of the following are the techniques for detection of cancer of internal organs? A radiography, MRI, B MRI, computer tomography, and basically C Vidal test and radiography, and D MRI and Vidal test. What is it? Options A and B, options A and C, option B and C, option B and D. So probably you can just look out from here. I think that will be easy for you. Options A and B. What is A and B? What is this thing? Techniques for detection of cancer. Radiography and MRI. Yes, this is. Okay, rest definitely this is. Apart from that, MRI and computer tomography, CT, that is also something that is there. Okay, A and B, both of them are correct. What about C? Vidal test is there. Vidal test is not there. Here also Vidal test is there, so I'll just put it wrong. So the only answer could be A and B. The only answer over here could be A and B. A and B, this one. This is going to be the answer. I do not know why it is being put. Okay. So which of the following are the techniques for detection of cancer of internal organs? You have been given options here, and basically you have to choose. Since Vidal test is there in both this C and D, I'm going to cut it off. Okay. And CT stands for computer tomography for people who didn't know about that. Cool. All of a sudden rain started coming, that's why I stopped. Sorry. Okay. Anyways. Now, the last thing that we have in cancer is basically treatment. What do we have as a treatment? So first thing that you might have seen is that people remove the parts which are being affected with cancer. Why? To prevent metastasis. To prevent metastasis from happening. So for that, what do? You do surgery. Okay, you do surgery. Remove the tumor mass out there. You can remove the tumor mass, and when you do that, little part of the tissues will also be going from your body. Cool. That is the first method. Second method is radiation therapy. Lethal radiations are being put on the tumor cells out there while protecting the normal tissues. Okay, these are going to be affecting the, okay, so they usually, when I say radiation therapy or chemotherapy and things like that, they affect the fast growing cells. The fast growing cells. So the cancer cells, you know, they are going to be fast growing cells, which is why they are going to be affected. Does that mean, man, that the normal cells are not being affected? It is. Which is why you might have seen that right now there are so many ways where it can be prevented, but you will see that cancer patients usually lose their hair. Why? Because your hair follicles and things like that are something that can divide very, very fast. Which is why they are also being targeted, and that is exactly why they lose their hair. Because the high growing cells are the ones which are being targeted over here. You get it? Similarly, cancer patients might be anemic. Why? Because your blood cells are also something that divides very, very fast. So that also is being targeted, which is why you will have that loss of immunity and stuff like that. So first is radiation therapy, where what do? Lethal irradiation of the tumor cells is being done while protecting what? The normal tissues are there. Then you have chemotherapy, where you're going to use some drugs, where we are going to have some medicine, some drugs, which is going to kill the cancer specific cell. Side effects includes hair loss and also anemia. As I said, is going to be targeting the fast growing cells. That's why. Next thing is a combination therapy. So when I say surgery has been done, then radiation has been done, then chemo has been done, sometimes it does not work. So which is why we have to do combo of it. Okay, that is surgery. We have to do all of it together. Surgery we have to do, radiation have to do. So what I meant is, some people just need surgery. You do not need radiation as well as chemotherapy. With surgery only, things could be fine. That's the case that is usually happening. But some people, for them, they might need all of it. They might need surgery. Apart from that, they also might need doing the other things also. For example, radiation therapy and chemotherapy as well. This is very, very important. Do not forget it. Okay. Now what do we have? We have immunotherapy. We have what? Immunotherapy. Tumor cells evade the immune system. Okay, tumor cells evade the immune system. We know that. What is immunotherapy for? Immunotherapy is not basically, I'm not curing the disease with the help of this. I'm basically helping the cancer patients. Okay, because their immune system is very, very weak right now. The tumor cells have evaded the immune system as well, which is why what we can do is that we are going to give some biological response modifiers. Very, very important. Biological response modifiers, as in there are certain things. Okay, we say cytokine, remember, cell releases certain things to make sure that the other cells are being protected. Interferons, if you have studied about it before, remember in innate immunity the cytokine barriers were there, interferons we studied. So they are basically biological response modifiers. They are going to modify, they are going to help in increasing the response in a better manner. Alpha interferon boosts the immunity so that the body can destroy the tumor. So what do we give to cancer patient? We give alpha interferons. These alpha interferons which are there, they are going to boost the immunity such that the body can directly affect the tumor cells. They can kill the tumor cells very, very easily. It is boosting up our immunity. That's why we call it as biological response modifiers. Remember, plain interferons, that is for target, that is for telling that I am virus infected, please other cells be protected. Here I am talking about alpha interferons. There's a slight difference. These alpha interferons over here are biological response modifiers which boost up our immunity such that basically our body can fight against things. Okay, alpha interferons is a biological response modifier, a treatment, not a cause. Okay, do not file it with the carcinogens. They are not carcinogens. Obviously this is coming under treatments. Okay, so what do we have? Common treatment. Listen, diagnostic tool is different, treatment is different. In treatment you have surgery, you have radiation therapy, you have chemotherapy, or a combination of all of it. In immunotherapy, what do? You give biological response modifiers, that is alpha interferons, and they are there for boosting up your immunity and things like that. Okay, done. That's all. Now we're gonna go ahead and talk about certain questions. A PYQ of 2018. Identify the odd one from the following. You have alpha interferon, oncogenic virus, proto-oncogenes, and UV rays. Which one is going to be an odd one out? This is 2018 question. So if you see, we have solved 2019, 20 and every question from cancer base. So cancer question is something that usually comes up. We cannot miss it. Okay, alpha interferon, oncogenic virus, proto-oncogenes, UV rays. Which one is going to be the odd one out? It is going to be the alpha interferon. Why? Because this is something that is used for treatment. All of them, all the others are carcinogens. They cause cancer, and this is the one that is used for treatment. So A is the odd one out. A is the odd one out. Okay, 3-marker question that has come from this particular portion, that is cancer. Answer the following about cancer. Name the group of genes identified in normal cells that could lead to cancer. What are those genes which are there in normal cells but can lead to cancer? What are those genes? What do you call them? Cellular oncogenes, or basically I call them proto-oncogenes. They are normally there in our body, but they can turn cancerous if at all they are undergoing some modifications out there. Now, which techniques are useful in detecting cancers of internal organs? Which techniques are useful in detecting cancers of internal organs? Any idea? So we know it's going to be CT, computer tomography, it's going to be MRI, magnetic resonance imaging, and also radiography. These are there for internal organs. 3-marker question. Actually, it's a 5-marker. In total, it's a 5-marker question. Okay, 3-marker is this, 1-marker is this, and finally, why are cancer patients often give an alpha interferon as a part of treatment? Why are they given alpha interferons? Because alpha interferons are biological response. Okay, biological response is there, but they want to modify it. So they are going to be biological response modifiers. That is why you have this being given. So this is a 5-marker question that had come. That's why I was thinking, cancer, usually 5-marker. No, yes. So the gene group, proto-oncogenes, normal cellular genes that can trigger cancer under specific conditions. Over here, techniques for internal cancers, biopsy and histopathology. Then is CT scan. Then you have MRI. Why alpha interferon? Alpha interferons are biological response modifiers. They activate the immune system and boost the body's ability to destroy cancer cells. They enhance the immune response against any form of tumor out there. Done. Cool? Works? Works. Now over here, Cause or cure? That's a drill that we have for cancer. Let's check it out. Cause or cure? UV rays, alpha interferon, proto-oncogenes, chemotherapy, oncogenic virus, biopsy, and tobacco smoke. UV rays, is it a cause or a cure? Cause. UV rays is a physical carcinogen. Alpha interferons is going to be a cure, biological response modifier. Proto-oncogenes, they are going to be biological carcinogens out there, so it is going to be a cause. Okay, chemotherapy, it is going to be a cure where you're giving chemicals, drugs to kill the cancer cells. Oncogenic viruses pass their genes out there, oncogenes out there, it's a cause. Okay, biopsy, it's going to be a cure. You take a sample of it and basically test it for treatment and all. Tobacco smoke, it's going to be tobacco smoke which is there, it's going to be a cause. What cause? It is going to be a chemical cause. Okay, chemical carcinogen out there. I'm so sorry if at all the rain's voice is coming a lot, but yes. So careful, one item on this list is a detection method, not a cause, not a cure. Yeah, biopsy is actually not a cause, not a cure, it's actually a detection method. So I can just mention that. Okay, I thought I was not supposed to do that. Anyways, so that is it. So that is about it, and I hope you like the drill also. So, yes. Now, we are going to go ahead with the final part of this chapter, and that is going to be drugs and their sources. Very, very, very important thing, and we cannot definitely miss it out. So, listen to me very, very carefully. It's a fun part, and after I teach you this, I promise you will never forget things. Okay, that's my promise. So ready for this? Let's go. So the first set of drugs that we have are known as opioids. Similarly, we have three types, okay? Coca alkaloids, okay, cannabinoids, and opioids. So these are three people that we should know. Opioids, cannabinoids, and coca alkaloids. There are three different family who are neighbors who are staying together. Like, I don't like you, I don't like you. That is how it goes, okay? In this house, in the house of opioids, you have two drugs. Okay, morphine and heroin. Morphine and heroin. Listen to me. Okay, so this is how the plant looks. You call this as Papaver somniferum. What do you call this plant? Papaver somniferum. Ma'am, do we have to remember it? Obviously, yes. You also call this as opium poppy. You also call this as opium poppy, from where you get opioids. So it's easy. Opium poppy is easy, right? Yes. Or you call this as Papaver somniferum. Tupperware, you know, Tupperware bottles are there. With that you can remember. Papaver somniferum. Here, these things that you see are pots. Okay. And these pots are going to produce some latex, white color fluid out there. Do you have the picture? No. This white color fluid are something from where you can get morphine. From where you're going to get morphine. Okay, ma'am, but you said that there are two type of drugs that are being produced. Heroin also. What about that? So listen to me carefully. First you get morphine. Morphine is made to undergo some chemical change out there. It's a reaction that can be done. From how, that is how we get heroin. So heroin, it's not something that we can directly get. We actually get morphine, but morphine undergoes a chemical reaction which is known as acetylation. Okay, that is known as acetylation. So suppose over here we have morphine. This morphine makes heroin, but for that it needs to undergo acetylation. So we say heroin is also known as diacetyl morphine. You also call heroin as diacetyl morphine because it has underwent some changes out there. Where do you get morphine from? From the latex. From the latex of opium poppy. From the latex of opium poppy. Now, why they are known as drugs, ma'am? So each house they are fighting that I am the best drug, I am the best drug. So we are going one by one. Okay, morphine says I am the best. Why? Because doctors use me. Huh? Doctors use drug. Listen, not for them, but for the patients. Okay, but for the patients. So you know, some patients are there. They might have undergone some surgeries and all. It might be so painful for them to endure the pain, which is why, to make sure that they do not have to undergo that much pain, they're given morphine. It's a sedative. By sedative, I mean you feel sleepy. It's a painkiller. I'll say it's a painkiller and a sedative. That means tomorrow I have a headache, I'll take morphine from doctor. No. High doses of morphine can also lead to death. And it's only given when the pain is unbearable. Okay. So listen to me carefully. Morphine is from the latex of the poppy plant. What do you call this plant? Papaver somniferum. Papaver somniferum. Okay, I'm writing it. Oh my god, I would have fallen right now. Sorry. Papaver somniferum. Okay, ma'am. Action. A sedative and a painkiller. Very useful in patients who have undergone surgery. Yes, painkiller and sedative. Will you remember it? I'm a painkiller. I'm basically a sedative. What more do you want? Is what morphine is asking. Here, I'm going to say what is being affected and all things like that. Listen, if you want to feel sleepy and things like that, what do you think is to be affected? Your central nervous system, your brain and the spinal cord is a major part of a lot of things, your sleep cycle and everything. So when I talk about these drugs, opioids, they are going to affect what? Your central nervous system. These all things are very, very important. Central nervous system. And apart from it, it also affects your gastrointestinal tract. It has an effect on your gastrointestinal tract. It slows down things. It is going to slow down everything out there. Gastrointestinal as in this thing, your digestive whole thing. Okay, gastrointestinal tract is also being affected. Cool, cool. So now in the house of opioids, morphine is saying, I am the best drug out there. I am used by doctors to give the patients because I am a painkiller and also a sedative. I am from the latex of the opium poppy plant, that is Papaver somniferum. And I affect the central nervous system and also the gastrointestinal tract. Okay, heroin comes into picture. But when heroin comes into picture, morphine says, hey, you have been formed of me. You became because of me. Because I went acetylation. I underwent acetylation. You are diacetyl morphine. You have my name in your name. Okay, you are diacetyl morphine. So heroin smacks. Okay, heroin smacks morphine and says that, hey, I might have formed from you, but you need to understand that I work better than you. You are just a painkiller and a sedative. I am a depressant. Okay, that was just to make people sleep and calm down a bit. But this is going to be a depressant, even more bad. Depressant over here. So always remember, this particular drug which is there, that is heroin, it's going to be a depressant. It slows down the body. It slows down the body very, very much. Okay, and it is white in color, it is odorless, it is bitter crystalline compound. It is white in color, it is odorless as in does not have any smell, and basically it is crystalline compound. You might have seen in movies and all, they trick drug and all, this particular heroin and all could be even catched very easily. White powdery drug, crystalline actually, it is odorless. How do they take it? They take it by snorting, like this, or basically by injection. Snorting or injection. Snorting or injection, you will remember. Okay, like that you can remember. This is the thing that we have. And I told you that it smacks. Okay, it smacks the morphine. So remember, it's also known as smack. Okay, it is going to be known as smack. There is a reason I am talking about all of it. Each and everything that I have taught over here is a question. Is a question, can be an MCQ question, can be a theoretical question, can be a question. So please do remember everything that I have told over here. Now, one more thing. This picture can be given to you and asked, what is this? Identify what is this. So obviously, this is not an image of a person to be easily identified, but always remember, here it looks like, oh, so it has to be an opioid. It's actually morphine. It's actually morphine. You know, always the first kid is being preferred too much. First kid might have so many pictures. Second kid might not have too many pictures. First kid has a picture that is morphine. So opioid, in the opioid, the first picture that we have is for morphine. Will you remember it? Okay, so direction matters. Heroin is made by acetylation of morphine, never the other way around. So please remember it. Okay, so I'm going to revise one thing very, very clearly once more. Okay, we are talking about the opioid family. Opioid family, the first drug that we have is going to be morphine. Morphine says that I am a painkiller and basically I am a sedative used by doctors to give to patients who have underwent surgery. Basically, I am retrieved from the latex of the poppy plant, which is known as Papaver somniferum, and I affect the central nervous system and also the gastrointestinal tract. Okay, and my chota bhai, okay, my small brother, heroin, which is made by acetylation of morphine, is also going to affect the CNS, central nervous system, that is your brain and the spinal cord, and also the gastrointestinal tract. Okay, now the heroin comes into picture and says that, okay, my name is heroin, people call me smack also because I smack morphine, but my actual name is also there, which we hide usually, that is known as diacetyl morphine. Diacetyl morphine. Okay, it undergoes acetylation and that is why it is known as diacetyl morphine. Okay, fine. Now, this particular drug which is there, it is a depressant. It slows down the body, and which is why the other one wins the race. It is the one that slows down the body altogether. It's a depressant. How do you take it? By snorting injection. Snorting injection. Okay, okay. Done. There's two ways to take it. How does it look? White, crystalline compound, odorless. That is how it looks. Okay, that has also been done. What is left behind? Nothing is left behind. Okay, this is the only thing that you need to remember, and the picture is also given to you. Please remember that. I spoke about everything else. Cool. That is about opioids. Now, drugs and their use source. Morphine is obtained from inflorescence of cannabis, leaves or erythroxylum, latex of poppy plant, roots of atropa. So you do not know about any of the others, which is why you can go and type latex of the poppy plant. It's easy, right? It's easy. Now come over here. Let's talk about this particular question. Cannabinoids has still not been discussed, which is why I'll skip that question for right now. I'll go to cannabinoids first, then we'll come back to that question. Okay, so now we have come to the next home, neighboring home, cannabinoids. Now with cannabinoids, what happens is that there's one plant. Okay, there's one plant which says that I am the father of all the families which are there in this particular society, because each and every part of my plant body can be utilized. Leaves you want, you can make a drug out of it. Flowers you want, you can make a drug out of it. Root, you can make a drug out of it. I am the plant and my name is Cannabis sativa. I am a very popular plant and my name is what? Cannabis sativa. Over here I have a leaves picture, and this looks like a high five. It's just me giving a high five to you. Okay. The things, the drugs that you get from cannabis sativa, they are known as cannabinoids. And Baba, every drug which is quite famous that you might have heard about, charas, ganja, marijuana, hashish, all of it you get from this particular plant itself. They have been taken from different plant parts, but they are all coming in the same category. Now, what does it usually affect? Now, obviously, talking about all of them separately could be a big task for us. So, common thing, what does it commonly affect? It is not going to affect your central nervous system. Actually, it does, but not given in your NCERT. It is mentioned that this is a drug that is going to affect your cardiovascular system. It is going to affect your cardiovascular system, your heartbeat, everything. Your cardiovascular system is being affected with this, and this is the only drug that is going to affect it. There's one more thing that I'm going to talk about, nicotine in the tobacco, that is also going to affect your heart and all. But please remember, in these three families, okay, opioids, co-alkaloids, cannabinoids, this is the only one that affects your cardiovascular system. And under that comes, as I said, marijuana. Marijuana spelling is like this: hashish, charas, ganja, all of them. They are formed from flower tops, leaves, raisins, from each and every part. Okay, now how do people take it? People can either directly have it, bhang and all, bhang and all is being made by this only. Directly add and eat. Okay, so by direct ingestion, done, or probably by inhalation. People can inhale it also, or basically by ingestion. So I is something that is there. Cannabinoids also have an I. Cannabinoids, cannabis also has an I. You can remember like that. Either way, you have to remember ingestion and inhalation is something that is very common over here. What does it affect? Cardiovascular system is something that is going to affect it. Okay, and they actually interact with the cannabinoid receptors in the brain. There are receptors in our brain, cannabinoid receptors. They are going to affect them, and that is going to have an impact on your cardiovascular system. Okay, so over here again, let's read one by one. Definition: chemicals that interact with cannabinoid receptors in the brain. Okay, but it is going to affect what? Cardiovascular system. Extracted from the inflorescence of cannabis sativa. From each and every part of cannabis sativa, you take it. Marijuana, hashish, charas, ganja, all of them are made from this. Mode of intake: inhalation or basically ingestion. Affects the cardiovascular system, very important. Abuse: cannabinoids are abused by sports person. Very important point. There are so many drugs given in the NCERT, and they ask you a common question: which is that drug that is taken by sports person and they abuse it, as in basically they use it very much? It's cannabinoids. It's cannabinoids. Okay, that is the thing. That is why this particular guy was like, I am the one which is the winner of everything, because I am the one that affects the cardiovascular system. I am the only one. I am the one who's used by the sports people. I am the one which has every part being utilized for making drugs. I'll make marijuana, hashish, ganja, charas, everything. So please remember it like that. Just chumma I said. Cannabis sativa is the name of the plant. And over here, you can remember the diagram like this. People who have this now, they are not able to see the road. Okay, they feel that, okay, there might be no road in front, but they might see that there is a road and they might just keep walking. They might just keep walking. You can remember like that. So this particular line is for that. Okay, this is a cannabinoid molecules picture that is given over here. So cannabinoids, cardiovascular system, opioids, and okay, so I'll come with that. The next drug that we have over here, do I have a question? Yes, I have a question, but I'll not solve it right now. Okay, I can solve it, I think. Okay, from which of the given plants is a drug whose skeletal structure is given below extracted? So this particular picture is given. This was a PYQ of 2018, and you have been asked, from which particular plant do you take it? Papaver somniferum, Atropa belladonna, or Cannabis sativa, or Erythroxylum coca? What do you think is the answer for this? Atropa belladonna, Cannabis sativa, Erythroxylum coca, or Papaver somniferum? What do you think is the answer for this? It is going to be what? Cannabis sativa. From here, you get this particular plant. Easy. You study about it right now. Yes. Now we talk about the third group of family. We have entered the new home, coca alkaloids, and it says that, so you have met opioids and you have met cannabinoids, right? They are not the one that could do something that I could do. I can cause hallucination. I can cause hallucination. What do you mean by hallucination? You will start seeing things which is not even there. You'll start seeing things which is not even there. You're going to hallucinate. For example, I am going to see you flying, me flying. You can see me flying also. Okay, Jasmine Ma'am is flying in air. Okay, this is hallucination, something that is not actually happening. Now that's a severe case. Whenever you have too much amount of coca alkaloids, that's when you have hallucination. Apart from that, generally you have euphoria. What do you mean by euphoria? Sense of happiness. Okay, you have extreme sense of happiness, that is known as euphoria. Now everything like this is related to your mood and everything. So just understand, coca alkaloids which are there, they are going to again affect your CNS. You studied about CNS in opioids also. But here, the CNS has been affected, central nervous system has been affected, and the one that has been affected more over here is the dopamine receptors. What do you mean by dopamine? So when you scroll your phone, or when you do something that makes you happy, your body releases dopamine. And when you feel happy, you keep on going because your dopamine has been released. This particular drug is going to mess around your dopamine receptors, such that basically the receptors over here are blocked in a way that the transmission is ongoing, keep on going, such that you feel a sense of what? Euphoria. Example of the drug, one drug is enough in this particular category, only one, because it is doing all of the things. It's causing hallucination, it's causing euphoria and all. I'll call this drug as cocaine, and you might have heard about it. And cocaine is the bap of drugs, okay, it's the father of all the drugs we say. Right, cocaine, you also have different names for it. These names are asked in your examination. Cocaine is known as coke, or you also call this as crack. Okay, give me some coke. Coke is a short form of cocaine, or crack. Obviously hallucination, you're seeing me flying, what are you? Normal person? No, crack. Okay, so it will be crack. Coke or crack. Do not get confused with smack. Smack is heroin giving smack to morphine, right? So please remember like that. Okay. So what have we studied until now? We are in coca alkaloids. Example is cocaine. You also call this as coke or crack. Generally, it causes euphoria. Why? Because it affects your central nervous system and especially your dopamine transmission out there. That is why euphoria, sense of happiness. Extreme cases, you will see hallucination also. Okay, now which plant? From there you studied opioids, you get from Papaver somniferum. Okay, cannabinoids you get from cannabis sativa. This particular thing, where do you get it from? You get it from Erythroxylum coca. You get it from Erythroxylum coca, and my dear children, this plant is a native of South America, not North, South. Erythroxylum coca is from South. Okay, South, always, everyone, come on. Think of south. Think of south. Bangalore, Kerala, Tamil Nadu, everything. South, 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 south. Very important. They ask you whether North America or South America. So you should know south. That's why I'm telling you, remember south. South America, not India, South America. Okay, so Erythroxylum coca is a native of South America, from where you get this particular thing. Common name is coke or crack, and the mode of intake is snorting. You snort it up. Okay, affects the central nervous system. It interferes with the dopamine transport in the brain. Affects a stimulant, increases euphoria and energy. That means immense sense of happiness. In high doses, it can lead to what? Hallucination. In high doses, it can lead to hallucination. Now, we have reached until hallucination. And you know about all of it. By the way, I'll just revise it, then I'll talk about hallucination, more about hallucination. So what do we have? We have reached the coca alkaloids. Coca alkaloids example is cocaine. You call it as coke or crack. What do you have? In normal doses, you have a sense of euphoria, energy and all. But in high doses, it can lead to what? In high doses, it can lead to what? In high doses, it can lead to hallucination. Hallucination, right, okay. Fine. Where do you get it from? Erythroxylum coca. Where is it from? Native of South America. Okay, done. How do you take it? Snorting. General thing. These are the few things which are there. Right. Now listen. We spoke about hallucination. And what does it affect? Central nervous system, especially dopamine transport. Over here, the most important thing that I wanted to mention is basically, there are two more plans given in your NCERT, and both of these two plans are also involved in what? Hallucination. Okay, they are going to be involved in hallucination. So what are these particular plans that we have over here? Just a second. Okay, what are these particular plans that we have over here? This is going to be Atropa, belladonna and also datura. Atropa, belladonna and datura, they also come under this particular category. They also can lead to hallucination. Atropa, belladonna and datura. This particular picture that you see over here for the flowers, which looks like a funnel sort of thing, this is datura. This is datura. So please remember, other plants causing hallucination is Atropa, belladonna and also datura. Cocaine blocks dopamine transport, not serotonin, not GABA. So that is not something that is your concern. You can just remember dopamine. I think that will be fine. But please remember this thing. Hallucination. For hallucination, what all drugs do you have? For hallucination, you have cocaine, that you get from erythroxylum, that you get from, okay, just a second, erythroxylum coca. Then you have Atropa, belladonna, okay, and then you have datura. Datura is also there. Okay, datura is also there. Datura has a funnel shaped image of the flower. Please remember it. This picture can be given and can be asked, what is this particular plant? Cool. These are also hallucinogens. Okay, now I come back over here because I had a question. Where is the question? Where is that question? Which I stopped. Yeah, this one. Okay, read the following statement. Statement number 1. Morphine is obtained by acetylation of heroin. Is it? Morphine is obtained by acetylation of heroin? No, heroin is obtained by acetylation of morphine. So this is going to be wrong. Statement number 1 is wrong. Cannabinoids are known for their effect on cardiovascular system. Cannabinoids are the only one, the middle guy was the only one that affects your cardiovascular system. So this is correct. So statement 1 is correct. Statement 1 is wrong and statement 2 is correct. Statement 1 is wrong, incorrect, and statement 2 is correct. Your answer is going to be what, Baba? It is going to be C. This is the PYQ of 2024. PYQ of 2024. Very important. Will you remember it? Please, Macha, remember it. Okay? Okay, ma'am. Fine. Next thing. Over here, what do we have? This we have solved. Okay, next. The transport of which neurotransmitter is interfered by cocaine? Which neurotransmitter? Okay, anyways. Which is that particular neurotransmitter? Which is that chemical whose transmission has been affected by cocaine? Dopamine, acetylcholine, serotonin or GABA? The answer is going to be what? Dopamine. This is a PYQ of 2020. So you see, these topics are giving so many KCET questions. Dopamine is going to be the answer for this. Do remember it. Okay, ma'am, done. Dopamine is a neurotransmitter, by the way. It's released by the neurons and it goes and affects the other neurons. It signals the other neurons. That is why you call them neurotransmitters. Okay. Which among the following plant is a source of a drug which is native to America? America. Papaver somniferum, erythroxylum coca, cannabis sativa, Atropa belladonna. Which one is native to America, South America to be specific? It is going to be erythroxylum coca. It is native to South America. Erythroxylum coca, native to South America. Okay, ka is there, right? Okay. So which of the following plants does not, this is an MQP question of your second PUC, MCQ, which of the following plants does not possess hallucinogenic properties? Which does not possess hallucinogenic properties? Erythroxylum coca, Atropa belladonna, Datura, Papaver somniferum. This are hallucinogens. This one which is there is not the one. This is opioid. Papa guy gives opioid. So this is not going to be having, does not possess hallucinogenic properties. This is going to be the answer for that. Cool ma'am. Works ma'am. Okay. Now we are going to go ahead with the other drugs. These are the final drugs which are there, which is given in NCERT, which we have to cover, and then the drug part is officially over. We have almost officially completed our chapter also. Okay, let's go and talk about it. So over here, what do we have? The first one is nicotine. You know, when someone smokes, which is a drug that affects them? In the tobacco and all, basically, what do we have? We have nicotine. And what does a nicotine do? This is a very important question. What does a nicotine do? Nicotine is going to stimulate your adrenal gland. Okay, above your kidney, you have two glands out there, a pair of gland actually. You call this as adrenal gland. What does this adrenal gland do? They release adrenaline and noradrenaline. They release adrenaline and noradrenaline. Both of them are responsible for fight or flight response. Okay, for increasing your blood pressure. For example, I see a bear in front of me or tiger in front of me. What will I do? I will either get like this. What is happening over here? My blood pressure is increasing. Why is my blood pressure increasing? Such that basically my blood is getting transported everywhere. Oxygen is getting transported. I get energy. Oxygen is more. Respiration is more. If respiration is more, energy is more. I get to run. You get it? That's why we say fight or flight response. So your adrenaline and noradrenaline are being produced over here. And in this condition, definitely your heart rate is increasing. Now that's very normal to be having all this thing when a tiger is in front of you or when you're in a bad situation. But normally, just while smoking and all, if you're taking nicotine and your heart rate is keeping on increasing, it's not good for your heart. Always you're pressurizing your heart, right? So it leads to increased heart rate and blood pressure. This is the common question. Which is that drug that increases the BP? It is going to be what? Nicotine. So people generally think cannabinoids, which are responsible for cardiovascular functions. They are the one that is being responsible, but no, nicotine is the one responsible for increasing the BP. Why? Because it stimulates your adrenal glands. It increases adrenaline and noradrenaline. That leads to heart rate increase, and that leads to high amount of BP also. Blood pressure. Cool. By the way, which is a drug that has been abused by sport people? Cannabinoids. Okay, cannabinoids. Always remember. Okay. Tobacco chewing, increased risk of oral cavity cancer. So tobacco has nicotine and tobacco chewing separately can also lead to what? It can lead to cancer and stuff like that. I told you already, there's carcinogen. Now, health risks of smoking. Cancers, lung, throat, urinary bladder cancer can easily happen. You know, when you smoke, you have so many cilia in your tract. Okay, cilia are the ones that trap things out there. These cilia, one by one, they die. Now there is no one to trap. Everything come inside the body, have nice party. Okay, let's cause infection inside the body. That is a role that is going to happen. That is a thing that is going to happen. So which is why we should not be smoking. Okay. Similarly, you can get respiratory diseases such as bronchitis or emphysema. Emphysema, you're going to study about this particular disease later on also in a different chapter. So bronchitis as well as emphysema are respiratory diseases that can be happening. Heart diseases such as coronary heart disease, also gastric ulcers and things like that can happen because of smoking. I'm talking about all about smoking. Smoking causes cancer. We have heard about it before any movie starts, we see that, right? Because yes, it has nicotine and nicotine has all of these problems, and apart from it, they have cancer causing. Tobacco smoke itself can be cancerous, lung cancer, throat cancer, urinary bladder cancer, respiratory diseases, heart diseases. Okay, everything can be caused because of this. Just have a knowledge of it, just have an understanding. It has usually not come as a question, but yes, you never know. Now, when you do smoking, you know, in your body, a particular thing increases, that is known as carbon monoxide, not carbon dioxide, carbon monoxide. One oxygen is there. And this one which is there, it is the villain in the story, no? Komalika. What is going to happen? Usually our hemoglobin and oxygen, they are best friends. But when hemoglobin sees carbon monoxide, it says like, oxygen, I think I have to break up with you, go. It goes and pairs with carbon monoxide, and that is a problem for us. Why? Because our body needs oxygen for the process of respiration to happen. So that is a very big problem, very, very big problem. Okay, so smoking raises CO in the blood, and CO reduces HbO2 binding. Oxygen deficiency is being caused in the tissue. Oxygen deficiency is definitely going to be caused in the tissues. Cool, that is one very important thing that is there. Works. So CO reduces HbO2 binding, oxygen deficiency is caused in the tissue. Okay. Now, that is all. So people might be thinking that, ma'am, what is there in the slide to remember? Nicotine, remember, it causes high BP. Why? Because your adrenal glands has been raised up there. Okay, adrenal glands are being alerted up there. Apart from it, I told you tobacco smoking can cause cancer, respiratory diseases, heart disease and things like that. Carbon monoxide also increases because of smoking, that causes oxygen deficiency. Now, one very important thing, which is given as a small line in your this particular page. Barbiturates, amphetamines, benzodiazepines are used for depression and insomnia. What is this? Listen to me. Very, very, very important. So we have BAB. Okay, we have BAB. BAB is our friend. You know Bob. Similarly, we have BAB. BAB is the imaginary friend that we have. What is the name of BAB? B stands for barbiturates, A stands for amphetamines, and last B stands for what? Benzodiazepines. Benzodiazepines. What is BAB doing? BAB is the one that is going to help us during sleepless nights. When you're not able to sleep, what do you call this? Insomnia. Or basically if you're in depression. Not you, but doctors can give you a combination of these drugs or these drugs alone. This is used to treat depression as well as insomnia. This is, I'll say, a good sort of drug that we have. Morphine is also a painkiller sedative. It's also good in nature, but people abuse it. You have barbiturates, amphetamines and benzodiazepines also. They are also good. Okay, they are also good in nature if at all used properly. I'm writing it barbiturates. Okay, barbiturates, amphetamines. Okay, amphitheater is mine. Barbiturates, barbiturates, okay, amphetamines, and then we have benzodiazepines. BAB. They are there to treat insomnia. Some people write euphoria. Euphoria, sense of happiness that we do not have to treat. That's good, no? That is caused because of cocaine. Insomnia is basically we're not able to sleep. That. Okay? Insomnia, and apart from that, it is also there for treating depression. Will you remember BAB? Will you try to remember BAB? It's a very important thing. Don't forget it, macha. Okay? If you remember that, it will be good. Anyway, we are remembering a lot of things from the chapter. The chapter is interesting. So why not this also? So let's go. Over here, you and me are going to be doctors. This is actually a 5-marker question that came way before in your second PUC, and over here it goes like this. Some drug bottles had their name labels missing in a drugstore of a hospital. The staff needs to identify the drug with their actions still written on them. So what is there? The bottle is given, the drug name is missing, but the action is given. What do they do? That is mentioned. So you have to find which is what. So doctors, are we ready? So let's go ahead and find it out. Used by doctors as sedative and a painkiller. 1, 2. Painkiller and a sedative. What is going to be? It's going to be morphine. It's going to be morphine. That is what you use as painkiller and sedative. What is it? It comes under opioids. They come under opioids. Okay, next thing. Help patients cope with insomnia and depression. BAB, our friend. Okay, barbiturates. Barbiturates, should I write it again? No, right? Barbiturates, amphetamines and benzodiazepines. They are the ones. Increase blood pressure and heart rate of the consumer. Ma'am, you increase my heart rate, you teach a lot, my tension, this big long one shot, who will watch it? You will watch it. You are going to watch it because I am pretty sure that this is definitely going to help you. Anyway, so increase blood pressure and blood rate, or say heart rate of the consumer, it is going to be what? Nicotine. Nicotine. Okay. Acts as a depressant and slows down your body function. Acts as a depressant, slows down your body function. Heroin. Heroin. From the first family, we have heroin. Affects the cardiovascular system of the body. Only one is there, and that is going to be cannabinoids. cannabinoids. They are the one that affects the cardiovascular system of the body. They are abused by the sport people also. Remember? Done. Okay. Exactly, the answers are written over here so that you can probably go through it. Now this is the last drill that we have, okay, and then probably we're going to end up soon. For each plant, name the drug it yields and the system it affects. Papaver somniferum. Drug, what do you get? Morphine and opium. And what does it affect? CNS as well as your gastrointestinal tract. Cannabis sativa. What do you get? Hashish, ganja, charas, marijuana, all of it. What does it affect? Cardiovascular system. Erythrozyllum coca. Okay, what drug? Cocaine. And what does it affect? Basically CNS, dopamine transport. Atropa belladonna, hallucination. Nicotinia, tobacco, nicotine, BP, blood pressure. Okay, it is going to affect your adrenal glands. That is going to be there. So this is very, very important. All the things that I mentioned over here, the drill is given to you so that you know all this thing. Now last is drug and alcohol abuse. Drug on alcohol abuse. So listen to me very carefully. This particular portion is going to be the most important one. Okay? We usually ignore this part, but we should know. General effects of drug and alcohol abuse. Alcohol in adolescence can lead to what? Heavy drinking in adulthood. We know that can happen. Chronic drug and alcohol use damages the nervous system and also the liver. You might have seen people, they get withdrawal symptoms. You know withdrawal symptoms, what is that? So suppose you are someone who is addicted to something. You stop it. Your body wants it. Your body wants it, which is why it shows withdrawal symptom. And my dear children, I'm telling you, people die because of it, because of the withdrawal symptom. It's so dangerous. Your body becomes so addicted to it. And it's killing your body also. You get it? So chronic drug and alcohol use can lead to damage in your nervous system and liver and can also have a very bad effect when you live it. It leads to withdrawal symptoms. During pregnancy, it can harm the fetus if at all you are drinking or smoking and things like that. Misuse in sports in narcotic analgesics and narcotic analgesics. Analgesics means painkillers. Narcotic analgesics in drugs, they are not good actually. They are being abused. Anabolic steroids, diuretics and hormones are something that are used to enhance the performance in the sports people, and I'm going to talk about that right over here. Anyway, so you know all of them has a bad effect. This is not something that you can mug up. You have to remember, like, general thing. Affects your nervous system, affects your body in some other way, affects the fetus if at all you're pregnant, and things like that. Now, coming to the major topic from where you get questions. Anabolic steroids. So these are going to be things which are taken by sports people, men and female, women, which increases their performance. But you definitely have some side effects. Female body, in the female body, the side effects that is there, side effect based questions come. In female body, what are the side effects? Masculinization. You will have a masculine body in the females. Mood swings, depression, irregular periods, excessive hair, deep voice. So what I do is, to remember things very, very easily, think of all the masculine features together. In the case of females, they will have masculinization, which is why they will have a deep voice. They will have excessive hair on their body, because all of these features are coming somewhere under masculinity, right? Yes. Now, the next set of things that is generally there, mood swings, depression will be there, and irregular periods. Obviously, if at all you are taking in something, it is going to have some change in your hormones and all. You will be having depression, you will be having mood swings, you will be having irregular periods also. Right. These are the side effects that you see in the case of females. What about the males? Males are the same thing that we can find as mood swings and depression. Mood swing and depression. Apart from it, they might have a lot of acne because of the hormone change and stuff like that. And majorly, it reduces their testicular size, and because of that, they will have low sperm count. They will have low sperm count. They can have prostate issues also. Prostate gland, you remember, which helps in providing calcium and enzyme to the sperms. They might have issues with the prostate glands. They might have baldness also, a lot of problem. So the men, they do not have feminine character, rather, okay, they are losing a lot of their masculine things out there. Okay, so they are usually hairy, but here they will be having baldness, they will be having acne, they will be having mood swing, depression. Apart from that, majorly, testicle size is going to be reduced, prostate glands are going to be affected, low sperm count is going to be there in the case of males. In adolescence, basically severe acne will be there, stunted growth, you will not find too much height, and premature closure of the bones. Your bones and all might not be developing very, very well. Cool. this and this is something that is being asked most of the times, and this is something that we should not be missing out. So I'm just going to hide it and we're going to talk about it. Females, all the feminine character, just remember, periods but irregular periods, which is by mood swings and which is by depression. Okay. Next thing that we have is basically masculinization of the body, deep voice, hairy, more hair. Okay, female done. What about males? In the males, talk about all the male part, low testicular size, which is why testicular size reduces, low sperm count, which is why basically we can say prostate gland is also being affected. Okay, mood swing and depression, common. Apart from that, acne will be there. Okay, adolescents, they will be having premature closure of their bones, they will be having severe acne, they will also have mood swings and stuff like that. This is the problems that is caused by anabolic steroids, which sports people use basically for enhancing their performance. Muscularization in female is the single most repeated steroid fact that is being asked, and cirrhosis of the liver is a keyword. Please remember, if you have too much of alcohol, it can lead to cirrhosis in the liver. Done. Now, one of the side effects of the use of anabolic steroids in female is cirrhosis of liver, loss of memory, muscularization, hallucination. What do you think is the answer? In the females, it is going to be muscularization. Remember, that's all. This is a PYQ of 2022. And by the way, we have completed the whole of the chapter. But before I go, I just want to tell one thing, that we have to go to our NCERT. Where is it? NCERT. You can go check it out. We have completed everything. Okay? So this is what I'm talking about. Dependence is a tendency of the body to manifest a character and an unpleasant withdrawal syndrome if regular dose of the drug is not being given. This is something that can be seen. Okay. Now over here, there are few things that you should be knowing, as in what are the way prevention and control in the case of drug abuse and things like that. So please know these points. Avoid undue peer pressure. Your friends might be doing things, but please, not because you know, I had my friends who used to say that I'll do this because they will be making fun of me. Don't do that. Let them make fun of you. Who cares, guys? You're Gen Zs. You're not being affected by stupid things out there. Let them do whatever they want. Do what you feel like and what is right. Okay, so avoid undue peer pressure. That is more cool. So every child has his own choice and personality, which should be respected and nurtured. A child should not be pushed unduly to perform beyond his or her threshold limits, be it studies, sports, or other activities. So avoid undue peer pressure. This is for you, and this is for the parents who tell that that you have to be like them, like this guy. And next is education and counseling. For people who feel that, okay, so you know your friends or you know yourself, you're not feeling fine, you should be going and talking to some people. You have to face our problems and understand it. Okay? And the parents should be supportive as well. So educating and counseling him or her to face the problems and stresses and accept disappointments and failures as a part of life. It would be worthwhile to channelize the child's energy into healthy pursuits like sports, reading, and you should be channelizing all your energy into that rather than taking drugs because I'm depressed. Does not make sense. So education and counseling is very important. Seeking help from parents and peers. My dear children, I'm telling you, we all have been through the same age. Okay, we know things, what happens. I'll request you to make sure that please do not be scared to seek help. The people who seek help are very, very courageous. They have the courage to talk about their issues. So if you have any issues, please talk to your friends, please talk to your family regarding it. There will be some point, some solution. You know what? Whenever I face a problem, it's not like one person, I go to one person. Obviously, I go to one person and speak about it. But if I don't find my solution, I take suggestion from multiple people. And while you grow, you realize that it's okay to do so. It's okay to do so. And I'm telling you, it's not like you're going to be judged and things like that. If you need help, talk about it. So help from parents and peers should be sought immediately so that they can guide appropriately. Help may be sought from close and trusted friends also. You can talk to your friends also. Yeah. Besides getting proper advice to sort out their problems, this would help young to vent their feelings or anxiety and guilt. So yes, venting is very important. Next thing, looking for danger signs. Alert parents and teachers need to identify the danger signs discussed above, even friends if they find someone using drug and alcohol. So if you see that someone else is using drug and alcohol, please report. Don't think that that's my friend, he or she will be caught. No, does not help. Does not help. Please go and report. Because, my dear children, there will be other people talking to them and they can help them out. You know, when I was in Unacademy, I had found students basically using vape and stuff like that. First of all, I was very sad, but then I spoke to them. Okay, I spoke to them that this is what I know right now. Other teachers got them actually, and it came to me to talk to them, and I spoke to them. This is how it works. This is generally thing. And my dear children, it's not like you will be crucified or you're going to be dead on point for doing something like that. No. But it's very important to come out of it. Otherwise, you're going to be in a loop. And from that loop, to come out of that loop, it's very, very difficult. It's going to be hampering a lot of your decisions in your life. So never, never do that. So please identify your danger signs. Talk to your, if there is a friend doing something, please go talk about it to them and also report it. Seeking professional medical help wherever needed. So some things can be sorted by a psychologist. Something needs a psychiatrist. Okay, if at all you feel that there are some wounds which cannot be spoken about, do not turn to drugs rather than turn to people and talk about it. As I said, seek professional help. So these are few things that is there. So first thing that we have is basically avoid undue peer pressure. This is for parents and also for you. Education and counseling. Second thing, seeking help from parents and peers. Looking for danger signs and seeking professional and medical help. Those are the few steps that we can be taking. This question usually does not come. This is not a question-based thing that I'm explaining over here. I'm trying to tell you what is important and what as a teacher I must say. So that's all. I hope that you had loved this particular session. If you did, definitely do not forget to hit the subscribe button. And if you have any doubts around anything, put it down in the comment section. And if you love the class, put it down in the comment section. I would love to know that. So take care. See you soon with a new chapter up there. Thank you so much. Lots of love. Bye-bye. Take care, sweeties.